menggunakan ilmu dan teknologi silviculture untuk menjamin fungsi ekologis, kesehatan, dan produktivitas hutan sesuai kebutuhan dan nilai-nilai hutan yang diinginkan secara berkelanjutan. Departemen Silviculture IPB memiliki bidang kajian yang luas, menarik, dan aplikatif, sehingga dalam pelaksanaannya, Departemen Silviculture IPB dibagi dalam 3 kajian divisi, diantaranya Divisi Ekologi, Divisi Silviculture, dan Divisi Perlindungan Hutan. Bidang kajian ekologi hutan meliputi hutan mangrove, hutan rawa gambut, hutan dataran rendah, hutan pegunungan, ekosistem das, tanah hutan, nutrisi hutan, restorasi hutan, reklamasi lahan pasca tambang, biodiversitas, botani hutan, dan lainnya. Bidang kajian silviculture meliputi genetika dan molekuler hutan, perbenihan dan persemaian, sistem silviculture, agroforestry, permudahan hutan, mikoriza, rhizobium, bioteknologi kehutanan, reklamasi pasca tambang, biodiversitas, dan lainnya. Bidang kajian perlindungan hutan meliputi patologi hutan, entomologi hutan, jamur hutan, mikrobiologi hutan, hama penyakit hutan, kebakaran hutan dan lahan, kesehatan hutan, gangguan hutan, perubahan iklim, biodiversitas, dan lainnya.
Tertarik dengan flora fauna yang ada di hutan?
Senang berpetualang ke alam bebas?
Atau ingin turut andil dalam melestarikan hutan di Indonesia?
Fakultas Kehutanan dan Lingkungan IPB University bisa menjadi pilihan yang tepat
Untuk kamu. Fakultas Kehutanan dan Lingkungan IPB University memiliki 4 program studi yang pastinya sangat keren. Pertama, manajemen hutan. Di sini, kamu akan mempelajari cara mengolah hutan dari mulai membuat perencanaan, kebijakan, hingga cara memanen hasil hutan secara lestari, baik kayu maupun non-kayu.
Kedua, hasil hutan.
Beragam hal bisa kamu pelajari di sini, seperti pemanfaatan hasil hutan dengan baik agar bernilai jual tinggi, dan cara memaksimalkan produk kayu dan non-kayu dengan teknologi yang canggih dan modern.
Ketiga, konservasi sumber daya hutan dan ekowisata. Sesuai dengan namanya, kamu akan mempelajari flora fauna dan konservasi sumber daya yang ada di hutan, serta pengelolaan suatu ekosistem agar dapat dikembangkan dari sisi ekowisata.
Terakhir, silviculture.
Pada program studi yang dikenal dengan sebutan dokternya hutan, kamu akan belajar tentang cara budidaya bibit pohon agar menjadi unggul, serta belajar tentang rekayasa genetika dan perkembangan jenis-jenis pohon.
Untuk mendukung proses pembelajaran, Fakultas Kehutanan dan Lingkungan IPB University memiliki beragam fasilitas yang sangat lengkap. Seperti hutan arboretum, workshop Departemen Hasil Hutan, rumah kaca, penangkaran rusa, hutan pendidikan Gunung Walat, perpustakaan, taman hutan kampus, persemaian permanen, dan beragam laboratorium yang pastinya sangat lengkap.
Gak cuma itu, Fakultas Kehutanan dan Lingkungan IPB University sudah terakreditasi A dan internasional.
Fakultas Kehutanan dan Lingkungan IPB University didukung dengan pengajar yang berkualitas.
Ada juga kegiatan unggulan yang dilaksanakan seperti praktik lapang kehutanan, di mana mahasiswa mempelajari secara langsung berbagai macam ekosistem di hutan, dari mulai hutan pantai hingga hutan dataran tinggi.
Tidak hanya aktif di perkuliahan, kamu juga bisa aktif dalam himpunan profesi dari masing-masing program studi, seperti Forest Management Students Club, Himpunan Mahasiswa Hasil Hutan, Himpunan Mahasiswa Konservasi Sumber Daya Hutan dan Ekowisata, juga Tree Grower Community.
Fakultas Kehutanan dan Lingkungan IPB University berhasil mencetak beragam alumni sukses. Berikut beberapa alumni sukses dari Fakultas Kehutanan dan Lingkungan IPB University.
Bagaimana?
Sudah siap menjadi rimbawan Indonesia?
Ayo gabung bersama IPB University.
Indonesia terletak di lintasan garis khatulistiwa yang membentang dari Sumatera, Kalimantan, hingga Papua. Keindahan alam Indonesia yang terdiri dari pesisir pantai, gugusan pulau-pulau, barisan pegunungan, dan hijaunya hutan belantara menjadikan Indonesia disebut sebagai Jamrut Khatulistiwa. Keragaman hutan Indonesia merupakan rumah bagi berbagai kehidupan yang ada di dalamnya.
Hutan perkasa yang dulu menyelimuti pulau-pulau ini sebagian besar telah hilang. Tinggallah bentangan hutan utuh di Papua sebagai pemilik hutan terakhir di negeri ini. Saat ini, hutan digunduli sejumlah besar gas rumah kaca yang dilepas ke udara, dan dengan demikian mendorong kita lebih cepat ke titik di mana kita tidak bisa kembali ke dampak perubahan iklim.
Selamat datang di Departemen Silviculture, Fakultas Kehutanan dan Lingkungan IPB University. Departemen Silviculture IPB berdiri pada tahun 2005 yang sebelumnya berada di Divisi Budidaya Hutan, Departemen Manajemen Hutan, Fakultas Kehutanan IPB. Pada tahun 2013, Departemen Silviculture meraih akreditasi A dari Badan Akreditasi Nasional Perguruan Tinggi serta memperoleh sertifikat ASEAN Quality Network Assurance pada tahun 2015. Pada tahun 2016, Departemen Silviculture IPB dan departemen lainnya di Fakultas Kehutanan IPB bersama-sama menerima sertifikat SNI ISO. Departemen Silviculture IPB memiliki fungsi menjadikan Departemen Silviculture sebagai program studi terkemuka dengan kompetensi utama silviculture tropika berkarakter kewirausahaan dan bersendikan keharmonisan. Departemen Silviculture IPB memiliki misi yaitu menyelenggarakan pendidikan tinggi yang berkualitas berbasis penelitian untuk menghasilkan sumber daya manusia yang berkualitas dan untuk menjamin fungsi ekologis, kesehatan, dan produktivitas ekosistem hutan secara berkelanjutan sehingga menjadikan Departemen Silviculture yang berperan sebagai trendsetter bagi masyarakat profesi kehutanan. Departemen Silviculture IPB menjadi lembaga pendidikan tinggi yang mampu mengantisipasi dan menjawab berbagai permasalahan pembangunan kehutanan secara ilmiah dan profesional dengan sistem manajemen berorientasi pada mutu dan profesionalisme. Departemen Silviculture IPB memiliki mandat dan pengembangan ilmu dan teknologi silviculture yang diperlukan untuk membina hutan alam serta membangun dan membina hutan tanaman secara berkelanjutan berbasis ekosistem. Kompetensi di Departemen Silviculture IPB mampu menyerapkan ilmu dan teknologi silviculture untuk menjamin fungsi ekologis, kesehatan, dan produktivitas hutan sesuai kebutuhan dan nilai-nilai hutan yang diinginkan secara berkelanjutan. Departemen Silviculture IPB memiliki bidang kajian yang luas, menarik, dan aplikatif, sehingga dalam pelaksanaannya, Departemen Silviculture IPB dibagi dalam 3 kajian divisi, diantaranya Divisi Ekologi, Divisi Silviculture, dan Divisi Perlindungan Hutan. Bidang kajian ekologi hutan meliputi hutan mangrove, hutan rawa gambut, hutan dataran rendah, hutan pegunungan, ekosistem das, tanah hutan, nutrisi hutan, restorasi hutan, reklamasi lahan pasca tambang, biodiversitas, botani hutan, dan lainnya. Bidang kajian silviculture meliputi genetika dan molekuler hutan, perbenihan dan persemaian, sistem silviculture, agroforestry, permudahan hutan, mikoriza, rhizobium, bioteknologi kehutanan, reklamasi pasca tambang, biodiversitas, dan lainnya. Bidang kajian perlindungan hutan meliputi patologi hutan, entomologi hutan, jamur hutan, mikrobiologi hutan, hama penyakit hutan, kebakaran hutan dan lahan, kesehatan hutan, gangguan hutan, perubahan iklim, biodiversitas, dan lainnya. Fasilitas yang ada di Departemen Silviculture meliputi laboratorium, ruang kuliah, rumah kaca, dan persemaian. Program Sarjana Silviculture akan meraih gelar Sarjana Kehutanan, program Pasca Sarjana Silviculture Tropika akan meraih gelar Magister Sains dan program Strata 3 akan meraih gelar Doktor. Berbagai inovasi telah diberikan oleh Departemen Silviculture yang diantaranya sudah dipatenkan. Jejaring kerjasama internasional Departemen Silviculture meliputi sebagai berikut. Jejaring kerjasama silviculture yang ada di dalam negeri sebagai berikut. Peluang kerja Departemen Silviculture tercatat bekerja di berbagai bidang meliputi. Selain aktif di kampus, mahasiswa Departemen Silviculture IPB juga aktif dalam himpunannya dengan berbagai program kegiatan yang dilakukan pada setiap tahunnya untuk meningkatkan soft skill, keterampilan, kreativitas, dan hobi. Beberapa kegiatan tahunan yang dilakukan mahasiswa Departemen Silviculture meliputi ekspedisi flora dan studi ilmiah, TGC in Action, dan aksi mangrove. Departemen Silviculture IPB membangun kejayaan hutan untuk kebanggaan dan kesejahteraan bangsa.
Ladies and gentlemen, the opening ceremony Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Honorable Rector of IPB University, Professor Arif Satria, Honorable Dean of Faculty of Forestry and Environment IPB University, Dr. Nareswara Nugroho, Honorable Vice Dean for Academic and Student Affairs Faculty of Forestry and Environment IPB University, Dr. Nurfarika Haneda, Honorable Vice Dean for Resources, Cooperation and Development, Faculty of Forestry and Environment IPB University, Dr. Nandi Kosmariandi, Honorable Director of International Collaboration Office IPB University, Professor Iskandar Zulkarnain Siregar, Honorable Head of Departments from Faculty of Forestry and Environment IPB University, our honorable keynote speakers, Professor Marco Poren, Professor Rapid Loner, Professor Hiromi Mizunaga, and Dr. Agus Yustianto. Our honorable invited speakers, Professor Iskandar Zulkarnain Siregar, Professor Bambang Hero Saharjo, Professor Iin Handayani, Professor Muhammad Azani Alias, Dr. Hiroshi Hayasaka, Dr. Sonia Dewi, Dr. Donald Mead, Dr. Supriyanto, Dr. Surono, and Dr. Marinus, and also distinguished oral and poster presenters and all participants. Good morning from Indonesia, ladies. You to the third international seminar on Conference Tropical Silviculture 2021 or ICTS 2021 with the theme Inspiring Silviculture, Innovation and Research in Achieving Sustainable Development Goals. This event is organized by Department of Silviculture, Faculty of Forestry and Environment IPB University, and supported by International Collaboration Office IPB University. My name is Ati Dinur Hayati, and I will be your Master of Ceremony today. First of all, I would like to thank everyone here for attending to this event. On this special morning, we have several agendas as follows. The first is opening ceremony and photo session. The second is plenary session. The third is parallel presentation session 1. Then we will have an hour for break time. And we continue with the parallel presentation session 2 and 3. And the last is closing. Okay, distinguished participants, ladies and gentlemen, to open the international seminar, we will listen to National Anthem of Indonesia, Indonesia Raya.
Indonesia
and gentlemen, the next agenda is Moment of Prayer that will be led by Dr. Alam Firmansyah. To Dr. Alam, please, time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, let us bow our head for a moment. Pray to God Allah Subhanahu wa Ta'ala so that our international conference can be prestigious to all of us. I will let this pray based on Islam. Let us start with reciting Basmalah. Bismillahirrahmanirrahim. And Al-Fatihah. Al-Fatihah. Auzubillahiminasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirrabbilalamin. Ar-Rahmanirrahim. Maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Auzubillahiminasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirrabbilalamin. Hamdan yuafi ni'mahu wa yukafi mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhika wa azimi sultanik. Allahumma sholli ala sayyidina Muhammad fil awwalin wal akhirin. Allahumma inna nas'aluka salamatan fid din wa afiatan fil jasad wa ziyaratan fil ilm wa barakatan fil rizq wa taubatan qoblal maut wa rahmatan 'indal maut wa maghfiratan ba'dal maut. Allahumma fir lana wa li walidaina walil muslimin wal muslimat wal mu'minin wal mu'minat wal ahya'i minhum wal amwat innaka samiun qaribu mujibu da'wat wa ya qadiyal hajat. Oh Allah, today Tuesday, August 24th, 2021, in this beautiful place we gather here to bring about a third international conference on tropical silviculture 2021. The theme is inspiring silviculture innovation and research in achieving sustainable development goals. Make this international conference as a useful science assembly, as a medium of sharing useful ideas, knowledge, and experiences of scholars, researchers, and students of various disciplines. May the conference we organize today benefit to our life, broaden our knowledge, shine our ideas, and let us to be successful, productive person, which in turn will boost dignity of our nation. Oh Allah, guide and bless our heart and our minds with the light of your guidance. Impart your supreme wisdom upon our activity. Help us to speak our mind clearly. Help us to listen to each other, respect each other, love each other so that we are included to the blessed person. Oh Allah, protect us from unintended temptation. Show us the right path and give us knowledge and strength to perform good things equally. Show us and make it clear the bad things and give us knowledge and strength to avoid them. Oh Allah, you are the one who can fulfill our dua. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Subhana rabbika rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Alam. Distinguished participants, ladies and gentlemen, step on to the following agenda is speeches. We are pleased to invite the chairman of organizing committee to deliver a brief report of ICTS 2021. To Dr. Priyanto Pamungkas, please, time is yours.
And all participants. On behalf of the organizing committee, welcome to all 2021. It is a great pleasure to welcome eminent scientists, researchers, and practitioners gathered here in the conference. Tropical rainforest is known as one of the mega biodiversity and most versatile renewable resources in providing economic, environmental, and social benefit. Therefore, the principle of sustainable forest management should be implemented in the management of our forest. Recently, management paradigm is changing from forest management that came to timber production became to forest management that consider the ecosystem of the services, or so-called from the era of the exploitative forestry to extensive or intensive forestry, and finally to the era of the precision forestry. Ladies and gentlemen, the aim of this conference are to disseminate the result of research and innovation in the scope of tropical silviculture. This conference is involving 5 keynote speakers from Indonesia, Malaysia, Japan, Germany, and United States of America. 11 invited speakers coming from Indonesia, Malaysia, Japan, United States of America, and New Zealand. There are on about 111 participants as oral and poster presenters, and as 8 aspect of theme, namely biodiversity, forest fire and climate change, non-timber forest product, agroforestry and forest plantation, uneven aids, silviculture, ecosystem services, and forest degradation and rehabilitation. And also we discuss about the forest biomass energy. Ladies and gentlemen, on behalf of the organizing committee, I would like to thank Pak Rektor IPB University, Pak Dekan of Faculty of Forestry and Environment IPB University, and the head of Silviculture Department of IPB University in supporting to the conference. And finally, I would like to thank all members of the organizing committee for all hard work and dedication as shown today. Wassalamualaikum warahmatullahi wabarakatuh. Thank you very much.
Ya, Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Priyanto, for the brief report of ICTS. The next agenda is welcome remark that will be delivered by Dean Faculty of Forestry and Environment IPB University. Please welcome Dr. Nareswara Nugroho. The time is yours.
Okay, thank you, Serati. Can you hear me? My voice is clear?
Yes, I can hear you.
Okay, thank you. Bismillahirrahmanirrahim. The Honorable Rector of IPB University, Professor Dr. Arif Satria, the Honorable Vice Dean, Faculty of Forestry and Environment, IPB University, the Honorable Head of Department of Silviculture, Faculty of Forestry and Environment, IPB University, the Honorable Keynote Speakers, invited speakers, and official committee of ICTS 2021, oral and poster presenters, as well as all participants of ICTS 2021, whom I respect. Ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Good morning, selamat pagi, ohayo gozaimasu. First of all, let us praise to Almighty Allah Subhanahu wa Ta'ala, the most loving and the most merciful, for His blessing that enable us to be present in this very important event today using online or virtual mode via Zoom. We are delighted to welcome you to the 3rd International Conference on Tropical Silviculture, ICTS 2021, to be held from IPB University Bogor, Indonesia on 24th August 2021. Forest and ecosystem unity with much of natural resources richness inside should be managed sustainably. Forests give us both tangible and intangible benefits, such as wood, non-timber forest product, fruit, flowers, animal, for protein resources, as well as ecosystem services that are important to our life. Unfortunately, according to Forest Watch Indonesia, the natural forested cover area in Indonesia is around 82 million hectare, or only 46% of the terrestrial weight of Indonesia, and 62% of total forested area. The loss of forested cover area in Indonesia is caused by many factors, such as forest fire, illegal logging, forest conversion, agriculture, palm oil industry, expansion, as well as exploration and exploitation of forest area related to mining industry. Forest degradation in Indonesia significantly impacts toward the increment of carbon dioxide emission, climate change, and the loss of biodiversity, both flora and fauna. Therefore, forest degradation is able to remove the forest ecosystem function too. Forest ecosystem function refer to the forest ability on its naturally process to provide both product or service benefit to meet human needs. Silviculture science and technology plays important role on the sustainably forest management, which is assuring three principal aspects such as ecology, economy, and social. Ladies and gentlemen, the third International Conference on Tropical Silviculture is biennial internationally conference on the field of tropical silviculture, as well as forest and environment, organized by Department of Silviculture, Faculty of Forestry and Environment, IPB University. Especially on this year, the International appoints an interesting theme, namely inspiring silviculture, innovation and research, achieving sustainable development goals. The implementation of the ICTS 2021 is expected to disseminate research and innovation on tropical silviculture for sustainably forest development, as well as to strengthen and improve Indonesian silviculturist rules and the research, innovation, development, and forest management policy in Indonesia. Distinguished guests, ladies and gentlemen, unfortunately, ICTS 2021 should be held virtually due to the COVID-19 pandemic circumstance. Nevertheless, I believe that ICTS 2021 will be going well. Through this event, I hope that we are able to unite our spirit and to strengthen each other. Let's work together to save forest ecosystem and to create the better life for our future. In this occasion, on behalf of the Department of Silviculture, the faculty, and the committee, we are inviting Director of IPB University, Professor Arif Satria, to open this conference officially. Thank you very much for your participation and your kind attention. Have a nice experiences with the third International Conference on Tropical Silviculture. I wish you have a fruitful meeting and discussion and achieve the goals of the conference successfully. Billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh. Thank you.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Nares, for the speech. Distinguished participants, ladies and gentlemen, the next agenda is the opening remarks from Rector of IPB University that also will officially open this conference. Please welcome Professor Arif Satria. The time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen, and good evening for the speaker from USA. Honorable keynote speakers and invited speakers from Indonesia, USA, Japan, Germany, Malaysia, and New Zealand, the Honorable Dean of Faculty of Forestry and Environment, IB University, Honorable Head of Department of Silviculture, and distinguished guest participants and organizing committee of the third ICTS 2021. Ladies and gentlemen, firstly, on behalf of IB University, allow me to this opportunity to welcome all of you to the virtual conference of the third International Conference on Tropical Silviculture, with the theme inspiring silviculture innovation and research in achieving sustainable development goals. By first praying our gratitude and praise to the Almighty God for the blessing, grace, mercies that have made us possible to gather here in excellent condition and health. Ladies and gentlemen, on this occasion, I should like to advise that the importance of the forest for the well-being of people and the planet is very, very clear. People worldwide depend directly on forests for food, shelter, energy, and income. So forests can also be said as a key resource in achieving sustainable development goals. Sustainably managed forests are crucial for eradicating poverty, combating climate change, conserving biodiversity, protecting watersheds, and building food and energy security. And forests support, forests support the livelihoods of some most vulnerable segment of society, especially the rural, poor and indigenous people. However, the world's forests today facing many challenges, include the effect of changing climate, rapid development and competing land use, worsening fire seasons, and epidemics of forest pests and diseases. Therefore, we must consider appropriate strategies to cope with these challenges. One of them is an advanced and innovative silvicultural technique or practical approach, as all theories and practice of silviculture could be applied in controlling the establishment, composition, health quality, and growth of forests to meet diverse needs and values, as well as making an improved and sustainable forestry, which is more socially acceptable, more economically viable, and more ecologically sound than what we have today. Here we can understand that silviculture science play a very important role in sustainable forest management through ensuring the sustainability of forest ecosystem functions and increasing positive impact towards socioeconomic in maintaining and improving forest productivity, as well as in achieving sustainable development. And silviculture science and technology, therefore, plays important role on the sustainable forest management, which is assuring three principal aspects of such as ecology, economy, and social. Dear participants, ladies and gentlemen, as the leading university in Indonesia, IPB University has put the sustainable forest management as one of our concerns. We always encourage all of the parties to maintain the sustainability of forests for better life and living and of mankind. All of this effort has escalated the position of IPB University among the best world university. Recently, IPB University is ranked number 62 on QS World University Ranking for the subject of forestry and agriculture. It should be pointed out that the conference is held mainly due to our concern on the need of further research, sharing and dissemination of research report on silviculture science, innovation, and technology among stakeholders. It is hoped that this conference with the proposed theme can strengthen and enhance the role of Indonesian and global silviculturists to inspire the development of research, innovation, and forest management policies, not only in the tropics, but also worldwide. Thus, the workshop's goals to bring together researchers of the world working on silviculture science, innovation, and technology to exchange results and ideas. It's really match our philosophy on inspiring innovation with integrity in agriculture, ocean, and bioscience for sustainable world. I believe this conference will provide multiple opportunities to engage on a number of issues that have relevance for the issue and help you take action. My hope is that you will take full advantage of this conference, which is designed also as one of a kind of knowledge sharing and networking opportunity. I appreciate Department of Silviculture, Faculty of Forestry and Environment, IPB University, organizing this international conference. Hopefully this event will significantly give more contribution to the study program as well as to the scientific community engaged in silviculture and forestry. In conclusion, I should be wishing you all every success in your work. I wish you all a fruitful conference. By saying Bismillahirrahmanirrahim, may Allah provide His bless for this workshop. I officially open the third ICTS 2021. Enjoy the scientific atmosphere of the conference. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for the speech from Rector of IPB University, Professor Arif Satria. Ladies and gentlemen, before we continue the next agenda, We would like to invite all participants to join the photo session. Kindly please turn on your video cameras for a moment, and to the committee, please help to take a photo on my count. Okay, we have 5 slides. The first slide, 1, 2, 3. The second slide, 1, 2, 3. The third slide. Okay, 1, 2, 3. The fourth slide. 1, 2, 3. And the last slide. 1, 2, 3. Okay, thank you. Distinguished participants, ladies and gentlemen, the next agenda is the plenary session. In the session, there are 5 keynote speakers coming from 5 countries and will be moderated by Dr. Ulfa Juniarti from IPB University. So please allow me to read short CV from Dr. Ulfa. Dr. Ulfa Juniarti is Associate Professor at Department Silviculture, Faculty of Forestry and Environment, IPB University. She got her PhD at Kyoto University, Japan. At present, she also serves as Senior Affiliate Scientist at Simio Biotrop. Her research interests mainly are forest genetics, genomics, tree improvement, and biotechnology. Also metagenomics of microalgae. She is also interested in climate change and development of forest-based bioenergy. Now, we would like to invite Dr. Ulfa Juniarti. Please, time is yours.
Assalamualaikum. Assalamualaikum.
Waalaikumsalam.
Assalamualaikum warahmatullahi wabarakatuh. And very good morning here in Indonesia to all participants. Maybe some participant or one of our plenary speaker from United States, maybe now it's night time there. So I would like to have a good night. No, not really good night. So have a good evening to the participant. I will be chair this plenary session, and there are 6 speaker from this session. The first one is from Professor Mark A. Cochrane from University of Maryland, Center for Environmental Science, United States. I want to check whether Professor Cochrane is already joined this Zoom.
Yes, I'm here.
Oh, okay. I'm glad. Thank you. So, Professor Mike Cochrane will deliver his speech on monitoring large-scale carbon loss from Indonesia peatlands and the effectiveness of mitigation efforts. I will just read the short CV of Professor Mark Cochrane. He got a PhD in ecology from Pennsylvania State University in 1998, I believe, and then he served as a professor at University of Maryland since 2017. Professor at the Appalachian Laboratory Center for Environmental Science, University of Maryland. The area of expertise of Professor Cochrane is wildland fire, climate change, earth system science, disturbance ecology, land cover change, and remote sensing. Professor Cochrane conduct interdisciplinary work combining ecology, remote sensing, and other fields of study to provide an earth system perspective of the dynamic process involved in global change. So I would like to welcome Professor Cochrane to give his presentation in this plenary for 20 minutes. 20 minutes. So time is yours.
Okay. Well, thank you, everybody. Moving so long, I'm happy to be here. It's the middle, getting late for me here. So how this works? Do I say next or do I share my screen? So next slide. Or, okay, yeah. So yeah, I look at a lot of wildfire and how it's affected forests in Indonesia. But the question is why? Why would we be here in Indonesia? And as talking in Indonesia, this is not a unusual idea, but for many people in the world, it's really strange. Why would we talk about fire in a tropical country in Indonesia as one of the largest emitters of carbon, at least in some years? And it's they're surprised to hear that in some years Indonesia might be as high as the third largest CO2 emitter, and for most countries it's all about the fossil fuels. But for some of the tropical countries like Indonesia and Brazil, a large part of those emissions are from land cover change, or in the case of Indonesia, after the land cover change, the burning in peat swamps. And so the peat itself is being consumed and ends up releasing a huge amount of carbon. And so while this is in its own way a problem, a major issue, it is also a great opportunity in that most of these emissions are not desired. Nobody really wants them. So we have a real opportunity here to do mitigation and reduce the amount of carbon being released, which globally would be important, and for Indonesia, very important, and in a way that would probably help the health of many millions of people. So that is why we're here. Next. Next slide. Am I controlling this or is somebody else controlling this? There we go. Okay. So when we started studying these questions, the whole purpose was to try to help Indonesia create a so-called MRV, measurement, reporting, verification system for its people. Because if we're going to have credit for managing things well, we need a way of measuring how much carbon is coming off of those sites now, and a way of estimating how much might have been preserved through other types of activities. Whoops, but we'll get there. But what we've had to do is, first, how would you do this? Well, you have to be able to detect those fires. You have to know where it is. You have to be able to map where the fires have happened. You have to be able to estimate how much peat has been consumed by those fires, so the volume. So we need to get to the depth. And we need to know, well, when you burn it, what comes out of it? It's not just carbon. There's a lot of other things. All of those things, if we understand that, provides a baseline that would allow us to then try to assess the effectiveness of any kind of mitigation activities like rewetting peatlands. Next. And what we're trying to do is just, do a simple algebra equation where we can take the amount of area burned, the amount of fuel that got burned up, and what it got turned into, and all of that equates to the total emissions. So for most of the world, it's all about the above ground change. So when you deforest an area, remove that vegetation, it's easy to figure out. But for the peatlands, it's what's happening below that is the major part. So when we try to figure out where did it burn, we have to be able to, map that. Well, there are many satellite products out there that have, purportedly can show us burned area around the world, but these products haven't really been tested in places like Indonesia. They're really good in some places, but people use them globally without being critical about how they are. And so with Yeni Vitrita, we've tried to actually assess how good are these products at measuring the burned area within Indonesia. Next. So, to do that, we have to be able to look at an area that they say burned and an area we know burned. So what we were able to do is use higher resolution imagery that we could actually verify on the ground, and we know it burned, and then we see if those other global products actually can find those fires, or if they detect fires that aren't there, for example. And basically what we were able to assess is the fact that even the best products are missing at least half of the fires. And that was in a year that wasn't like 2015. This is a moderate year. And in the areas out of the peatlands, surprisingly, they were doing even worse. So they're missing 60%. And the reason there is the fires off of the peatlands tend to be much smaller. So on the peatland, they tend to be rather cool because they're in peat, and they tend to be very smoky, so you can't see them. Off of the peat, they tend to be smaller and therefore below the energy level that these instruments usually can detect. You're looking at either a square kilometer or maybe 500 meter. So there's a problem there. We're not seeing many of the fires that are actually happening. Next, please. Still, even though we're only seeing maybe half of the burning, what we were able to find when we look over a long time span is that there's a lot of burning. All through the peatlands of Sumatra and Kalimantan, and increasingly in Papua as well. We have way more fire than we would expect for these forests. They shouldn't have hardly any fire, if any. The amount of burning is not even every year. We have it in most years. The El Nino years, when we tend to have more extended droughts, definitely have the most burning. That is most pronounced in Kalimantan, less so in Sumatra. But when we look at peat versus non-peat, where the fires are happening, given the amount of peat, it's 5 times more likely to be having fire in these peatlands than it is on the non-peat. So the peatland have a particular problem. Next, please. So everywhere what we're finding is it's burning way more than these forests can survive. It's burning and burning repeatedly. And so what we see is that wherever fires have happened, not too surprisingly, every time you see more fire, there's much more likelihood that you don't have a forest or even a degraded forest there. We're going into non-forest, and those forests are not able to recover because we're burning over and over again. Every time any forest tries to regrow, it tends to get burnt. So we have a problem. We have to manage these peatlands differently if we're going to maintain any forest or return any forest. Next, please. So to do this, we've created products where we can, see what's happening and measure it over time. And what we can show is things like here it's 94. I don't know if it'll show on the next one or not, but it basically we've gone from 84% forested in 1994 down to, it was 13% in 2015 and 6% in 2019. So it is almost completely deforested over this large area, which I should say is in Kalimantan. It was part of the Ex-Mega Rice project. So it's been, thousands of kilometers of canals. It's been drained. And so these areas have been burning more and more. And so at this point, 91% of that surface area has been affected by fire. And most of those areas have burned many times, so more than 5, some up to 12 times. So it is incredibly fire-prone landscape, and that's why we have so much emissions. And so here, this map is showing you the multiple fires that happen on the site. So the darker blues had 5 or more, and all of those things that, except for the yellowish ones, have burned at least once. So what you can see is this whole landscape is burning. You can see it concentrates along what those black lines are, the canals. So the canals dry the area, and so it also allows people into those areas, and that is where the majority of the fires are happening, or starting at least. Next, please. So in order to really look at how things are burning or what's happening with these things, we have to be able to measure them in a standardized way. And so we've created methods to do so. So we will go out, we'll find fires, we'll put metal rods in front of them, measure how far away we are from when they get there, how far they've gone beyond those rods at another point in time. We'll also take sampling frames and put them up in front of the fire, measure the topography in front of the fire. After the fire, we'll come back, we'll measure it all again and figure out just how much volume has burned. So ultimately what we're trying to do is figure out how fire behavior is proceeding in these landscapes and figure out just how much carbon, how much peat is being lost in these fires. There are estimates that are all over the board because nobody's actually gone out and measured it in a systematic way. So we have done this, we've created these methods. Next, please. And what we're not just doing it on our own, we're actually trying to train as many people as possible. And we've published this manual with all the methods. We have teams that we try to train various groups around the country so that we can have standardized methods, and hopefully even in other countries that where there's tropical peatland, to actually measure these things in a common way so that we can measure between year to year, place to place, and even country to country, hopefully. So we'll have a better idea of what's happening. Next, please. So the reason, some of this becomes really important is what we find is, okay, most fires we think of happen on the surface, they're flaming, you see the flames. But the peatland fires, the problems are when they burn into the peat itself and they just smolder. So they just glow a little red and they release a huge amount of smoke and all the aerosols. And with Dr. Putra here, he's been able to show that there are some critical levels that we really have to be concerned with. In particular, when the water table depth starts dropping, when it gets below about 20 centimeters, that's when suddenly the amount of fire tends to pick up dramatically. It's also when we tend to start getting fires that are more carbon loss. And so hydrology is going to be key. And this is how this whole system is run. It's all based on water. And that's why in order to use it, they went in and drained it. They put in these canals to help take the water out of the site so it can be used for different purposes. But what that does is it changes that ecosystem. So once you start dropping the water table, you allow oxygen into all of those, all the peat that is now drained, and that allows microbes to start eating the peat itself. And so we're losing carbon right there all the time. Anytime it's exposed to air, we're losing carbon. If it goes low enough, it gets dry enough, that is when it allows fire to get in there and consume that peat very quickly. So this graphic on the upper right, we've been able to model this whole site to show just how much peat there is, how it's distributed. It's vertically exaggerated about 600 times to show you topography, but that is the peat dome in the middle, and that chopped up look is from the canals. And the colors are giving you an idea of how dry they are, how high up they are. And so we can look at, like on the left shows the percentage of peat that is either exposed to air, and by year in October in this case, or is so dry that it could potentially burn. So 2015, 6% of all the peat could burn. The lower right is showing you the distribution of the volume of peat and how deep you have to go to get to that amount. So in fact, a large amount of the peat is too wet to burn, but just that percentage that's in that top 50 centimeters to a meter is at risk, and it is a huge amount of carbon to release. Next, please. So we need to know what's burning. So, we had to understand more about what's happening. So with the canals, they're brought in. You take the vegetation out, that allows the peat to dry and shrink and be exposed to sun. The drainage also allows that peat to condense and compact. And then fire changes how it works, breaks down to smaller particles if it doesn't consume it completely. And it changes the peat bulk density. Next, please. So that's just the amount of carbon per unit volume. Next, please. And so most of all, those emissions are actually from the peat, not the vegetation on top, but from the peat underneath. So that drainage and degradation compacts it. And we need to know this because once this happens, the bulk density increases by up to 40%. That means 40% more carbon per unit volume. So square, cubic meter, 40% more carbon than it was before it started being degraded. So this is important if we're going to estimate how much is being released when we have fires in these sites. Next, please. So, bulk density, carbon per unit volume, higher in the degraded peat than it is in the non-degraded peat. The aerobic decomposition and the depth of burning are going to depend on the water level. So if we can monitor them or model them once we have done so, that will allow us to predict over time and space how much is either being degraded or at least vulnerable. So fires we find, they don't proceed in a nice, even manner. They're usually thought of as going down to a certain depth and burning evenly everywhere. They do not do that. They burn very variably through this area. But another thing is when they burn matters a lot, such that if we look at a site and have fires in August, and then we have the fires go through again in September, the ones in September are going to release 7 times as much carbon as those ones in August because they can burn deeper into the peat. Next, please. So what we've done is gone out there and actually measure what's coming off of these peatlands. Surprisingly, that hadn't really been done. And so we went out and we actually measured the smoke in 2015. Here's in Kalimantan. Next, please. And we've gone on Sumatra on the right. We're still getting the numbers for Sumatra published, but they're similar. But we've done it for Kalimantan and been able to create new emission factors for these areas for Indonesian peat. Next, please. And so here's just some of the sampling we were doing in 2019 over in Riau and Jambi in South Sumatra. And that's just showing you a thermal image, and you can see all those red areas. It is actually burning under our feet. Indra lost some shoes in there. So ultimately, we've been able to actually calculate these emission factors and show how much of which gases, and there's like 80 or more. But the really important ones are those greenhouse gases we hear so much about, the CO2, methane, the nitrous compounds and carbon monoxide. And what we were able to show is that the amount coming off per unit volume is very different than what was being estimated in the IPCC calculations, for example. And so we're trying to get that updated now so that we'll have more accurate numbers. Now, ultimately, we have to be able to measure this. We're trying to do it with modeling from the ground, but we're also trying to do it kind of top down. It'd be nice if we could measure it with satellites. And so what we've been able to do is create methods where we can actually start mapping the smoke plumes coming out of these areas. And the biggest problem we have, not too surprisingly, is clouds. And so separating those two is a problem. But we're able to start pulling that apart, and that allows us to do more estimates. So the next one, please. Where we've been able to actually calculate for these given smoke plumes, depending if we're in peatland or non-peatland, or as we're over time, how dry that is, we can calculate how much aerosols, basically how much carbon and other gases are coming off, depending on the amount of fire, the amount of radiative energy from fire that we can detect, so that we can estimate how much emissions are ongoing at a given point in time or place. And with that, we've been able to show that yes, the draining has caused it to be worse, but the flip side now is that as we re-wet these areas, it can improve. Next, please. And so, ultimately, we got, BRG trying to do mitigation projects. We're trying to re-wet at least 2.5 million hectares of peatlands, and there's more going on beyond that. And we're trying to have methods that, one, we can actually see where that's happening, and help figure out where it's getting wet and whether that change in the hydrology is changing how fire is behaving on that landscape. And next. And so what we're finding now is that yes, we can say definitively that areas where we have the BRG projects in the areas where we have been working, we've had these dip wells in place since well before and during and since. And not only have the canal blockages started to raise water table levels, they've improved over time. So it's not just that they've come up, but they've actually started to come up nearer the canals more so year after year. So that may just be the long-term effects of the blockage that was put in there, but it also may be that peatland is kind of recovering and healing, if you will, and having better hydrology. We know that this is reducing the emissions off of these areas. And so the early indications are that these mitigation projects are being somewhat effective. We're still trying to quantify exactly how effective, how much we can say it's either reduced fire or reduced the depth of burning, but ultimately it's looking very promising. And the last slide is just acknowledgements. So, thank you.
Thank you very much, Professor Cochran. Exactly 20 minutes. That's really difficult to achieve, but you somehow achieve it. So I'm really impressed. Unfortunately, we don't receive questions and discussion in this plenary session. So if you have any questions from the participant, if you have any question, please write it down in the chat room, and probably the organizing committee will forward it to Professor Cochran to get answer later through emails or something like that. Write down your names and emails. Probably Professor Cochran can answer your questions. Thank you very much. Thank you very much. Well, that was very interesting presentation about Indonesia's main problem, yearly problems. Every year we got this problem. So thank you very much again. For the next speaker, I would like to invite Professor Mitloner. I want to check whether Professor Ralph Mitloner is already joining this Zoom meeting. I would like to check. Is Professor Mitloner already joined this room? Not yet. Second speaker is Professor Ralph Mitloner. Is he already joining this room?
Bu Ulfa,
Yeah.
Mitloner is not with us.
Oh, I see.
Yeah, so maybe we can continue to the next speaker.
So in such case, I would like to invite Professor Hiromi Mizunaga from Shizuoka University. Is he already here?
I'm here.
Oh, okay. Thank you very much. So Professor Mizunaga will deliver his speech on feasible multi-age silviculture as complex canopy management for sustainable and high production. Yeah.
Can you hear me?
Yeah.
And can you see my slide? Okay.
Okay. Yeah, I think it's already. So you also have 20 minutes to give your speech. So time is yours, please.
Okay, thanks, Chairman. Selamat pagi, everyone. Nama saya Hiromi Mizunaga.
Wow.
It is very honor for me to be provided the opportunity to have talk here. Today's talk is about function and how to establish complex stand structures or multi-age stand silvicultures. Okay, next. Multi-age silviculture is defined as silviculture to establish or sustain multi-aged structure of stands as be illustrated here. Left two panels have complex and diverse structure than right panel. Multi-age silviculture was known to have not only timber production, but other ecosystem services such as soil protection, biodiversity, water conservation, and so on. It's sometimes referred to close to nature forestry. In this aspect, multi-age silviculture might be well suited to address SDGs. The term is included in this conference. Inverse J-shaped frequency of tree size is a criteria of ideal multi-age silviculture. The inverse J shape with many small trees would represent sustainable provision of resources from a stand well. I said before, the multi-age stand is expected to have diverse ecosystem services. But is it clear from this diagram? I mean, how is the ecosystem services of multi-age stand? I cannot find the answer to the question from this diagram. Leaf distribution or canopy structure plays an interface between silviculture and ecosystem services. Silvicultural operation change the leaf distribution, and canopy structure determine the growth and microclimate. The microclimate in stand affects the ecosystem services written in the gray boxes and biodiversity. In other words, we can manage the ecosystem services by controlling canopy structure. Therefore, to evaluate the ecological contribution of multi-age stand is to find the ecological functions of complex canopy structures. Culture forms complex canopy structure. I will talk two topics today. First, how complex canopy structure cope high production and sustainability. Second, how to transform to complex structured plantation with feasible process. Hardiman found the high positive relationship between complexity of leaf distribution and net primary production. X-axis is the logistic complexity of leaf distribution. Y-axis net primary production. Net primary production increase with the complexity of leaf distribution. Canopy complexity or great heterogeneity of tree size increase net primary production as reported by several studies. Here. Talking on the canopy complexity and production, complementary use, resource use might be keywords. For example, over-yielding. You may know over-yielding, the phenomena that the species mixture enhance the production is explained by the complementary use of species along various vertical strata. While canopy complexity increase light transmittance or penetration. Large light transmittance result well-lit forest floor and provide many safe sites for seedlings. So prove the sustainability. However, high production and well regeneration might be contradicted, because reduction of light interception by canopy might decrease stand production by limiting resource use by canopy. Our understanding of the sharing and use of resources among
how large phenological variation in the canopy for the complex canopy have logic.
Our understanding of the sharing and use of resources among vegetation strata in heterogeneous canopy is limited. Physiological variation along the light gradient probably contribute to enhance production of complex canopy by improving light use efficiency. So, how large phenological variation within canopy is needed for the complex canopy have larger production? may be useful to understand how complex canopy structure cope high production and sustainability. Three coniferous stands in Slovenia here were sampled. The size structure were quite different among three stands from EA, this one, to ST, the inverse J-shaped. IM and ST is multi-age stands. Three-dimensional leaf distribution of stands were estimated by fine scale in small boxes by terrestrial laser scanner. This is the image of the laser scanning. Vertical leaf distribution here is diverse in ST, single selection system stand, while leaves were concentrated around 20 meters in EA with sharp peak. Vertical section of leaf density are shown in right panel. Darker green means higher leaf area density. The complex structure is clearly shown in multi-age stands like the IM and ST, very complex. The horizontal light distribution estimated from the canopy structure was shown in right panel. Bright color showed the bright condition. So multi-age stand, the IM and ST had many well-lit condition. Therefore, complex canopy provide more safe site for seedlings. That's the bright condition made from the complex canopy by making a cluster of foliage. So a suitable regeneration site might be appear in the multi-age stand. Twelve physiological scenario, that is combination of 3 shade tolerance and 4 plasticity class were employed. Shade tolerance was set from 15 to 5 micromole of maximum photosynthesis. That is the range of coniferous species according to Nimitz. For photosynthesis plasticity to relative PPFD, that indicated the slope of this curve, was set, and 3 of them, from minimum to maximum, is in the range of the plasticity within species, according to the Nimitz. And EXC, exceeding, means the larger plasticity beyond the species. So therefore, it corresponds to species mixture. Okay. Then X, very complex diagram, but the X-axis shows the shade tolerance, maximum photosynthesis, and Y-axis showed the daily canopy photosynthesis. Different color means stand type. From left panel to right panel, that means the plasticity decrease from exceeding to minimum. From top to bottom, the panel means June, August, October. Even age stand, that orange color, please focus orange color. Even age stand had advantages in light demanding species here, and lower plasticity, this group, and high solar zenith, like June. Multi-age stand intermediate green one had slightly higher canopy photosynthesis than even aged in shade tolerant and higher plasticity, this group, and the lower solar generous season. Multi-age stand blue one, a single section, had lower canopy photosynthesis than even aged in all combination. But the difference between the orange one and blue one getting to be smaller with plasticity is higher and more shade tolerance. Then for sustainability, more safe site for seedlings will be provided by compressed canopies. It might be one of the causes to sustain stand structure. And for higher production, compressed canopy structure is suitable for shade-tolerant species, suitable for lower solar season, and it requires higher physiological plasticity beyond the species, if possible. So, therefore, in the area with high solar zenith like tropics, species mixture with combination of diverse shade tolerance is required for higher production of multi-age stands. But we have to note the simple combination of species with different shade tolerance does not provide sustainable structure in strict, so we need to consider the arrangement of the strata and species. Then next topic is the transforming from even age monoculture to multi-age stand. Transforming from even age monoculture plantation to multi-age stand is not easy challenge in Japan, maybe also in Southeast Asia. Since national region is generally difficult because of the poverty of advanced seedlings in plantation and being inhibited by vigorous competitive vegetation. Therefore, most of multi-age managed forest in Japan is multi-age plantation that need to plant seedlings in understories. Although the initial stage seedling establishment stage are managed by planting, there are many infeasible cases of multi-age plantations in Japan. This section, I introduced some the failure example, not success example, and then feasible road to transform to complex structure. But time is limited, so I want to skip this second one. These pictures are view of traditional single selection plantation. The forest consists with tree from 1 year old to 200 years old. Stakeholders have small forest, like the less than 2 or 3 hectare forest, but they manage to keep the sustainable forestry before. Stakeholder harvest 1 or 2 trees in a year per hectare and plant 2 or 3 seedlings in the gaps created by each harvested trees. The change in the view and dBH frequency of the forest is shown for 40 years. 40 years before, multi-age stand structure and compressed canopy was clearly seen. However, these forests turn to be simple structure forest at present. Yeah, very simple structure. What happened? Upper panels show the dBH frequency and vertical leaf distribution in plot with keeping harvesting forest. And lower panels showed those in the stand without logging for 40 years. These figures indicate that to sustain the complex structure, adequate harvesting is needed. The less use of forests change the stand structure and decrease complexity. The passive logging activity was due to the reduction of local timber market that was beaten by large wood company and global economy. Horizontal PPFD map is shown with higher in light yellow color. Now this PPFD map is also calculated, estimated by the canopy architecture. Plot 2 create dark forest color and unsuitable regeneration. This example indicates the single selection of plantation is infeasible so far as present, according to the change of economical and social changes. And I want to show a trial for the model forest with group selection for small stakeholders in our university. Since most of stakeholders of forest have only few hectares in this area, we are transforming from even age monoculture plantation to uneven age mixed stand to complicate age structure and diverse species composition. Combining group selection, cutting, and thinning is conducting with 10 years rotation. 25% thinning and group selection with 100 square meter has been conducted in target area. Cypress seedlings, coniferous seedlings are planted in a gap without weeding. Then 100 years after from now, trees from 1 year old to 100 year old and 180 years old tree will be coexisted. We remain the seedlings of broadleaf canopy tree species induce mixed forest. We also maintain snags and CWD for animal habitat. The patch size of group selection, I said 10 meter by 10 meter, was determined using of the application of CanStan and the Canopy Navigator for Sustainable Tree and Diversity. I developed this software several years ago. We can predict the right condition after cutting or thinning before conducting this trial with various topography by selecting location and various type of the operation, selecting by the trees. This simulation recommended 10-meter gap for the objective of this forest. For designing patch selection, we use the information of canopy architecture like that. These pictures show a patch 5 years after thinning. Vegetation developed well, and the cypress seedling here, this one and this one, grow well with coexist the other species. The both economical feasibility and ecological function should be evaluated after long monitoring. But so far, both economical aspect and ecological aspect seem to both is as we expected. Oh, sorry. Terima kasih. Thank you very much for listening.
Thank you very much. Thank you very much for Professor Hiromi Mizunaga for very nice presentations. That was different perspective. But it is very important and very useful for managing the uneven age forest in Indonesia. As I mentioned earlier, we don't take any question or discussion for this session. So if you have any questions, please write down in the chat room, and we will forward the chat your question to Professor Mizunaga to get the answer. If not through the chat, maybe we will send it through email, and he can reply you through email also. For next speaker, I would like to invite, is Professor Ralph Mitloner already present? Not yet? If not yet, then I would like to invite Professor Hasandi Abdul Hamid from University Putra Malaysia. He's here already, right? Yeah.
Yes, sir. Can you hear me?
Okay. Yeah. So before that, I would like to read his short CV. Professor Hasandi is right now serve as Dean, Faculty of Forestry and Environment, University Putra Malaysia. His research interests includes forest ecophysiology, forest ecology, plantation forest, and tree improvement. And today, he is going to give a presentation on the way forward of forest plantation in Malaysia. So I would like to give time to you, Professor Hasandi, please. Yeah, you have 20 minutes, but since Professor Mitloner have not yet joined, maybe you can add some minutes, but around 20 minutes. Yeah,
Okay.
please.
Right. Bismillahirrahmanirrahim. Thank you, session moderators, Dr. Insinyur Ufah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, good afternoon, and good evening to all. So before I start, I just like to thank the conference organizers, and I'm honored to be part of this conference, and I hope the information sharing in this conference may benefit all of us. I'm going to talk about the way forward of forest plantation in Malaysia. Next. This topic will be covered some information on the history of forest plantation in Malaysia, the statement of parameters influencing the sustainable production of forest plantation, including genetic diversities, silvicultures, and as well as preserving site sustainability. I'm going to discuss the different strategies which can be used during forest plantation and increase efficacy of these strategies. In the next step, the effects of different or mixed strategies on forest plantation will also be reviewed. And finally, the impacts of mathematical programming in the forest plantation will also be explained, and the challenges and resolutions of forest plantation will be stated. All information are based on the review and also based on my knowledge, perspective, and opinion related to the forest plantation development in Malaysia. Okay, the perspective. The broad agreements of definitions stated that planted forests are forests in which trees has been established through planting or seeding by human intervention, whereby plantation forests are a subset of planted forests. And plantation forests are planted forests that have been established and are managed intensively for commercial production of wood and non-wood forest product, or to provide specific environmental services such as erosion controls, landslide stabilization, windbreakers, etc., etc. So there is a trend toward referring to planted forests of exotic species as plantation forests, whereby planted forests of indigenous species are form of semi-natural forests or modified natural forests, depending on degree of naturalness, including mixed species and age classes, and as well as variable planting density, according to FAO 2000. How about oil palm plantation? Can we consider it as one of the forest plantations? By definition, yes. Yeah. After all, this species is also originated from natural forest, and nowadays the trunk of this oil palm can also be used in the wood-based industries. Okay, for the introductions, Malaysia is one of the mega diverse countries that has more than 150,000 invertebrate species, 15,000 vascular plant species, 742 bird species, 567 reptile species, 612 coral species, 1,619 marine fish species, 449 fresh water fish species, and 306 wild mammalian species. So this is from the record, current record, and I believe there are more species out there have yet to be discovered. Next, please. So in Malaysia, there are different type of forests, such as mangrove forest or coastal forest, big swamp forest, lowland ditrochite forest, hill ditrochite forest, upper hill ditrochite forest, as well as oak mountain forest or mountain ericaceous forest, whereby these forests are strictly managed under the policies provided some regulatory instructions to increase forest uniformity, to improve forest conservation, and also to manage educational and social needs. Next, please. For your mentions, the global forest area from 1992 to 2020 has decreased around 1.7%, or about 178 million hectares, due to anthropogenic changes, due to development, and so on and so forth. And for the global forest plantation from 1990 to 2020, there is a steady increase from 120 million hectares to 294 million hectares. And the highest forest plantation rate is in South America. Next, please. Malaysia, as you know, Malaysia is a pioneer country for the oil palm and rubber plantations. So the highest rate of palm plantation has been reported about 2.35 to 3.6 million hectares. This is according to the Global Forest Resource Assessment. But local record, I think, is more than 5 million. And Malaysia has the second rank for rubber plantation between the Asian countries after Thailand, where approximately 1 million hectares of land were covered by rubber. And for the forest land area in Malaysia, from 1990 to 2020, there is a slightly decrease, even though there is a land use changes from natural forest to other land use, but these figures actually include the or green cover, meaning that it also include the oil palm plantations and also rubber plantations. And naturally regeneration forest area in Malaysia from 1990 is about 18.6 up to 19.4. This is because of the practices in the sustainable forest management that we intensively and extensively use. And for the planted forest area in Malaysia from 1990 is about 1.9 million hectares and down to 1.6 million hectares. So this is due to the conversions of the plantations forests, especially oil palms and rubber, to the housing or industrial estates. Next, please. And for the log productions from planted forests in Malaysia, so this data actually include the supply of wood from the existing planted rubber under Rubber Industry Smallholders Development Authority, which is RISDA, and the record from MTIB 2009. So as you can see here, the wood output volume per year from plantation forests in cubic meter is about, in Sarawak only 1.7 million cubic meter, in Peninsular Malaysia is 1.5 million hectare, and in Sabah 600,000 million cubic meters. And the species composition, if we compare rubber with other species, it shows that the Peninsular Malaysia having the higher ratio in terms of rubber compared to the Sarawak and Sabah. And for the ratio of export, between export and domestic. It also shows that the Sarawak and Sabah show the highest export compared to domestic consumptions. Next, please. So this is a brief history of forest plantations, which is including the focusing on the woody species. Forest plantation in Malaysia started with the first planting of rubber, which is Hevea brasiliensis, at the end of 1800s and the beginning of 1900 for rubber productions. And forest plantation has been dominated by Acacia mengium, but many other species like teak, Tectona grandis, Azadirachta, the species and pioneer species has also been planted on a wide scale, but not from the improved planting material at that time. And forest plantation was limited to trial previously for extremely valuable exotic such as Acacia mengium, and also from the indigenous species such as Eusidoroxylon zwageri, Quasarina, Casuarina equisetofolia, Fagrefragan, Insia palambica, and also Palacium gutta. In 1997, the forest plantations area is estimated about 180,000 hectares, of which 90,000 hectares in Sabah, and 77,000 hectares in Peninsular Malaysia, and 13,000 hectares in Sarawak. But these figures have surely increased tremendously. Yeah? So beside forest plantations, there are some 1.6 million hectares of rubber plantation, which we call it as a commodity plantation. And it's estimated that annually around 2 million cubic meter of heavy wood logs are harvested and utilized for the productions of furniture and furniture components. So next. So this is the table shows that summary of most notable event in the history of plantation forestry in Peninsular Malaysia. Started in 1877, planting rubber, and in 1996, planting the teak as well as Azadirachta. And after that, there were no active or special program related to the plantation program in Malaysia. But next, please. But in 2005, in the third national agriculture policies, the Malaysian government encouraged the development of large-scale commercial forest plantations as an effort to reduce pressure on native forests as a source for raw materials and to ensure its continuous availability for domestic timber industry. So this effort continued in March 2005 when government cabinet has given mandate to the Ministry of Plantation Industries and Commodities to carry out an extensive program to enhance forest plantation developments. So the program started with the establishment of a special purpose vehicles known as Forest Plantation Development Sdn Bhd, which is established under the Malaysian Timber Industry Board. And for the funding, the government has allocated about 1.045 billion to be given out as soft loan to eligible companies applying to participate in the forest plantation programs. And this program has targeted to develop another 375,000 hectares of forest plantation at annual planting rates of 25,000 hectares per year for the next 15 years. And the species selected are 10 species of woody species and 5 species from bamboos. So next. So to make sure this program is sustained, to make sure the sustainable production of forest plantation, so there are a few aspects that we have to be counted, like social parameters, economic parameters, and ecological parameters, which is there are about 7 elements that we have to focus in, like genetic diversity, tree conservation, genetic improvements, sustaining tree productions, optimizing silvicultural interventions, avoiding or decreasing land degradation, as well as cost-benefit factors. So next, please. So for the genetic diversities, it provides the basis for resistant and adaptive biotic and we have to use the good forestry practices as well. So meaning that silviculture treatments, which is silviculture can be more efficient by understanding the limitations of natural resources in the specific sites. Therefore, the understanding help to implement the cost-effective plan and obtain maximum productivity. And last but not least, is preserving site sustainability, meaning that species site matching. So this is the one that we need to focus in our strategy. So which is the efficient plantation program of those plants that present an absolute match between the site requirement and the forest status in terms of soil, water, climate, and also depends on the tree characteristic. So next please. And the strategies that we need to focus in to make sure that our forest plantations in the sustainable manners. So we focus on rotation strategies, which is we have about 6 rotation strategies from very short to long to mixed wild fruits and also agroforestry system. And apart from that, we also have to include the modern omic roads to speed up forest plantation such as genomics, transcriptomics, proteomics, as well as metabolomics. And also we have to look at the applications of mathematical programming in the forest plantation, which involve like economic analysis, ecological analysis, growth analysis, modeling, so on and so forth. So next, please. So for the very short rotation, I think most of you already know about this. So for this strategy is considered as feasible method for growing growing trees species within 2 to 5 years, which are able to grow at high density area. And these very short rotations aims to produce paper, pulp, medium density fiberboards, gypsum bonded board, bio-based, wood adhesive, wood vinegar, charcoal. And the species recommended for this very short rotation, as you can see here, like from Acacia mangium until you can use the bamboo as well. So next, for the short rotation plantations, it was designed for the plantation model with the rotation age between 10 to 25 years. Thus, fast-growing hardwood tree species could be cultivated at high-density forest land with 1,111. So meaning that we use 3 by 3 meters planting distance per hectare, so we can get 1,111 up to 2,500 trees per hectare, meaning that we use 2 times 2 meter planting distance. So this method can be used in the degraded forest land and also marginal areas, which can be occupied by using 2 or 3 compatible tree species in mixed species plantation. And the species suggested like Tectona grandis, Sticulia, Neolamakia cadamba, Ciba petanda, Eucalyptus species, Octomelius sumatrana, Gemalina oborea, and until Endospermum diadinum. So it depends on the growth rate as well. So next, please. And for the medium rotation plantations, so this suitable rotation time is in this strategy is the age of 45 to 60. Which allowed the cultivated tree species to grow for solid wood productions or rotary peeling. So in this strategy of forest plantation, thinning should be implemented 2 or 3 times at the age of 5 to 7 years, which is removing 40% of the growing stock, 15 to 18 years, which is removing 30% of the growing stocks, and 25 to 30 years, which is removing 20% of the growing stock. And it's depending on the species climate condition and also management techniques. So this breakthrough of this, the breakthrough of this strategy is the capability of mixing 2 or more than 2 tree species, which could be established by using a checkerboard or row mix planting. So the species suggested, as you can see here, from Tectona grandis, Sentangs, and Hopia to be used for these medium rotation plantations. So next, please. For the long rotation plantations, the periods of tree species in long plantation method is between 60 to 90 years. And the thinning phase could be performed at age of 10, 20, 30, and 40 years. And proper management practice and silviculture treatments such as thinning and pruning are important to optimize the wood quality and increase tree growth and value of the end product from these long rotation plantations. But this long rotation plantation can also be strategized by including the non-wood, include like rattan or anau, lemongrass, nutmeg, kenaf, hibiscus cannabinus, hibiscus subdarifa, neem, kayu manis, and also acularia, gaharu. So we can put it together with the long rotation plantation species. Next, please. For the mixed wild fruit plantations, so this wild fruit species can be mixed with multi-strata canopies in accordance with home garden structures or traditional fruit orchards. So we can use wild fruits and such as mangifera, mangoes, bacang, quinines, philanthus, bacauria, pakia, petai, keranji, scapium, kembang semangkuk, Garcinia species like candies, and also Artocarpus species like cepedak, jackfruit, and so on and so forth. Also durian species. So next, please. And agroforestry plantation system can also be implemented in this strategy, which is agri-silvipastoral or agri-silviculture strategy is another forest plantation system. But this system normally can be applied to small-scale plantations of forest with area of 4 to 50 hectares. But it also can be incorporated to other types of strategies, long-term, short-term, and also medium-term. So next, please. Okay, to make sure that there is sustainable productions from the forest plantation, or to make sure that our forest plantations is sustainable, so we should include the modern omics to speed up forest plantation, such as genomics, proteomics, transcriptomics, and also metabolomics. So why omics? Next, please. Why omics? So because over time, forestries have been subjected to an unprecedented rise in pathogens and pest attacks. And climate change is another threat, which has influenced forests and caused limitation in the productivity of trees. So one way to reduce losses is by planting of resistant tree species or genotypes in the forest against different stress factors. And although conventional breeding strategies have been countered as the main road to achieve resistant trees, but modern biotechnology technique has become a reliable way to develop tree resistant against herbivorous attacks. In fact, application of conventional breeding method to improve forestries has some limitations, depends on the genotypes, age, breeding cycle, cross-pollination types, compatibility of parents, progeny test setup, the interactions of G by E, and the target mechanism or traits. But and modern biotechnology techniques have been recruited in forest breeding program for attaining elevated productivity of wood and timber to meet the huge claim of the wood markets. Next, please. Interestingly, the use of advancements of modern genetic and biotechnology tools could significantly lessen the time required for tree growth and maturation, as well as help to reduce the population of trees by means of non-favorable traits, which is genomic discovery and selections of important agronomical traits are the most important milestone of modern genetic engineering. And genomic selections could eliminate the cycle of breeding in eucalyptus, for instance, by 50%. So this kind of technique has widely been used in China, in Australia, Brazil, as well as in a few European countries. So, and we can see that China's Australia, they only focus one or two, or Brazil, one or two species for forest plantations. And these species will be improved time to time through this kind of omics techniques. And modernization of plant breeding method, genetic transformation, and genome editing by genomic selections, protoplast transformations, bioholistic method, and also using agrobacterium and also clustered regularly interspaced short palindromic repeats for improving of desired trait, remarkably increase forest productions and improve tolerance of trees against stresses. So this is what we can see from plantation forest in China, for instance, lately, like they use eucalyptus hybrids produced through the specific technique using the biotechnologies. They can produce a good clone, high productivity, and also can shorten the rotation cycles. So additionally, this technique have also been applied to improve the quantity and quality of wood as well. And transcriptomics, divergence of three species in natural populations and gain attention and momentum among the policy makers, tree breeders, and scientific communities nowadays. And proteomic tools can help to evaluate the functional analysis of the gene of interest in the level of protein expression, which is protein specific to cell death, enzyme signaling in plant defense mechanism as well. And metabolomic studies in the tree stress interaction have been focused on the evaluation of some secondary metabolites such as flavonoid, phenolic acid, and antioxidant using NIR, using HPLC, LSC, GSC, LCMC, and as well as GCMS. Next, please.
Excuse me, your time is almost finished. Yeah,
okay.
Thank you.
All right. I think better we skip here. Next. Okay, application of mathematical programming in the forest plantation very crucial, because we can use the modelings, we can analyze the gross productivities, we can also determine the economic perspective of plantation establishment by using the mathematical programmings. So next, please. And limitation and highlight of forest plantations mostly related to the high installation cost, related to the maintenance, and also related to the genetic. So jadi during the entire cycle of silviculture, several parameters can change. The market price, social norms, ecosystem service, subsidies, taxes, and supply and demands of forest resources. So this is part of limitation and highlight of forest plantation in Malaysia. So next, please. So ways to overcome the barriers, increasing the diversities of the species in the forest plantation procedure is one of the most important ways to reduce the risk of hazard exposure. That's why in our special program, we recommended to plant more than 10 species to be included in the forest plantation programs. So next, please. So in conclusions, high demand for wood and timber and high potential of the country to supply more wood and timber could have taken the attentions of forest researchers and managers to focus more on forest plantation strategies. And forest plantation is a reliable strategies which play an important role in the wood and non-wood based manufactories. And the prominent technique of the forest field can provide environmental and social benefits. And however, beneficial method of forest plantation, several key points and strategies should be considered as well, which is providing sustainable production is one of the most important factors which should be studied during establishing and maintaining the planted forest. And genetic diversity, silviculture, and preserving site sustainability have been taken the attentions. And additionally, applying new omic technologies producing high resistant and quality trees could be taken, and as well as computational based technology and mathematical formulations also would be the most reliable tool to estimate the efficacy of plantation method and calculate the cost benefits. So notwithstanding the mentioned progress, and prominent achievement in the forest plantation area, there are some serious challenges and restrictions yet, which stalling the progress of forest plantation in Malaysia. So with that, I think, thank you. Terima kasih.
Thank you very much. Thank you very much, Dr. Hazandi.
Welcome.
Yeah, thank you very much. Very interesting indeed, presentation from Professor Hazandi. I can see similarity with plantation in Indonesia, but I was surprised with the list of species that you presented. So many species. I think Indonesia need to look at that. Yeah, I mean to try to that also many species, new species. For the next speaker, I will, without further ado, I would like to invite the next speaker. From Malaysia, we shall go to Indonesia. So we will see Indonesia situation. And for this, I would like to invite Dr. Agus Justianto. Is he already in this room?
Yes, Bu Ulfa.
Oh, okay. Thank you. Dr. Agus Justianto will present his speech on sustainable forest management scheme in Indonesia. And before that, I would like to read his short CV. Actually, Dr. Agus Justianto is graduated doctorate program from IPB University. And now he serves as Director General of Sustainable Forest Management of Ministry of Environment and Forestry in Indonesia. So without further ado, I would give the time for you, Pak Agus. Yeah, please.
Yeah. Thank you, Bu Ulfa. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Very good morning. Honorable Dean of Forestry Faculty of IPB University, honorable keynote speakers, honorable invited speakers, distinguished participants, ladies and gentlemen. I'm very pleased to be here at the third International Conference on Tropical Forests, a Tropical Silviculture, online from Bogor. First of all, please allow me, on behalf of the Ministry of Environment and Forestry, Republic of Indonesia, to extend my sincere appreciation to the Faculty of Forestry, IPB University, for hosting and organizing this conference. Thank you for inviting me as a keynote speaker to this important conference. Next. I would like to presenting my speech regarding the Sustainable Forest Management Scheme in Indonesia. Firstly, I will overview the Indonesian forest. Then I will talk about the national strategy to support sustainable forest management and the challenge opportunities in the sustainable forest management implementation. As you know that Indonesia has a vast forest area, which is 65.8% of Indonesia's land area, and it is rich in biodiversity. Next. For this reason, forestry has a vital role in Indonesia developments, and which is includes strengthen economic resilience for quality growth, develop regions to reduce gaps, improve quality and competitive human resources, and build the environment, and also increase disaster resilience and climate change. Next. Ministry of Environment and Forestry refer the forestry in the National Medium-Term Development Plan 2020-2024, as we have 3 main indicators of forestry development in that period, that is establish and protect 65 million hectares of national protected areas with high biodiversity, high carbon stocks, and carrying capacity and environmental capacity. And then overcoming the use of forest areas by community, by providing access and or assets to the community of 10 million hectares and meeting the minimum national wood production supply or demand around 60 million cubic meters per year. Next. As you know that the Indonesian forest, of course, we have to achieve our commitment, especially dealing the sustainable development goals on all the goals, 17 goals. Next. This is the position of the Indonesian forest in the SDGs. Next. Ladies and gentlemen, now we have what we call the Omnibus Law on job creation. As you know, this is the right momentum to encourage ease of business licensing, as well as simplifying the states and procedures in forest governance practices. In addition, the regulation of forestry multi-business development is a paradigm shift in forestry through the concept of forest optimization as the contribution of forestry to the SDGs. Through the multi-business forestry, it is expected to be able to maintain land cover, increase forest productivity, increase PNBP, increase export of forest products, increase carbon sequestration, and store it and create job opportunities. Next. Sustainable management. Next. Sustainable management of production forest and protection forest. Post the Omnibus Law. Next. We do the next. The policy through what we call the policy making cycle process. All the policy based on the scientific base and rule base, practical base, evidence base, and best practice as well. Next. Under the multi-business scheme, now forest utilization business permit will be following the multi-business scheme. That is utilization of production forest through the granting of forest utilization business permit. And this scheme actually is beyond timber, social forestry, and multi-businesses. And also utilization of forest land values is more optimal. Next. As you know that the utilization of production forest and protection forest, of course, next, will be implemented through many schemes. And of course, the pillars of sustainable forest management will be concerned on the certainty of area, businesses guarantee, productivity, product decertification, and competitiveness. Next. Regarding the sustainable forest management, especially on the production, through the business permit for utilization of timber forest product. So there is some process that can propose to reduction of the deforestation, degradation, with decomposition, and also improving sustainable forest management principle. Next. The concept of the sustainable forest management, next, will be covered the upstream, downstream, and the market. In the upstream, before that, please back one slide more. Yeah. In the upstream, actually we will focus on the forest management and forest area management plan, and then forest utilization business and non-tax revenue of forest utilization and forest utilization business permit. We have information system to cover these upstream activities. And then in the downstream, we do the forest product processing in forest utilization business permit and forest product processing outside the forest area. We also have already established the information system dealing with these downstream activities, and then for the market, through the domestic market and export, guaranteed by legality and sustainability. And we also already established or set up the information system who connect to the INATRADE in the Ministry of Trade and INSW in the Ministry of Finance and for export market. Next. Indonesia is the only country that mandatory implements the timber legality assurance system. As you know that there is a comparison regarding the timber legality assurance system, and many countries actually already do the same process with Indonesia. For example, Korea, China, Malaysia, Vietnam, US, EU, Australia, and also New Zealand. The timber legality assurance system next, that we call Sistem Verifikasi Legalitas Kayu atau SVLK, it covers the timber industry at the nationwide scale. Since 2013 until March 2021, Sistem Informasi Legalitas Kayu has issued, or SILK, has issued more than 1.4 million fee legal documents, including FLEGT license for EU and UK destinations to support timber product export with total value of more than 77 million US dollar. Next. The 10 years experience in working with the international partners to negotiate and implement FLEGT VPA through the multi-stakeholder process. As I mentioned that we have already begun since 2001 through the VPA negotiation, intensify and provide leeway for perfecting of SVLK. And in the year of 2011, we have already launched a fee legal logo for legal timber and timber products. And then to design information system starts to operate in January 2013. And then in the 2016, Indonesia issues first FLEGT licenses for timber product export to the EU member countries. And Indonesia is the world's first FLEGT licensing country. In the year 2017-2018, Indonesia has reviewed and improved the implementation of the timber legality assurance system, and in the year of 2019, UK and Indonesia signed voluntary partnership agreement on forest law enforcement, government, and trade in the timber products. Distinguished participants, ladies and gentlemen, next, I can mention that the SVLK has the uniqueness. Some core principles have enabled SVLK to become a successful framework for timber reform in Indonesia. SVLK developed based on Indonesian laws and regulation, and then developed based, refer to the international standard, and also conducted through the multi-stakeholder consultation process. And then full traceability along the entire timber chain of custody, legality and sustainability from upstream to downstream, and so on. And of course, this is a strong commitment to sustain forest resources. Next, the advantage of SVLK in the implementation that improve market confidence, better access to international markets, contribute to increase export revenue, reduces forest degradation and deforestation, improve image of Indonesian timber products, assurance on proof of legality and traceability for trade partners, strong market potential for customer, and improve forest governance. Next. Of course, we do the continuous improvement as SPLK arrangement is listed in the government regulation number 23, 2021, and Ministerial Decree number 8, 2021. This regulation of further improving SPLK, especially to strengthen transparency through independent monitoring, strengthen government support to SMEs, and then implement green government procurement policy for domestic market. Next. This is a breakthrough forest product legality and assurance. Through some activities, actually we have get a lot of benefits in the implementation of timber legality assurance system. Next. Next. Now, I would like to give you an overview about the achievement, opportunities, and challenges. Next, for sustainable forest management. We do a lot of corrective measure in the forestry development. For example, land and forest fire prevention, and then building the climate resilience by restoring, managing, and recovering peatland, and so on. And shifting the forest management from timber-oriented to multi-business forestry based on landscape and community-based. And of course, prevention of biodiversity by area conservation and biodiversity protection. And then we also develop the national forestry policy is aligned with the international convention. And then internalize carrying capacity and environmental capacity in designing the national forestry plan. Next. The achievement towards the sustainable forest management, of course, we have the result of series improvements efforts since 2015. That is a social forestry by granting the access rights around 12.7 million hectares of forest to communities. And then conservation value in all palm plantation, new permit moratorium since 2018 to evaluate the recent concession and halting further forest land conversion. And then effective implementation of the SPLK, which has been nationally applied since 2013. And then forest land rehabilitation by targeting 4 million hectares for the past 5 years. Law enforcement related to forest fire, forest area encroachment, illegal mining, and so on. Peat management through the moratorium on the utilization of peatlands, water management regulation, and implementation of canal blocking in the site level. And then forest and land fire management improved through, among other, early warning system. And that's our achievement during since the 2015. Based on this, correctly know that the annual deforestation rate in Indonesia is declining by more than 80% compared to the 2011. Distinguished participants, ladies and gentlemen, I would like to give you an overview, the contribution of the forestry business sector. Since the COVID-19 pandemic hit the world, the business and economic sectors have been hit and hard by policies that restrict the movement of people and goods, including the trade sector. And then in Indonesia, the COVID-19 pandemic has impacted the national economic growth. And in the quarter 2 in the year of 2021, the rate of national economic growth increased by 3.31% compared to the quarter 2 of the year 2020, that is quarter to quarter. In the forestry sector, production logs, processed wood, and non-timber forest product have rebounded. These were in line with an increase in the export value of forest products. Next. The challenge of sustainable forest management, especially dealing with the implementation of law number 11, 2020 concerning the omnibus law on job creation. But this is a momentum for permit holder to improve their in new and renewable energy by developing the food estate energy plantation forest in the multi-business forestry scheme. And then build upstream, downstream, and market integrated forestry business cluster, both in special economic zones and other potential economic areas to increase product efficiency and competitiveness, and then provide facilitation and capital support for business licensing through we call it the BLU, and ensuring business continuity by granting a long period of business licensing, and then providing incentive for imposition of dana rehabilitation dan dana reboisasi solely for natural forest wood, which previously based on permits, and then increase the productivity of forest product with silvicultural system, multi-silvicultural system, and silane techniques, and low impact harvesting, reduce impact logging in forest management in accordance to site condition, and then provide facilitation for permit holders to build a forest product processing in their working area, and develop a new forestry business configuration by prioritizing the role of the community and the SMEs. The opportunities next for sustainable forest management is it is a necessity to map the potential of forest resource in working areas, and then planning adjustment are needed by changing or efficient business working plans. And then within the context of regional certainty, implementation of business licensing area boundaries follows new provision with an information technology approach. And then forestry multi-business must produce diverse products or commodities derived from utilization of timber forest products, non-timber forest products, and environmental services, and improving coordination of all stakeholders, building a performance evaluation system for multi-business forestry, and reorganizing carbon storage and sequestration activities as one of the multi-business forestry activities that play an important role in supporting climate change mitigation and adaptation to achieve NDC target in the forestry sector, and socializing the job creation law or omnibus law and its regulation implementation for sector outside the forestry. I thank you very much.
Thank you very much. Thank you very much for Pak Agus Yustianto for very, very comprehensive presentation. Since Professor Midloner has not been able to join us until now, so I would. This is Professor Dr. Agus would be the last speaker in this session. But before the closing, I close the session. I would like to give an overview of plenary session. In this session, we have been presented with a full view of nowadays forestry. We started with the big problem of carbon emission, mainly in peatland forests through forest fire, and possible mitigation have been given by Professor Cochrane. And then later we have presented with some innovation in management of uneven age forest stand, presented by Professor Mizunaga, and then followed by an overview on innovative strategies, which is applied in forest plantation in Malaysia. And just now, this session has been finalized by Dr. Agus Yustianto with a view on innovative policies developed by Ministry of Environment and Forestry Indonesia. And on behalf of the organizing committee, I would like to give to express our highest appreciation to all of our speakers this morning. And thank you very much. And with this, I would like to end this plenary session and will give the time back to our MC, Miss Ati Nurhayati. Thank you very much. And applause for all the speakers. Thank you very much.
Okay, thank you very much, Dr. Ulfa, for guiding the plenary session. And of course, to all the great keynote speakers, thank you for sharing with us. And please once again to give applause to all speakers, or you can click the reaction. Okay, distinguished participants, ladies and gentlemen, before we continue the parallel presentation session, we inform you that there is a competition for student presenter. We will choose the best student presenter and the best student poster and announce it at the closing session. Okay, ladies and gentlemen, you are welcome to join the parallel presentation room using the link that we already shared in the chat box and the slide. Okay. After the parallel presentation session, you are kindly requested to be here again in the main room at 4 p.m. for closing. Thank you very much for your kind attention. Good morning and enjoy the parallel presentation. Okay.
Okay, thank you.
Okay, please join the parallel presentation room. The link already shared in the chat box. Okay, thank you.
Of the
Udah masuk ya? Gimana? Masuk di sini? Oh, udah login kan tadi? Udah. Wah, tadi bisa dari kantor. Ini Bapak udah di room juga? Belum ya? Oh, dia lead ya. Langsung buka aja. Ini servernya nanti. Oke.
During the 2020 maybe
3D printing, and also about the molecular development. And the report from McKinsey state that the future economic will be driven by the biorevolution. Yeah. But on the other side, we are also bound to the so-called Nagoya Protocol, which regulate the access to genetic resources and the fair and equitable sharing of benefits. If we are talking about the benefit, there will be a monetary and also non-monetary benefit. Yeah. This is the talking about the development of or transformation of the sequencing technology from the big one to the small one. Yeah. The big one is number 4, especially in the developing country. There are number 4 is not really easily accessible for us. Yeah. But when we are talking about the small one, it is easily available, meaning that affordable as well. Everywhere, everyone can have it. And IPBB research group try to be familiar with this technology. And in, I think last year, December last year, I just put in the Twitter that we are started to use the first time the ONT of nanopore technology to sequence one of the species collected inside the campus because of pandemic for the Castanopsis species. Yeah. And through this technology, we are developing our capacity to learn more. Stated here that we can do sequencing everywhere. Basically, it is in an office, yeah, with the pipette down the table, with the fungus comb from the termites, and would like to know the component or inside what kind of. Maybe there is DNA. We don't know yet, but we successfully extract some DNA samples. This is how the technology can be used. Very simple. Maybe we can generate, and then the data, generate the data, any kind of data. Yeah. First collecting the data first, then we try to process it to become an information, and later become useful knowledge. In the practical example, we would like to show it later through our study. The first one that we finally comfort with these 3 pipelines. Yeah. The first one is following the protocol from the ONT technology from the producer regarding library preparation. So at the time, we missed to use the qubit, in the past, and then we failed. But now we are using the qubit to quantify exactly the DNA content. And then for the sequencing work, I think it is fine, not a big deal, yeah, as long as we can put our library, yeah, in the, here we call it the flow cell, yeah. Then we just waiting the results, a day or even 3 days. And then the last one is about the bioinformatic platform from base calling to the annotation. So this is the precondition before we are working to use this technology. And until now, we have successfully conducted research on, I think, 8 species from Diospyros, Matoa, Ochroma, which are very useful for restoration of some forests in Indonesia. We collected with drop data. There are still diversity of data number, and then basically we could successfully construct or assemble the chloroplast genomic DNA with different, again, sizes. What we are going to do with this data of can do for ecosystem research or ecosystem studies, yeah. We can do ecosystem study for using this data and do a sequencing in the field, for example. In this case, we are tried in our Gunung Walat University forest. With on the left side here's the yeah. We have gained some lesson learned that we need to work together. Warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay. I use two devices, so I probably use.
But there is no explicit agroforestry class in those maps. But here in our exercise, we specifically discriminate agroforest from other land uses. And in 1990s, we saw we can but then regardless of the benefit that I mentioned earlier, in 2010s, the extent, and you can see also the distribution of agroforest changed a lot in 20 years, yeah, between 19 million to 12 million hectares areas, which is quite significant. And big part of this is because of the competition of land use for other purposes, like for settlement in the case of Java and maybe the southern part of Sumatra, and also competition with more monocultural and more intensive land uses, such as oil palm, such as timber plantation, etc. So we can see the decrease, and then during the benefit for the livelihoods and ecosystem services, we would like as well hear from ICRAF side as well. I see also from IPB colleagues, they have been also promoting agroforestry for practices of smallholders. We actually would like to see how actually agroforestry can still be scaled up so that it can deliver the double benefit of livelihoods and ecosystem services. So let me just go quickly to the our of how actually we can scale up agroforestry at the landscape level. So as a theoretical background, for those of you who are familiar with Fontunan work, actually he said this is a long time ago. It's before even the industrial era. Fontunan look at the observe that there is spatial patterns of agricultural land uses surrounding a city. So if the concentration of population is in the city, there will be a layer or a circle of agriculture, of pattern of agricultural land uses that is actually maximizing the farmers' profit by minimizing transport and land costs, yeah, so that it can meet the market demands for the city population. Yeah, this actually is very still very much relevant to today's society. But then by the end, towards the end of 20th century, we can see the pattern or the discussion globally that it's not only agricultural product that is important, but ecosystem services is getting more scarce, and therefore a broader need to maintain ecosystem services is very important. Yeah, and then with that, ecosystem mapping got a lot of attention, so that the supply and demand of ecosystem services in terms of local, regional, and global can be mapped, so that it can be used to design
Tertarik dengan flora fauna yang ada di hutan?
Senang berpetualang ke alam bebas?
Atau ingin turut andil dalam melestarikan hutan di Indonesia?
Fakultas Kehutanan dan Lingkungan IPB University bisa menjadi pilihan yang tepat
Untuk kamu. Fakultas Kehutanan dan Lingkungan IPB University memiliki 4 program studi yang pastinya sangat keren. Pertama, manajemen hutan. Di sini, kamu akan mempelajari cara mengolah hutan dari mulai membuat perencanaan, kebijakan, hingga cara memanen hasil hutan secara lestari, baik kayu maupun non-kayu.
Kedua, hasil hutan.
Beragam hal bisa kamu pelajari di sini, seperti pemanfaatan hasil hutan dengan baik agar bernilai jual tinggi, dan cara memaksimalkan produk kayu dan non-kayu dengan teknologi yang canggih dan modern.
Ketiga, konservasi sumber daya hutan dan ekowisata. Sesuai dengan namanya, kamu akan mempelajari flora fauna dan konservasi sumber daya yang ada di hutan, serta pengelolaan suatu ekosistem agar dapat dikembangkan dari sisi ekowisata.
Terakhir, Silviculture.
Pada program studi yang dikenal dengan sebutan dokternya hutan, kamu akan belajar tentang cara budidaya bibit pohon agar menjadi unggul, serta belajar tentang rekayasa genetika dan perkembangan jenis-jenis pohon.
Untuk mendukung proses pembelajaran, Fakultas Kehutanan dan Lingkungan IPB University memiliki beragam fasilitas yang sangat lengkap. Seperti hutan arboretum, workshop, rumah kaca, penangkaran rusa, perpustakaan, taman hutan kampus, persemaian permanen, dan beragam laboratorium yang pastinya sangat lengkap.
Gak cuma itu, Fakultas Kehutanan
Fakultas Kehutanan dan Lingkungan IPB University didukung dengan pengajar yang berkualitas.
Ada juga kegiatan unggulan yang dilaksanakan seperti praktik lapang kehutanan, di mana mahasiswa
developed in Indonesia so that Indonesia can reduce import of beef and meat. Yeah. And finally, thank you all for your attention. Wassalamualaikum warahmatullahi wabarakatuh. Terima kasih.
Halo, moderator.
Ya.
Tadi saya belum presentasi.
Untuk sesi ini untuk invited speaker ya. Habis itu kita lanjutkan ke ya.
Oh iya, oke.
And the Species Diversity Index is very usable parameter for comparing two communities And then specific evenness index is specific index type or indent evenness, so the level of individual evenness of per species. And then last,
we found forest therapy combined with mindfulness-based stress reduction and observational behavioral therapy. Mindfulness-based stress reduction is an 8-week evidence-based program that offers secular intensive mindfulness training to assist people with stress, anxiety, depression, and pain. Developed at the University of Massachusetts Medical Center in 1970s by Professor John Kabat-Zinn, MBSR uses a combination of mindfulness meditation, body awareness, yoga, and exploration of patterns of behavior, thinking, feeling, and action. On the other hand, behavioral therapy is a term that describes a broad range of techniques used to change maladaptive behaviors. The goal is to reinforce desirable behaviors and eliminate unwanted ones. Behavioral therapy is rooted in the principles of behaviorism, a school of thought focused on the idea that we learn from our environment. This approach emerged during the early part of the 20th century and became a dominant force in the field for many years. Edward Thorndike was one of the first to refer to the idea of modifying behavior. Based on our findings, both of these methods combined with forest therapy benefited human health. Based on the systematic literature review we conducted using keywords forest healing, forest bathing, Shinrin-yoku, and human health, there is still a scarce amount of literature research on forest therapy and forest bathing. Synthesis of these works of literature resulted in the categorization of methods used for forest therapy and intervention. Forest therapy methods used by researchers are forest walks, forest viewing, the combination of forest walks and viewing, forest landscapes, therapy programs involving 5 human senses, doing relaxing activities in the forest, and traditional medicine-based therapy. On the other hand, were also combined methods used. All of these methods benefited human health. The limitation of this finding is the broad types of forest use for forest therapy. Further research is suggested regarding this matter. Thank you. I sincerely appreciate your attention today. If anyone has any question, please feel free to ask now, and I'll do my best to answer. Thank you.
Okay, thank you, Mbak Farida, Mbak Ferda. Okay, now we move to the second presentation. Please, Ibu Aulia Rianti.
Yeah, hello.
Yeah, please.
Okay.
Yeah. Okay, please.
Okay. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Good evening, everyone. I apologize for not being able to turn on my camera due to signal and device issues. Thank you for the opportunity and time given to me. My name is Aulia Ranti from the Department of Forest Management, Faculty of Forestry and Environment, IPB University. Here I will explain the result of our research entitled Detection of Change in Urban Forest in Jabodetabek Megacity using Sentinel-2 and Landsat 8 imagery through the Google Earth Engine cloud computing platform. With a drafting team consisting of me, Rahmat Asyari, and Tarisa Hikmah Amaliana. Next. Okay, our presentation outline is introduce, method, result, and discussion, and conclusion. Next.
viability, and they cannot be stored over a longer period of time, and that's why the development of a propagation protocol, an alternative one, using the non-conventional technique of vegetative propagation, is high time. Now, this study actually involves two major activities. One is the germplasm collection that conducted in the Lobok Watershed Forest Reserve in Bohol Province in the Philippines, while the seed collection was conducted in various identified and selected mother trees of Aquilaria cumingiana in the said province. After 1 year, the seedlings were transported from the Bohol Island State University to the College of Forestry and Natural Resources at the University of the Philippines in Los Baños, where the actual vegetative propagation protocol has been. Now, the orthotropic or the vertically oriented shoots were harvested from the 1-year-old cuttings, which were separated into three different categories. These cuttings of different varying leaf number actually serve as the treatment in this particular study, such as 1, 2, and 3 leaves per cutting, respectively. And then after that, all these cuttings harvested were sanitized using the fungicide solution before setting all the cuttings or treated cuttings with fungicide into the improvised propagation chamber that we have developed using a completely randomized design. Now, if you notice, we didn't use the commercially available rooting hormone, and we didn't apply the trimming of the leaves of the cuttings here. And that was after we discovered that this particular species, the Aquilaria creminiana, got a relatively high percent rooting even in the non-application of growth hormone and leaf trimming. Now, after 2 months or exactly 63 days, rooted and unrooted cuttings were all harvested and evaluated and analyzed statistically using the R statistics version 4.0.5 of 2021. Now, the cutting size, such as the cutting diameter, was also measured using the digital vernier caliper, while the cutting length were measured using the ruler. Now, results of the statistical analysis revealed a significant and highly significant variation among the different root parameters tested, such as the percent rooting, the number of roots, the average root length, the number of secondary roots, and the length of the longest roots. Now, in terms of the percent rooting, that range from more than 50% to up to about 80%, we have found that the cuttings with 2 leaves generated the highest percent rooting. And such value has been found significantly different compared to the other treatments after subjecting the means to a two-case range test. The same observation was also discovered in terms of the number of roots, wherein the treatments with or cuttings with 2 leaves generated or produced the most number of roots. And such value has also been found significantly different compared to the other treatments after all the means have been subjected to two-case range test. Now, in the case of the percent rooting and the number of roots, this emphasize or confirm the presence of naturally occurring endogenous auxin that has been discovered previously in the previous study that I had mentioned earlier. Now, in the case of average root length, we noticed that it was the cutting with 3 leaves generated the longest number of roots in terms longest number of roots on the average. And such value has also been found to be significantly different compared to the other cuttings with a varying leaf number after subjecting these means to two-case range test. And on the other hand, in terms of the number of secondary roots, we discovered an increasing number of secondary roots with the increasing number of leaves per cutting. Okay, just like what you can see in the pictures on the right part of your slide, showing that the cutting with 1 leaf produce a relatively less number of secondary roots compared to the other treatments. And such root parameters that shown to you in terms of the average root length and the number of secondary roots emphasize that aside from the naturally occurring endogenous auxins, perhaps the presence of carbohydrates or the varying carbohydrates influence the photosynthetic rate of these cuttings, which affect the rate and success of rooting. Now, finally, in terms of the length of the longest roots, we have noticed that it was actually the cuttings with 2 leaves that produce the longest root system that can also be shown to you on the right portion of your slide by the blinking red rectangular box. So you can see here, so in terms of the length of the longest roots, relatively, this the longest compared to the other treatments. Now, in terms of the correlation analysis, among the rooting traits that we have tested, the relationship between the average root length and the length of the longest roots generated the positive and strongest relationship, and it was followed by the relationship or association between the number of roots and the length of longest roots. And finally, by the correlation between the average root length and the number of secondary roots. Now, what does this particular observation imply? This implied to us that aside from the amount of the naturally occurring endogenous auxin, perhaps the distribution and the auxin transport might also influencing the rate and access of rooting among, and that's why we discovered a significant differences among these rooting traits. On the other hand, after comparing the correlation between the root traits and the cutting size, we notice a positive yet weak and non-significant associations in all parameters tested, which would indicate that perhaps the varying carbohydrates, due to varying leaf numbers, may not that large enough to give us a significant variation among these treatments tested. Now, for the conclusion and recommendation, this particular study confirmed the presence of naturally occurring endogenous auxins that we previously discovered in our other studies earlier. Now, aside from that, we
recording in progress.
Aquilaria that are said to be one of the most expensive agarwood producing species here in the Philippines. And this is very important, especially since here in the Philippines, despite the absence of an established agarwood industry, we do have a more than we do have a 9 species of Aquilaria, wherein 6 of these are said to be endemic, and 3 of these
acceptable for the what do you call it, to the fungi, for producing good good agarwood, something like that. So did you try by inversing after dipping in the hormone, say for example like this, and then you invert it, because basically the auxin goes for basipetal
area, we will make contour extraction, and then we estimate the line of planting using the contour that extracted, and we will count the plant row and plant point, and also we will estimate the potential productivity of forage and also the carrying capacity of livestock, using their and increasing in agroforestry product from both village. And the method we use is we gather around 50 lens unit as a base land sample using purposive sampling method, where is 30 unit in Talang Mulia village, as we call then site A, and 20 unit in Sungai Langka village at site B. Direct observation is conducted with on-field data collection using handled GPS, and we seek for primary data information about geographic location and land boundaries.
Okay. Okay. So, Mr. Adi, again, we want to have a question addressing for the other speaker. If not, so I will move.
And we estimate the forage production using the number from Savitri et al. Research, which is which passing 1 meter, it will produce 3.73 kilogram per year for gliricidia sepium, and in spacing 0.70 meters, it will produce around 2.01 kilogram of Penicillium purpureum CV mode, or we call it as rumput gajah mini in Indonesia. And then for a livestock carrying capacity, we use 9.1 as a cattle animal. One cattle animal unit is equivalent with 9.1 kilogram of dry forage, with it has 21% of dry matter content. And then one animal unit for cattle is equivalent with 14 adult of goats, or it same as 0.16 animal unit.
A very important role in achieving the
And then,
SDGs. Nature provides us with vital resources such as food, air, water, and energy. Nature can be harnessed to create solutions to the challenge set out in the SDGs, solutions that are positive for social, economic, governance, and environmental outcomes. Nature in all goals demonstrate the importance of NBS in delivering the SDGs. So the definition of NBS is illustrated in this slide in the below part. It's defined as action to protect, sustainably manage, and restore natural and modified ecosystems that address societal challenges effectively and adaptively, simultaneously providing human well-being and biodiversity benefits. NBS come with multiple formats, objectives, and benefits that synergistic that happen in the same time. Examples of the NBS are green roofs, green gardens, ecosystem restoration, energy efficiency, and many more. That is still possible to modify nature or ecosystem by mimicking the environment, not against the environment, but really site-specific. So there are 8 criteria that must be met in NBS, of which criterion 1,
wood and open wounds, we can give a physical
in the last
10% of peat emission come from research. That's one of the largest non-tropical peat carbon. This is also this is made by pitch that finally put Indonesia as the third largest. I met him in 2016 in UK, and I told them that you should revise your calculation. You calculate the burn depth, because when we calculate with us, the result is different. See, and then Fitch said that, "Mama, sorry, at the time we have no good, method to calculate the burn, something like that." So then, this is also another reason why I should say that first we should change the calculation. This is made by IPCC, where when you calculate the greenhouse gas emission, especially eye connecting with the peat, they put here a combustion factor, yeah, and also the other one, the mass, using burn depth. This is at least two factors that make the calculation maybe underestimate or maybe overestimate. Because what? Because in Indonesia, they use combustion factor per peat is 1, like we discussed. How come? And they make also the burn depth is almost pitch that finally put Indonesia as the third largest. I met him in 2016 in UK, and I saw them that they should revise your calculation to calculate the burn depth, because when we calculate with us, the result is different. See, and then Fitch said, "Mama, sorry, we have no good, method to calculate the burn, something like that." So then, this is also another reason why I should say that first we should change the calculation. This is made by IPCC, where when you calculate the greenhouse gas emission, especially eye connecting with the peak, they put here a combustion factor. Yeah, and also the other one, the mesh, using word there. This is at least two factors.
The self-assessment results shows that Subak addressed 3 out of 7 societal challenges as a core of NBS, which are environmental degradation and biodiversity loss, food security, and
Jadi pilihan yang tepat
Untuk kamu. Fakultas Kehutanan dan Lingkungan IPB University memiliki 4 program studi yang pastinya sangat keren.
risk on water scarcity, especially for irrigation-related paddy fields, reducing disaster risk in terms of terrain landscape that avoid landslides, as well as safeguarding environmental degradation and biodiversity loss. By maintaining nature-based solutions concepts in Subak will potentially encourage co-production of initiatives to ensure ownership and stewardships that address critical needs while conserving nature, restoring biodiversity, maintaining and enhancing ecosystem services. This eventually invites external support to make Subak more sustainable in ecosystem functional, economic stability, as well as social equity. Some issues found were lacking of government support, continuing stress from other sectoral development, declining farmers' regeneration, trading-related strategy, land use changes from irrigated agriculture to non-agricultural, water scarcity, environmental quality depletion, irrigation network management handover from local government to Subak people, and financial constraints. Subak consists of hundreds of Subak with their own nature and characteristics. Even in their daily activities in governing Subak and managing irrigation systems, there are a variety of local wisdoms, local knowledge, and mutual agreements under the same Trihita Karana philosophy among Subaks. Thus, their achievement, crop yields allocation, and how they implement adaptive management toward environmental changes are also different. Next slide, please. So we concluded that Subak is eligible as NBS with three societal challenges addressed. We need in-depth assessment in accordance with the IUCN guidelines. Subak needs to be well mainstreamed into strategic programs, policies, and regulations. Subak has to be included into regional infrastructure and development planning. And as published studies of Subak irrigation systems are mainly focused on the qualitative and monodisciplinary approaches in social sciences, with some extent on economic, but less attention on natural sciences, including ecology, hydrology, and natural resource management. So we recommend more studies on quantitative and dynamics approaches that use inter, multi, and even transdisciplinary approaches, elaborating ecology, economics, and socioculture as the three pillars of sustainability. By doing far beyond monodisciplinary approaches that combine with stakeholder engagement would hopefully promote stimulation for the protection and management of existing subak, as well as similarize their system beyond local and regional scale. We also recommend efforts of raising awareness of NBS concepts in all levels, as well as building an incentive program such as payment for ecosystem services to subak who consistent in maintaining the system sustainable. Next slide, please. So this is the end of my presentation. Thank you for listening. Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Ibu Risna, to see another aspect of ecosystem services related to the food security, environmental, and biodiversity aspect. Yeah, okay, thank you again. Very nice presentation. And the last presenter, invite the next presentation. Okay, please, Ibu Lailatus Saada.
Okay, hello everyone. My name is Lailatus Saada. I'm from IPB University, and now I will presentation of my research about spread and condition of growing places for Casuarina equisetifolia in the Lombang Beach area, Sumeneb Regency, Madura. Next. Introduction. According to Tohetero and Mahfud 2012, coastal forests have physical, ecological, and social functions, namely as an area for controlling the water cycle and seawater intrusion, and habitats, flora, and fauna. Generally, vegetation that grows in coastal forest ecosystem is unique because not all vegetation can grow in limited soil conditions. One of the vegetation that is commonly found is Casuarina equisetifolia. Casuarina equisetifolia is included in the genus Casuarina and the family Casuarinaceae is a type of tree that has unique characteristic of a place to grow. According to Atmanto et al. 2017, Casuarina equisetifolia is a plant that can adapt and live in coastal forests that have a limitation on abiotic forests such as temperatures,
tertarik dengan flora fauna yang ada di hutan?
Of the research plots was carried out by systematic sampling. The plots were made up of 3 lines, each with a size of 6 times 600 times 20 meter. Each line is divided into 3 zones, namely is front, middle, and back zone. Next. Number 2, vegetation analysis. Vegetation analysis data was collected using sample plots. Vegetation observation were carried out using the plot path methods by dividing each of 5 subplots. Subplots 2 times 2 for seedling and undergrowth data collections. Subplot 5 times 5 for sapling. Subplot 10 times 10 for poles, and subplots 20 times 20 for tree. Number 3, soil samples. Soil samples taken in all zone with a depth of 0 to 30 cm used by soil drill. Number 4, temperature sample. Temperature sample were dry and wet taken in all zone for 3 replication each. Next. The analysis data, the data analysis is important value index or EV, index dominance of type or C, species, and then species diversity index or H. Next. Result and discussion. Next. Table 1 shows the number of species in each growth stage in different is each zone. Overall, it can be seen that the back zone has a higher number of species than the other 2 zones. It can also show that the vegetation that grow in each ecosystem is not always the same and varies depending on the available environmental factors. According to Gunawan et al. 2011, EV or importance value index is an important role of a certain species in community. Next. Table 2 show that the individual species that had the highest EV and the seedling, sapling, poles, and tree, the same species. This is Casuarina equisetifolia. After that, for undergrowth level, the high EV was the Spigelia anthelmia. According to Harun et al. 2015, Spigelia anthelmia belongs to the Euphorbiaceae family and is one of the wild plants that can thrive in damp and rocky places such as on the banks of river and former rice field. These conditions are in accordance with the condition in the front zone. Next. Table 3 shows that the EV at the undergrowth level differed among the other regeneration levels. In the undergrowth, the highest EV was owned by Cynodon dactylon of 79%. This was also found in the research of Atmanto et al. 2017, which shows the species Cynodon dactylon, which has the highest EV with a clustered distribution. Group undergrowth is usually influenced by environmental factor and the same habitat condition where they grow, so that the species gather in the same area. Next. Table 4 shows that the undergrowth level Cyperus esculentus is the species that has the highest EV value of 18.6%. This is also in accordance with the research of Lubis et al. 2008, which shows that at the rehabilitation site of Ujung Brian village, Cyperus sp. This is because this species can live in the pasture formation, especially in dry sandy substrates. Next. Table 5 show the value of the dominance index or C at each plant level. The value of C range from 0 to 1 with the highest value at the real of 1. According to Nuraina et al. 2018, smaller the value of the dominance index or C, the more which spreads the type of dominant factor. This means that in the research environment condition of plant species at the undergrowth level, there is no concentration on N more significant than other level. Next, table 6 shows that the value of H range from 0 to 1. The value is found at the and level in the middle zone. Mean that the species is increasing. The greater the value of H indicates the forest has a high species diversity. Next. This is based on figure 1. It can be seen that the number of individuals at the underscore level in the middle zone, the total of 1,500 individual per hectare, while at the seeding level, the individual is found in the front zone of 4,000 individuals per hectare. According to Indriani et al. 2017, one of the environmental conditions that have the most influence on the understands, among others, is sunlight and shade. This is in accordance with the condition in the research zones. Next. Table 7.
Lailatus, could you make press, Lailatus?
Yeah, yes, sir.
Your time is 1 minute left.
Table 7 shows the percentage comparison is the highest percentage is the front zone with a percentage of 100% of or as many as 102 individuals per hectare. Next. This is a comparison of diameter classes with LBDS in the 3 study zone. Next. And this is figure 3 shows the different volume values for each diameter class. The highest volume was found in the species Casuarina equisifolia in front zone. Next. And this is a vertical structure. The different in species composition can be seen based on the color shown or in the visual.
Lailatus.
Halo.
Halo, Lailatus. Ya. Waktunya udah berakhir ya. Ya. Your time is up ya. Please go to the conclusion, Lailatus.
Okay, siap. The conclusion is
Lailatus. Hello. Or maybe have a problem with the connection. Lailatus. Halo, Lailatus. Lailatus, can you hear me? Halo, Lailatus.
I think she's not in the room, Pak.
Yeah, okay. Okay. I offer to the participant. We have still discussion session about 5 minutes. 5 minutes. Okay, whether we complete the discussion or we break for Salat. Yeah.
Pak Pungki,
Yeah.
Iwan.
Yeah, Pak Iwan.
Yeah.
Yeah, we have
my question.
Yeah, please, Pak Iwan.
First, my question for Ferda, yeah.
For Ferda, okay.
What the specific criteria for a forest area can use as forest healing, yeah. And second question for Ibu Latifah. What genus of Dipterocarpaceae have a largest biomass? And the third question for Lailatus. What the species which associated with Casuarina equistephalia in littoral forest? Thank you.
Okay, thank you, Pak Iwan. Pak Iwan have 3 questions. One to the Ferda, the second Ibu Latifah, and third Lailatus. Please make a simple, short answer. Start from Ferda, yeah. Ferda, please, Ferda.
Thank you, Mr. Iwan Hilwan, for the criteria of healing forests in Indonesia. In Indonesia, they are developing criteria based on the Undang-Undang Perumasakitan. So the criteria for hospital as a healing space, they will use the temperature, the humidity, and so for the comparing to the forest. So they will use that as the baseline of healing forests in Indonesia. But in other countries, they don't really have a specific baseline on the humidity and temperature. They have the overall condition gives comfort, and the activity is not exhausting.
Okay.
Thank you.
Okay. Okay. What about Pak Iwan? Enough, Pak Iwan?
Enough, yeah.
Enough,
Thank
yeah?
you.
Okay.
Yes.
Okay. The next is Ibu Latifah. Please, Ibu Latifah. Ibu Latifah. Halo, Ibu Latifah. Okay, we next to the Lailatus. Lailatus. Halo, Lailatus. Okay, but Ibu Latifah is still here in the room, yeah? Ibu Latifah. Okay, problem with the connection.
Yes.
Yeah.
I think now to the session, Pak Pungki, yeah.
Yeah. Okay. Is there any question? So we finish with the session, first session in the ecosystem services, forest biomass, and uneven age the forest. So before I close the session first, let me first that we have quite very good presentation. Yeah, all of the 5 of the presentation, and I hope that the presentation is benefit from the for the participants, and hopefully that we can make make a networking between us to develop our research. Okay, thank you very much for Ferda, Ibu Latifa, Ibu Rizna, and Lailatus and so maybe we have to break until at 13 at 1 o'clock, and then we go to the session 2. Okay, thank you very much. See you. Assalamualaikum warahmatullahi wabarakatuh.
Mr. Prianto.
Selamat menikmati makan siang, Pak.
Salam warahmatullahi wabarakatuh.
Ilmu silviculture memainkan peranan yang sangat penting dalam pengelolaan hutan berkelanjutan dengan memastikan keberlanjutan fungsi ekosistem hutan dan meningkatkan dampak positif sosial ekonomi dalam mempertahankan dan meningkatkan produktivitas hutan sehingga mencapai pembangunan berkelanjutan.
Fakultas Kehutanan dan Lingkungan IPB University bisa menjadi pilihan yang tepat untuk kamu.
Dilatar belakangi oleh hal tersebut, Departemen Silviculture Fakultas Kehutanan IPB University pada 10 dan 11 September 2019 melaksanakan kegiatan The Second International Conference on Tropical Silviculture dengan tema Forest Research and Innovation for Sustainable Development. Kegiatan yang berlangsung di IPB International Convention Center ini diikuti lebih dari 200 peserta yang terdiri dari para akademisi, peneliti, praktisi, dan pembuat kebijakan yang berasal dari berbagai negara seperti Indonesia, Amerika, Jerman, Jepang, Malaysia, Korea Selatan, dan Australia. Kegiatan ini diawali dengan sambutan oleh Wakil Rektor Bidang Kerjasama dan Sistem Informasi IPB University, Profesor Dodik Ridho Nur Rohmat. Dalam sambutannya beliau menjelaskan jika hutan tropis memiliki peranan penting dalam aspek konservasi keanekaragaman hayati dan aspek produk, baik produk kayu maupun produk non-kayu. Namun disayangkan hutan Indonesia menghadapi laju deforestasi dan degradasi lahan yang tinggi. Kondisi ini meningkatkan kebutuhan pengelolaan hutan yang lebih baik. Selain itu, beliau juga mengharapkan dengan adanya kegiatan konferensi internasional ini dapat memperluas pengetahuan dalam berbagai topik silviculture tropis.
Jadi tahun ini kita mengadakan 15 international conference, ya, salah satunya adalah international conference ya on silviculture. Ini yang kedua. Tentu saja kami berharap dengan banyaknya international conference yang diadakan oleh IPB, termasuk international conference pada hari ini, kita bisa menambah networking lebih banyak lagi dengan berbagai universitas dan peneliti dari luar negeri yang sudah punya nama yang dikenal di dunia internasional seperti Profesor Goldamer misalnya. Profesor Goldamer sangat terkenal untuk fresh fire dan juga profesor yang lain, Koran dan sebagainya, yang diharapkan nantinya kita bisa membuat riset bersama, juga kolaborasi dalam publikasi dan sebagainya.
Kegiatan konferensi internasional ini dilanjutkan dengan plenary session yang menghadirkan 4 keynote speaker. Pembicara pertama adalah Profesor Johann Georg Goldamer, Director Global Fire Monitoring Center atau GFMC, Max Planck Institute for Chemistry and Freiburg University, Jerman. Beliau menjelaskan presentasi dengan judul Revisit if the Freiburg Declaration on Tropical Fire of 1989, The Initiation of an International Agenda in Global Landscape Fire Science and Fire Management. Dalam presentasinya beliau menjelaskan bahwa diskusi ilmiah tentang perubahan iklim, penggundulan dan degradasi hutan sudah lama dilakukan, yaitu sejak 1980 hingga kini. Ditambahkannya degradasi hutan terjadi karena kebakaran hutan dengan berbagai sebab. Indonesia sebaiknya melakukan pencegahan, penekanan, dan rehabilitasi untuk mengurangi ancaman kebakaran hutan dan lahan.
Yes, today in my presentation to the conference, I spoke about the last 30 years of fire problems and the last 30 years of fire research in Indonesia and other continents. And over these 3 decades, we have made some progress in reducing the negative use of fire. But we are not yet there, we are not yet arrived at a point where we can stop completely the unnecessary or excessive burning. It is clear to us, of course, that fire is also needed in some land use systems, but we all need to work collectively together to reduce those fires that are destroying the very vulnerable and important ecosystems. So from this conference, I think we go ahead and are inspired to do more collaborative research work. And what is most important, to bring this message to our political decision makers, and so that they can make their best decisions based on the scientific evidence.
Dilanjutkan pembicara kedua adalah Profesor Horomi Mizunaga dari Fakultas Pertanian Shizuoka University. Beliau menjelaskan presentasi dengan judul Complexity of Leaf Arrangement and Ecosystem Services in Uneven Age Silviculture. Beliau memaparkan terkait struktur kanopi memainkan peranan penting silvikultur dan fungsi ekologis. Dilanjutkan pembicara ketiga adalah Profesor Mark Cochrane dari University of Maryland Center for Environmental Science. Beliau menjelaskan presentasi dengan judul Fire and Carbon Emission in Indonesia Peatlands. Dalam presentasinya beliau menjelaskan jika kebakaran hutan menyebar dengan cara yang sangat bervariasi, baik secara horizontal maupun vertikal. Sedangkan kehilangan volume gambut per unit meningkat secara substansial seiring dengan musim kemarau yang berkelanjutan. Dilanjutkan pembicara keempat, yaitu Dr. Agus Justianto dari Badan Litbang dan Inovasi Kementerian Lingkungan Hidup dan Kehutanan. Beliau menjelaskan presentasi dengan judul Government Policy on Forest Research and Innovation. Dalam presentasinya, beliau menjelaskan peran signifikan hutan tropis Indonesia sebagai aset nasional dan global. Selain itu, aplikasi untuk mendukung SDGs oleh Badan Litbang dan Inovasi KLHK di Indonesia telah banyak diterapkan melalui bidang sosial, konservasi, ekowisata, dan restorasi. Kegiatan konferensi internasional ini dilanjutkan dengan sesi paralel yang dibagi ke dalam 7 tema besar, yaitu biodiversity, forest fire and climate change, agroforestry and forest plantation, ecosystem services, non-timber forest product, uneven age silviculture, dan forest degradation and rehabilitation, di mana setiap kelas sesi paralel terdapat pembicara utama. Selain itu, pada konferensi ini juga dilaksanakan presentasi poster terkait 7 tema besar tersebut. Diharapkan melalui kegiatan konferensi ini dapat memberikan banyak peluang untuk berbagi ide-ide baru dan riset bersama untuk kemajuan pengelolaan hutan tropis di Indonesia dan global. Pipit Sativa dan kru yang bertugas melaporkan untuk Green Highlight.
Indonesia terletak di lintasan garis khatulistiwa yang membentang dari Sumatera, Kalimantan, hingga Papua. Keindahan alam Indonesia yang terdiri dari pesisir pantai, gugusan pulau-pulau, barisan pegunungan, dan hijaunya hutan belantara menjadikan Indonesia disebut sebagai Jamrut Khatulistiwa. Keragaman hutan Indonesia merupakan rumah bagi berbagai kehidupan yang ada di dalamnya.
Hutan perkasa yang dulu menyelimuti pulau-pulau ini sebagian besar telah hilang. Tinggallah bentangan hutan utuh di Papua sebagai pemilik hutan terakhir di negeri ini. Saat ini, hutan digunduli, sejumlah besar gas rumah kaca yang dilepas ke udara, dan dengan demikian mendorong kita lebih cepat ke titik di mana kita tidak bisa kembali ke dampak perubahan iklim.
Selamat datang di Departemen Silviculture, Fakultas Kehutanan dan Lingkungan IPB University. Departemen Silviculture IPB berdiri pada tahun 2005 yang sebelumnya berada di Divisi Budidaya Hutan, Departemen Manajemen Hutan, Fakultas Kehutanan IPB. Pada tahun 2013, Departemen Silviculture meraih akreditasi A dari Badan Akreditasi Nasional Perguruan Tinggi serta memperoleh sertifikat ASEAN Quality Network Assurance pada tahun 2015. Pada tahun 2016, Departemen Silviculture IPB dan departemen lainnya di Fakultas Kehutanan IPB bersama-sama menerima sertifikat SNI ISO. Departemen Silviculture IPB memiliki fungsi menjadikan Departemen Silviculture sebagai program studi terkemuka dengan kompetensi utama silviculture tropika berkarakter kewirausahaan dan bersendikan keharmonisan. Departemen Silviculture IPB memiliki misi yaitu menyelenggarakan pendidikan tinggi yang berkualitas berbasis penelitian untuk menghasilkan sumber daya manusia yang berkualitas dan untuk menjamin fungsi ekologis, kesehatan, dan produktivitas ekosistem hutan secara berkelanjutan sehingga menjadikan Departemen Silviculture yang berperan sebagai trendsetter bagi masyarakat profesi kehutanan. Departemen Silviculture IPB menjadi lembaga pendidikan tinggi yang mampu mengantisipasi dan menjawab berbagai permasalahan pembangunan kehutanan secara ilmiah dan profesional dengan sistem manajemen berorientasi pada mutu dan profesionalisme. Departemen Silviculture IPB memiliki mandat dan pengembangan ilmu dan teknologi silviculture yang diperlukan untuk membina hutan alam serta membangun dan membina hutan tanaman secara berkelanjutan berbasis ekosistem. Kompetensi di Departemen Silviculture IPB mampu menyerapkan ilmu dan teknologi silviculture untuk menjamin fungsi ekologis, kesehatan, dan produktivitas hutan sesuai kebutuhan dan nilai-nilai hutan yang diinginkan secara berkelanjutan. Departemen Silviculture IPB memiliki bidang kajian yang luas, menarik, dan aplikatif, sehingga dalam pelaksanaannya, Departemen Silviculture IPB dibagi dalam 3 kajian divisi, diantaranya Divisi Ekologi, Divisi Silviculture, dan Divisi Perlindungan Hutan. Bidang kajian ekologi hutan meliputi hutan mangrove, hutan rawa gambut, hutan dataran rendah, hutan pegunungan, ekosistem das, tanah hutan, nutrisi hutan, restorasi hutan, reklamasi lahan pasca tambang, biodiversitas, botani hutan, dan lainnya. Bidang kajian silviculture meliputi genetika dan molekuler hutan, perbenihan dan persemaian, sistem silviculture, agroforestry, permudahan hutan, mikoriza, rhizobium, bioteknologi kehutanan, reklamasi pasca tambang, biodiversitas, dan lainnya. Bidang kajian perlindungan hutan meliputi patologi hutan, entomologi hutan, jamur hutan, mikrobiologi hutan, hama penyakit hutan, kebakaran hutan dan lahan, kesehatan hutan, gangguan hutan, perubahan iklim, biodiversitas, dan lainnya. Fasilitas yang ada di Departemen Silviculture meliputi laboratorium, ruang kuliah, rumah kaca, dan persemaian. Program Sarjana Silviculture akan meraih gelar Sarjana Kehutanan. Program Pasca Sarjana Silviculture Tropika akan meraih gelar Magister Sains, dan program Strata 3 akan meraih gelar Doktor. Berbagai inovasi telah diberikan oleh Departemen Silviculture yang diantaranya sudah dipatenkan. Jejaring kerjasama internasional Departemen Silviculture meliputi sebagai berikut. Jejaring kerjasama silviculture yang ada di dalam negeri sebagai berikut. Peluang kerja Departemen Silviculture tercatat bekerja di berbagai bidang meliputi. Selain aktif di kampus, mahasiswa Departemen Silviculture IPB juga aktif dalam himpunannya dengan berbagai program kegiatan yang dilakukan pada setiap tahunnya untuk meningkatkan soft skill, keterampilan, kreativitas, dan hobi. Beberapa kegiatan tahunan yang dilakukan mahasiswa Departemen Silviculture meliputi ekspedisi flora dan studi ilmiah, TGC in Action, dan aksi mangrove. Departemen Silviculture IPB membangun kejayaan hutan untuk kebanggaan dan kesejahteraan bangsa.
15 centimeter. The observation included that after transplanting in the nursery. For the Fibroria tinctoria, the field planting trial was conducted in dry land, like in this picture, in this the wetland. The wetland is near river banks and occasionally flooded.
Everyone hear my voice? Okay. I will start, Ibu Dokter.
Yes, please.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Today I would like to present my research on the effectiveness of biological and botanical pesticide against Ionaspis sp on sandalwood in South Central Timor Regency, East Nusa Tenggara. Before I start my presentation, let me introduce myself. My name is Henny. I'm a researcher for Environment and Research for Development Institute of Kupang, Ministry of Environment and Forestry. And here in the outline. And sandalwood or Santalum album, the highest valuable fragrant wood of the Sandalaceae family. This is the one of the endemic species from Indonesia, especially in the east part of Indonesia. And in East Nusa Tenggara, sandalwood known as haumeni. This means that the wood that produce fragrant or fragrant wood, and this is the symbol of unity and livelihood of family. And then because the sandalwood is identical to the social culture of the local people, so this species sandalwood was decided as the icon of East Nusa Tenggara province. Okay, in Indonesia, based on the research, sandalwood that grow in Indonesia is have the highest santal, especially sandalwood that grow in Alor and Sumba Island, compared to other sandalwood that grow in other countries such as China, Sri Lanka, and India. And then because of it, the demand of the sandalwood from Indonesia is high. Consequently, the overexploitation of the species resulting in the declining of the population of sandalwood in the natural habitat. The effort has been addressed to conserve the species. One of them is develop the sandalwood plantation. However, the occurrence of the pest scale insect disease, the Ionaspis, is one of the obstacles to developing sandalwood plantation. And then the Ionaspis belong to the Aspidae family. This is the picture from the previous study. And then this is one of the sucking insect and one of the most destructive sandalwood pests besides the termite, steam borer, and also the foliator, because causing the death of the sandalwood plant. And
something productive, so we have to invest.
Young coconut red. Where
will help in providing planting stock for cultivation, because
by chemical pesticides with the carbaryl active ingredient 0.
So we are missing written records on the land uses at that time. So the challenges are, we should regain ecological functionality and enhancing human well-being across these deforested and destroyed forest landscape. So we see ecological functionality that has something to do with the forest itself and enhance human well-being.
Conductivity, liming potential, CEC, and cation base, calcium, kalium, and natrium exchange, C inorganic and C organic compared to other sites. Finer sites have a greater potential to replicate
rapidly interact in the soil. Thank you for listening. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Arista. You still have 2 minutes more. It's okay. We can save for the discussion. For the second presenter, we call Mr. Amsar Maulana. Please.
Okay, Miss. Okay, thank you very much for the opportunity for me to presentation in ICTS 2021. So, and my topic, my research is a web of method on characteristic of biochar from young coconut western as amelioran. Introduction, me and student PhD of Agricultural Faculty Universitas Andalas Padang. So next, introduction in my research is waste management and development in the representation and
with my colleague, Dr. Yoko Takematsu from Yamaguchi University, the late Professor Tsuyoshi Yoshimura from Kyoto University. And this work will be the last collaborative research with Professor Yoshimura because he passed away last May. Okay, my talk today is about termite. Some characteristic of termite is grow.
Local people for many purposes, such as for their diet and traditional medicine.
Stopopic observation is control, and the lowest is in the limb formulation. And then this is the picture from the before after limb pesticide application. This is the before after metarism and control. After that, we calculate or measurement the pesticide efficacy, and the results show that the neem and the efficacy of neem formulation in nursery is highest, is around 50.86%, and then in the plantation also neem saw the highest pesticide efficacy is around 68%. And however, in the plantation there are other 3 pesticides that also effective to inhibit the scale insect attack. They are Biovaria, chemical pesticide, and Carino, because the efficacy is more than 50%. It means that the pesticide is effective. And in general, we can say that pesticide treatment can be inhibit the sandalwood scale insect, and the new formulation is consistently shown the highest efficacy value both in nursery and plantation. And then the botanical pesticide is neem or Carino, also is effective to inhibit the pest attack. Have many benefits. There are eco-friendly, of course, and then more effective, more efficient, because it's in terms of availability, raw material availability, and then simple technology, and also low cost. Okay, that's all my presentation. Thank you.
Thank you very much, Mrs. Henny, for a nice presentation. Please wait patiently for the discussion. So we are moving to the next presenters. Mr. Samuel Apambunan. He will deliver a presentation entitled Carbon Sequestration Potential of Pine Stands, Pinus mercusi ijang at the Fresh in the Toraja Highland. For Mr. Samuel, time is yours.
Yeah, thank you. I want to deliver myself to my PowerPoint from here. It's okay?
Okay, yes. Bu Henny, could you stop the share screen? Thank you.
Okay, it's okay. Yeah, thank you.
Yeah.
Thank you very much for moderator, Dr. Adisti. for the time given to me to present my research entitled Carbon Sequestration Potential of Pine Stand or Pinus mercusium at the Freeze in Toraja Highlands, South Sulawesi. This research is doing by 3 persons, me, Nurkin, and Lande. We are from the Faculty of Forestry, Hasanuddin University. As the background of this study, that it is now that climate change has occurred.
Characteristic analysis of biochar, the book Biochar Integrated Analytic Method, Analysis Biochar Properties in the SIG et al. 2017 and Balai Penelitian Tanah 2012. So the next production is biochar in this analysis statistic in tools SPSS or EMB 16 statistic 8 and Microsoft Excel 2016. So next in the result and this my research in the production of biochar from young coconut waste, and so the temperature, moisture and drying weight and yield ratio of young coconut biochar young coconut waste are all significant effect to be optimum of your production with the time of techniques and like your duration varying is not. The result of production first type method and have and very significant and temperature measuring dry weight and yield ratio biochar young coconut waste. So in the recommended in the biochar in production of biochar from young coconut waste is quantity because the yield ratio in the high to method here. Next. The characteristic in production biochar young coconut waste, this in effect of biochar production method very significant pH and liming potential in the but is electrical conductivity not significant from production biochar young coconut waste because characteristic of biochar production with effect method in the effect temperature of feedstock in the dan suhu in temperature and production in the determination and pH then and liming potential. So next. So in characteristic CSC and cation base in of biochar young coconut waste to very significant to method and proximate analysis and young coconut waste biochar in you very significant and C and C organic and C organic biochar young coconut waste very significant to all the characteristic biochar to production biochar in an effect method is very significant to characteristic of biochar. Now next. Okay, conclusion research the effect of manufacturing technique biochar production with method significant on temperature, moisture and dry weight and yield ratio biochar and characteristic biochar from young coconut waste on pH, liming potential, proximate analysis, volatile matter and as and fixed carbon, CSC and cation base and C organic and C organic with the recommended method of biochar production use the quantity method. So next and acknowledgement. Thank you for author and for your assistance from FIM introduction cause of Belgium and chemical laboratory and soil research in Bogor. Thank you very much and listening. Back to moderator.
Thank you, Mr. Ansar. You can manage the time. For the third presenter, we call Ibu Herianti.
We focus if we want to work in this, and this forest landscape restoration has a big potential. I think there's a lot of funding available soon that we need to train us more in close to nature forestry a little bit more than we have done already. Yeah, so this is some references, and then I would like to thank you very much and still apologize for coming too late because I missed the other way around. I thought Indonesia is forward in time, but it's just the opposite. So I apologize to come too late.
Okay.
Thank you very much.
Okay.
Thank you.
Okay. Thank you. Thank you so much, Prof. Ralph. So it's absolutely fine, Prof. Ralph. It's also maybe our mistake that didn't inform you from the first that we have just 6 or 7 hours difference between the countries. Okay, but anyway, do you have a time for around 30 minutes, Mark? Prof? Hello?
You can start now the presentation.
Alright. Assalamualaikum warahmatullahi wabarakatuh. The Honorable Mr. Cahyo Wibowo as a moderator and all the participants in this room. Good afternoon. My name is Salma Zubaida. I would like to present our research. The title is Seed Ball Coating Material Formulation to Enhance Germination and Growth of Fruit and Forestry Seeds. Next. Here is the content of the presentation. Next. First is introduction. Mining business is an activity in the context of mineral or coal exploitation. The existence of the mining causes ecological imbalance. The ex-mining land cannot be reused, so it is necessary to rehabilitate the ex-mining land. One of the ways to carry out post-mining land reclamation is by using seed ball. Seed coating provides the seeds with a nutrition and protection so they could survive on degraded area. Formulation of material to enclose the seed is important and could be specific for different seeds. The clay content of seed balls can reduce water deficiency by increasing water potency and help to prevent the seed from being eaten by insect and bird. The aim of this research is to determine the appropriate formulation of seed balls to enhance specific seeds. Next. Next, please. Okay, methodology. The research was conducted from February until July 2021 and carried out at the greenhouse of IPB University, Bogor, West Java. The variables observed in the study were germination rate, seed viability, and seedling height. Next. Here is the material and equipment we use for this research. Next, please. Okay, data collecting procedure. First is dormancy breaking. Dormancy breaking is used to accelerate the germination of the seeds, especially orthodox seeds. In this study, we use merbau and gmelina seeds. Merbau seeds were done by the mechanical scarification technique, by knife to allow moisture and air absorbed to the seeds. The seeds are then soaked in water for 24 hours. Gmelina seeds were done by soak in water for 24 hours. Jackfruit, butterfruit, and durian were not given dormancy breaking treatment. They are recalcitrant seeds. Next, please. This research is carried out to determine the appropriate materials composition. The coating material composition is divided into 3 treatments according to Table 1. Formula A use clay and compost. Formula B use clay, compost, and insecticides. And Formula C use material clay, sawdust, bone meal, and vermicompost. Tests were carried out by planting seeds in the form of seed ball in soil, compost, and sand with ratio 2:1 as a media.
Peatland is a wetland ecosystem formed by the accumulation of organic matters on the forest floor from the debris of the vegetation above it over a long period of time. This accumulation occurs due to the slow rate of decomposition compared to the rate of accumulation of organic matters on the wet forest floor. Nur added that tropical peat soil are formed through a paludification process. Because of the unique materials and formation processes, the properties of peat soil are different from the mineral soils. The peatland has a low density, high acidity, very high organic matter content, high porosity, and high cation exchange capacity value. Peatland have a very important role for human life and other living things. The peatland as a source of freshwater fish, habitat diverse living creatures, food control, and etc. And peatland also has a role in global climate control because of their ability to sequester and store carbon. The increasing demand for land in various sectors has led to land clearing activities in peat areas. Land clearing is done by logging or burning, and it affects the properties of peat soil. Peatland management by burning can affect the chemical properties of peat. In the short term, fire that destroys soil organic matter can affect on increasing nutrient availability, according to Firmansyah and Subodh 2012. And this study aims at analyzing the chemical properties of peat soil on 4 land management areas in Teluk Bakung Village, West Kalimantan. For the method, this research was conducted on 4 land management areas in Teluk Bakung, which is burn land, taro plantation with burn land management, taro plantation with non-burning land management, and rubber stand. So samples were taken in pot measuring 20 meters times 100 meters at each location. Disturbed soil sample used for analysis of chemical properties. Disturbed soil samples were taken from 5 points in each plot using a shovel at a depth of 10 till 0 centimeter. All soil samples were composite evenly to take 1 kilogram and put into a plastic bag. The chemical properties that were analyzed is soil acidity, soil organic carbon, S content, nitrogen total, available phosphor, cation exchange capacity, and base cation. And for the result, first is soil acidity. Peat is generally has a high acidity level. According to Hartatik, peat soil
In this study, seed bowl play a role in maintaining seed moisture so that water content is
in taro plantation with non-burning land management or TTB with value of 4.64, followed by taro plantation with burn land management and followed by burn land or 80 and rubber stand or takey with 2.97. It might be effect of the application of lime to land preparation in taro plantation with non-burning land management site. The application of lime on peat soil is technically the best thing in increasing the pH value of peat soil. Ilham added that effect of lime on peat soil can improve soil pH value, base saturation, increase calcium and magnesium element, and reduce the availability of toxic organic compound. Next is for soil organic carbon. According to Hartatik, peat soil is formed from a pile of organic matter so that the carbon content in peat soil is very large. And the result showed that rubber stand is the highest soil organic carbon compared to the other 3 sites with a value 53.66%. It might be influenced by the higher input of organic matter in rubber stand. Aristio reported that adding a lot of input or adding organic matter to peat will increase the content of existing organic acid, so that there will be an increase in the organic carbon value in the soil. Or the next is S content. According to Nur, the S content of peat soil in Kalimantan has a value between 11 to 41%. And the S content of peat soil indicates mineral content in the soil, which is negatively correlated with organic carbon content. And based on the result, taro plantation with burn land management has the highest value of S content with 14.91, followed by taro plantation with non-burning land management, burn land, and rubber stand. Nor added that peat S content is very low, except in soils that have experienced fires or have been cultivated intensively. Next is for nitrogen total. Based on the result, the nitrogen showed that the highest nitrogen is in burn land with 1.79, followed by taro plantation with burn land management, taro plantation with non-burning land management, and rubber stand. According to Agus, the total nitrogen content of the tropic peatland in some areas in Indonesia range from 0.3 to 2.1%. The high value of nitrogen in burn land can be affected because of mineral element that released due to fire. Purnomo also added that the increase in nutrients was caused by the addition of nutrients from ash of biomass combustion. But the availability of post-burning nitrogen nutrient increased, but the increase only effect in the short term. And for the next is available phosphor. Based on the result, the highest available phosphor content was in burn land with 153.69, and followed by taro plantation with burn land management, taro plantation with non-burning land management, and last is rubber stand. The increase in available phosphor in fire is caused by the release of organic phosphor and mineralization of soil mineral matter as a result of high temperature. Sulaiman also added that burning is beneficial in increasing the pH value and converting the unavailable phosphor, which is stored in peat organic compound, into available forms. And for the cation exchange capacity,
Citra, you have 2 minutes more.
yeah. The value of cation exchange capacity in peatland is very high. According to the result, the burn land has the highest value compared to the other three sites with 113.39. The residue of the burning process could increase cation exchange capacity according to August 2019 and Mintari 2019. And the last is for the base cations, and the result showed that for the calcium and magnesium value, the taro plantation with non-burning land management has the highest value with calcium for 22.38 and magnesium is 6.36. This might be influenced by liming activities during land preparation, and the result of the study of Ilham also added that there was an increase in the value of calcium and magnesium in peatlands that were given dolomite lime. And for the potassium and sodium, based on the result, the highest value was obtained in burn land, with potassium value is 2.78 and natrium value is 4.48. This might be affected by fire that occur in the area. Generally, fire increased the availability of all cations. Ralph added that burn peat soil will have a high potassium value because land fires will increase the concentration of exchange bases in the soil, including the potassium value. However, Agus added that the change in the chemical characteristic of soil took place temporarily. And for the conclusion, the result of the study showed that the parameters of the chemical properties at each site had various value. Burn land had the highest nitrogen, phosphor, potassium, sodium, and cation exchange capacity value. Meanwhile, the highest pH, calcium, and magnesium value were in taro plantation with non-burning land management. Then the highest S content values were in taro plantation with burn land management. For the value of soil organic carbon, rubber sand had the highest percentage compared to the other land condition. And this is the references that used in this presentation. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Pak Irdika Mansur. Good afternoon, ladies and gentlemen. Thank you very much for the opportunity for this afternoon. Today, this afternoon, I will present one of our research about the empty palm oil buds as the growing media for white oyster mushroom or Pleurotus osteratus. Next. Okay, I'm Irata Skrawati. I'm from Hasanuddin University. Next. Okay, naturally, oyster mushroom grow on the dead wood, or we call log. Oyster mushroom is the one of the organism that can decompose wood, and this mushroom have a delicious taste and rich of nutrients. Because of that, there's many farmers try to cultivate this mushroom. For cultivate this mushroom, usually we making artificial growing media. We call that backlog. This media actually we made from the sawdust. For example, sawdust of the sengon, gamelina, or candlenut. Several researchers try to find another alternative to replace the sawdust to another material like mulberry wax, and then sagon pulp, coconut fiber, and then bamboo wax. In this study, utilize waste of empty palm oil buds as a medium used to the grow of the mushroom. But for as you know, empty palm oil buds still have oil. So next, please. This study aimed to determine the duration of soaking the empty palm oil buds as a pre-treatment before this material we using as a growing media for white oyster mushroom. Next. So before being use a media, empty palm oil buds we cutting into the small particle, and then we make it a powder. This research step from the preparation media, and then mixing raw material, sterilization, inoculation, maintenance, and also observation. Next. There are seven, next please. There are 7 treatments we apply for the pre-treatment in this study. First, we soaking in the cold water in the 5 days, and then in the 7 days, in the 9 days. And then we also soaking in the hot water at 100 degree Celsius for 1 hour, for 2 hours, for 3 hours. And then there's for control, we using material without soaking. Next. For the variable, there are 5 variables observed in the study. First, we observe the mycelium growth time, and then the growth of pinhead. The third is harvesting time, and then the 4 is weight of the fruiting body, and then the number of fruiting body. Next. As the result, next please. Next. Okay. As the result, in the cold water is the best. It was the best performance, the best treatment, especially in when we soaking the media at the cool water for 7 and 9 days. The mycelium will grow on 20 until 23 days after the inoculation. However, on the if we soaking the material on the hot water, the treatment is more slow for the growing of the mycelium, but the faster one we can get in the treatment for the we soaking in the hot water for 1 day. For 1 hours. Next. Okay, still in the cold water, the soaking treatment get the good media in the cold water for 5 days. In this media, we can get only 52 days after inoculation. We already get the pinhead. And then, in other hand, in hot water, the backlog faster still in the hot water for soaking on the hot water for 1 hours. Next. Okay. In the last research, we get that the time for fruiting body after the pinhead first time grow is around 2 until 3 days. And this case, same in this study, we get around 2 until 3 days after the first time the pinhead grow in the media. So if we account from the first inoculation until we can harvesting this mushroom for the media which we soaking in the cold water for 5th day, we can harvest this mushroom for 55 days. But if we treatment in the hot water is more slowly, more slow, we can harvest around 67 days. And next, we also get the high weight for the fruiting body of fungi if we grow the fungi in the media in the soaking cold water. We get 110 gram for per backlog for the first time harvesting. But if we cultivate in the hot water, we only get 65 gram for the first harvest. And then for the number of fruiting body, we also get that the treatment T2, they are soaking in the 7 days, 7th day in the hot water, we get around 60 fruiting body. So for conclusion, okay, it's already next. Okay, for conclusion, first pre-treatment on the empty palm oil buds effect for fungal growth, especially for the oyster mushroom. And then empty palm oil buds powder with the cool soaking, especially for 5 days, is the best the best media for the growing oyster mushroom. And then empty palm oil, we recommend that they have a potential to use as growing media for oyster mushroom. I think that's all for my presentation. Very much for attention.
Thank you, Bu Ira. We will have another presenter on mushroom this afternoon later. But for the moment, you can post the question to Bu Ira in the chat box, and then we will discuss later. And we continue with presentation by Bu Diana. Diana, time is yours.
Yeah, thank you, Mr. Irdika. My committee, my PPT.
Okay.
Good afternoon, ladies and gentlemen. My PPT is from in the committee.
To overcome
The number of hotspots.
Okay, Sengon Paraserianthes falcataria is plant from the Fabaceae family, which belongs to the fast-growing species. Sengon is a versatile pioneer fast-growing.
Juan Sodik, you can start the presentation now.
Okay, thank you very much, Mr. Cahyo Wibowo. Okay, I'm Ikhwan Sodik Shifaudin. I would like to present my research about pathogenicity test of fungal leaf blight on Sengon seedlings at permanent nursery Dermaga Bogor. Next. Okay, Sengon Paraserianthes falcataria is plant from the Fabaceae family, which belongs to the fast-growing species. Sengon is a versatile pioneer fast-growing, able to adapt to various type of soil, good silvicultural characteristic, and wood quality accepted by the timber industry. Sengon is often used in forest and land rehabilitations. In addition, Sengon is also grown independently by the community in an agroforestry system. And then Sengon has a canopy density that is too high, and its roots can be in symbiosis with rhizobium to support the growth of plant underneath. Sengon has several regional names like Albasia, Jengjing Laut. And then Sengon also has different names in different countries like Batai and Maciswood in Sarawak and Puah in Brunei. And then Sengon seedlings in the nursery are susceptible to disease. Several previous studies, the disease found in Sengon seedlings is the cause of dumping off, Fusarium sp, the cause of Euromycladium teperianum, the cause of tumor rust, and Oidium sp, cause of powdery mildew disease between pathogens, host, and environmental. And the environment interacting with each other are known as the disease triangle concept. And this study aims to examine the level of pathogenicity of the pathogen that cause leaf blight on Sengon. Next. Research that was conducted in October 2020 to February 2021 at Permanent Nursery Dermaga Bogor and Laboratory of Forest Pathology IPB University. And the tools used in the research we can see in the slide, and the materials we see in the slide. There are Sengon seedlings, cotton media, alcohol, and aquades. Next, please. And then this is the research procedure. There are 3 procedures. For the first one is pre-test or pre-pathogenicity test. And then next, that is media creations, field observations, and inoculum source preparations. And for the second one is pathogenicity test. It's calculate disease incidence and disease severity. And the last one is identity microscopic, such as colonies, sclerotium, and by microscopic like partitions, angles, and spores. Next. Okay, this is for the formula that used in the research. And then this is incidence according to Agrias 2005. And then the disease intensity, disease intensity was calculated using the infections category scoring in table 1. The infections category scoring makes it easier to determine attacks to be included in the calculations of disease severity. And then the result of the grouping are based in top table 1. Then the calculations of disease severity use the formula by Firmansyah. Okay. Okay, next. Okay, this is the result and discussions. Symptoms of leaf blight were found in Sengon seedlings aged 3 months after weaning. Based on the field observations, leaf blight symptoms on Sengon seedlings were found in almost all space in the nursery. Leaf blight is indicated by the color change on the leaves. We can see in the figure 1 where the red arrows show symptoms of leaf blight on Sengon. Symptoms found in Sengon seedlings. Back to previous slide. Okay. Symptoms found in Sengon seedlings start from the tip of the leaflet and then spread to all parts of the leaf and other seedlings. Okay, next. Okay, all isolate obtained in the field were used in the pathogenicity test. We can see in figure 3, isolate 1 resulted 100% of disease incidents and 87.5% of disease severity on the 9-day observations. Isolate 2 resulted 37.5% of disease incidents and disease severity, and for the isolate 4 resulted 12.5% disease severity. And then for isolate 3 didn't produce disease incidents and disease severity. Okay, next. Next, okay. The result of Duncan's multiple range test in table 2 show that the isolate 1 was significantly different from the isolate 2, 3, 4, and the control in producing the disease incidents on the host. Okay, pathogenicity according to Brang et al. Okay, according to Brang et al., there are 2 processes required for pathogenesis: survival and growth of infected microorganisms, and host damage manifests as disease symptoms. Next. Okay, this is the result of identifications. Identifications was carried out on isolate that produced the highest disease incidence and disease severity and significantly different from the control. That is isolate 1. We can see in figure 4. The result of microscopic observations of the isolate 1, the colonies is white, and then the older they turn brown, and the sclerotium was spread unevenly at the edge of the petri dish, and then the sclerotium is irregular in shape and the color is dark black. And then based on the microscopic observations, figure 4b, isolate 1 had characteristics similar to Rhizoctonia sp. This character include no spores according to Burnett and Hunter, and then 90 degrees branching angle according to Gondal et al. Insulated hyphae according to Ahmad and Mansairo, and then hypha clipping according to Despani et al. And then there are monilite structure according to Fosfodic et al. We can see for the red arrows indicate monilite structure. We can see in this slide, and then for the yellow arrows indicate 90 degrees angle, partitions, and hypha clipping. Next. Okay, for the conclusions, there were 3 isolate. I'm sorry, it is 3, not 4. 3 isolate of the fungus that caused leaf blight in the field, and then the incidence of disease caused by the fungus isolate 1 was very severe produce 100% of disease incidence and 87.5% of disease severity. And then the result of fungal identification showed that isolate 1 was the fungus Rhizoctonia sp because they have similarities based on observations of macroscopic and microscopic characteristics. Okay, next. Okay, this is for the reference. Next, thank you very much. Good afternoon, everyone.
Okay, finish. Okay, thank you, Iwan Sodik, for the presentation.
Just peatland, and September in Muar Jambi district is the peak of dry season, and mostly burn area found on peatland. Prevention of forest and land fires in peat areas has not been maximized due to a lack of public awareness to maintain and protect environment sustainability. Next, please. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you so much, Mbak Rara Fatih. So we come to the discussion session. We have around 15 minutes. Sorry. I will check. Is there Ise Afifah is in the room? But the next presenter should be Ise Afifah. Ise Afifah is in the room. No, I don't think so. So how about Pak Sigit Sutikno? Actually, we have 5 presenters, Rob, but I think the 2 presenters from them are having another conflicting agenda. So, okay. We are coming to the discussion session. We have around 15 minutes. So any one of you that has the question for Pak Rauf or Bu Citra or Mbak Farah or Mbak Rara Fatih, please raise your hand or okay, or write your question in the chat room. I think it will be fine if you are worried to ask in English. You can ask in Bahasa. I think Pak Rauf is also understand Bahasa ya Pak Rauf.
Yes. Few words, it's true, yeah. Don't worry. Need not to be shy. Yeah. I'm also not shy. You know.
Yeah, don't be shy to speak in English ya Pak Rauf ya. Because if you don't speak, everyone didn't know you can speak English or not. But if you speak, but if you speak and you are wrong, so we can correct your pronunciation and so on.
Please.
Yeah.
Yes. Can I ask a question first?
Okay.
Because so many ladies, they talk about fire. Okay. Fire in Sumatra and Kalimantan. And my question is, this fire application, is this very much linked to oil palm plantations, or are there also other reasons?
Okay. Who will answer the question? Citra, please, you can answer, I think.
Maybe I give it try. So I think the fire and oil palm is any relation, because in this in my location, some of the site is burned, and then after a year it became a oil palm plantation. But in my location it's not big, very big, or for it's not for perusahaan. It's not for
Company.
it's a company, but it apa, dikelola oleh masyarakat.
Managed by
Managed
the
by
local people.
the local, yeah.
Yes. So, yeah, actually, we have maybe some problem with the oil palm because many of the companies are using fires just to prepare the land. So before they start planting the new oil palm plantation, sometimes they just use the fire because fire is very cheap comparing to the mechanical land clearing.
Can I ask a little side question to this, or is it not okay?
Okay, it's fine. We still
Because
have time.
I have been to Sumatra, to Sungai Air River,
yeah.
And there the peat was 10 meters.
Oh.
Yeah, there was still gelotong growing in the natural forest, ramin, and it was 10 meters. Does it mean that all these 10 meters will burn, or how much will burn from these 10 meters? How much? Just to understand, yeah?
Yeah.
That's my question.
Okay, thank you so much. Rafati, Farah, wanna answer? Oh, they are answering by a smile, Rob.
Yes. Maybe that's the best answer.
Okay, it's just like a tricky question, yeah, because gelotong is the endemic species for the peatland, so gelotong can grow better in the peat, yeah. And if you ask how many meters they burn, I think it's depend on the location and depend on the lot of parameters that we have to concern about the peat burn and how deep is the peat burn and so on, because it's related to the groundwater level, regarding to the water content of the peat, yeah, and regarding of the hydrology and so on. So I think the tip of the peat burn is vary from place to place.
Thank you.
So,
thank you very much.
Yes, there's a question from Andita Minda. You raise your hand, Andita. Okay, please, Andita Minda. You wanna ask something? You have a question?
Yes,
No?
I have a question for Prof. Love.
Okay. Okay, and you
about
have no answer.
About the
Okay.
management strategy that we use to manage forest fire that very wide and comprehensive to do. I'm concerned with the fuel as the strategy for land fire management, but it is so difficult to apply on the field. And I want to ask, do you have advice for us for manage land with the wide and comprehensive in the field? Just it. Thank you.
Okay. Thank you, Andita. That's a very good, nice question.
Thank you. Thank you very much for you asked me an idea of management to prevent fire, yeah? To prevent fire. Was that your question?
Yeah, I think the question is how to manage the how to manage or to restore the land after the fire.
After the
just
fire.
like a land fire management. Yeah.
Yes. After the fire, usually there will be a succession. I think first a fire in the evergreen moist forest or in the peat swamp forest, ramin, gelotong, and so on. Previously, there has rarely been any fire because this is evergreen moist forest.
In carrying out material and method. The root sample use study was taken. The average root colonization
media are then
of them. So have you maybe had a prediction when maybe the carbon sequestration will be stuck or maybe low and etc.?
Yeah. Okay. Thank you for this question. I think plantation is not far from the photosynthesis, and the carbon sequestration is done or is absorbed through the activity of photosynthesis. So if the plant is still active in doing photosynthesis, it means that the carbon sequestration from the atmosphere still going on, still be absorbed. So it is have a close relationship with the growth of the plants, because we know that the photosynthesis occurred in the leaf. So the bigger the tree canopy, the higher the carbon dioxide can be absorbed through the carbon dioxide sequestration. I think it is the relationship. So if the stem have achieved the, how to say, the age that cannot make progress growth again, I think it is also the same thing happened for the carbon sequestration. I think that's all. Thank you.
Okay, thank you very much, Prof. Samuel. Well, I invite the other participant. Do you have any question for the amazing presenters here? Not yet.
it's depend on the season. If there is in the rain.
Number of soil bacteria from
was able to decrease.
I think for me, and the second one is the camera trap, because sometimes the elephant in white canvas is throw the camera trap, so the battery is off, and then etc. That is the challenge for me, I think. Thank you.
Thank you very much. There's any question? Other question? Okay, if there is no question, we have one session again, and please give a big happy applause to all the presenter and to the participant. And I will introduce the next session and next moderator. We lead by Mrs. Elisina Herdiana. Times and place is yours. Thank you very much. More and less, I want to say sorry. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, moderator.
Then this might not fit well to the previous ecosystem. We need not to do forest landscape restoration. We need not to do this. We can do plantation, can do close to nature with exotics, whatever we want. Of course, we are free, and the land owner is deciding what he wants, that's it. But if we stick to the forest landscape restoration and hope to attract funds through this scheme, then we should find ways that the forest ecosystem can function itself without human interference, and can develop back to what it was before. Yeah. Thank you very much.
Okay, thank you, Rob.
Thank you, Professor, for the answer.
Yep, I think. Thank you so much for the discussion. There should be a lot of question and this to be discussed here, but time is limiting us, because now we have to move forward to the next session, the third session. So from our session, we can grab a lot of new thing and new paradigm of how to restore our forest landscape. Prof already gave us a broadened view of both the history, the benefit, and also the strategy to restore the forest landscape, and also how and we have to bring it to close to the nature, just like that. And from the second presenter, we learned that the land management and the burn land is affecting much the semiconductor properties of the pit soil. And from the third and fourth speaker, we can learn the couple of the precipitation and the hotspots. I think this one is very, the scientific atmosphere in this session is very nice. I love it, but Prof, we have a time limitation. Then if you have a time, we still have another session, Prof, if you want to join. But if you have another agenda, so we already feel very happy to have you here. Finally, we can meet here in the conference. Okay, please.
Can I say one word?
Okay.
I may run away in between because of a different termin I have. Yeah. So thank you. In between, silently. So thank you very much.
Okay. Thank you very much, Prof, for sharing your experience and for sharing your knowledge for us here. And thank you for Chitra and also Farah and Rafati. Thank you so much for sharing your research result with us. Hopefully, we can grab a bright future in the future. Yeah. Okay, thank you so much. Please give a big applause for our speakers here. Okay, thank you so much. I close the session. Assalamualaikum warahmatullahi wabarakatuh.
Species, whether or not you have the light crown ratio more than 35, whether or not they have lived enough in the sense of within one species to quantify, measure in a combination of the height and the diameter. Then you'll come out a proper characterization, because we married the growth and yield equation of height, diameter to the ecophysiological expression that we strongly related to the leaf area, because this leaf area is basically lead us to carbohydrate assimilation. Grow all come from carbohydrate assimilation. That is the leaf area. So, and then of course it depends on the way how you do it in each species. That's why in the initial step of my presentation, I did mention about genetic and environmental. So because our presentation very short, so won't be able to expand the thing behind everything. But when you have this growth index, you will be very carefully describing a population that you have planted fairly, so that your plant later will basically prove you right or wrong. So the Soria roxburghii will have to continue to grow, because at this moment, in terms of the relative growth index, it occupies in terms of the growth index population. So when we refer to the growth index of populations, it is safe, because basically that we are talking about relativity, right? So this is the first time in this conference. Actually, I before that, now is going after this. You see the value that I'm using in the problem, things like that, because we are working on each tree in urban planting. They're different in terms of number. Like you look at the data that I sent in my paper, basically you have about 10 trees of Croctosilum formosum, but they have 1 tree each, 2 trees. You know, you in terms of statistically speaking, you want to compare growth. You have a lot of critics who are very good researchers. They'll come after you, right? But in that sense, you basically quantify and then you describe, and you get all the measurable parameter into a relationship. And from that relationship, we don't intend, listen carefully, I don't intend to make it a regression. Because that will involve enough sample, all of them out together with my colleague. So I think her name is Light Green, and so she's working, helping me, basically working on many components of this. So we quantify, and it's a very tedious work. We have to count, and then later day we can have sub equation for each species. We cannot do mixed species in terms of the leaf tapala. So let's say I measure the diameter and height of Croctopsilum formosum or Daira costulata in urban planting. We throughout Malaysia of, let's say, 10 sites of the 25 trees, all right, and we recite, then I'll be able to predict tapala. So I don't need to measure anymore, but I know the diameter or volume, right? But whatever it is, this is the first time in our scientific research family. I opened this out, presented it, so that you can continue to develop it. All right. So what happened is that I really appreciate particular ICTS you organize, and we have all the healthy mind here, so that we learn from one another. So thank you very much, Chairman Kayo. Thank you very much.
Thank you. Any other questions? Well,
Mr. Brian, Mr. Agustino, ini Miss Kintan, ya, Miss Reni, and Miss Tiara, ya, and Mr. Wahyudi. Ya. For each speaker, only 10 minutes, ya, to deliver presentation. Ya. And then the form is parallel, ya, panel system. Ya. The first, okay, maybe I called the speaker, yeah, absent, yeah, is there or is in this room? Mr. Brian?
Present.
Okay. Mr. Agustin Ho? Mr. Agustin Ho? Yeah, ada nama, is here. Miss Kintan?
Yes, present, sir.
Okay. Miss Reni? Yeah.
Yes, I'm here.
With the local government due to action, adaptation action in Pekalongan and Demak currently is revegetation for the mangrove to reduce the land subsidence. So the Pekalongan and the government encourage the community in the coastal area, in the mangrove area, to do the revegetation. That's in the MAC to almost majority to 2021 hectares mangrove has been planted by the community itself. We hope the learn from the MAC also captured by the Pekalongan government. That's it.
Okay, thank you for your response. And I think it is time for concluding the discussion, and then there will be a closing remark, yeah, related with the 6 presentation in this session. Yeah, the first is that concerning the revegetation activities in ex-mining areas, there are specific trees or specific group of trees that have been used for revegetation in specific post-mining areas, such as post-silica sand mining areas, etc. And up to now, there are improvements in terms of nutrient cycles, hydrology, and microbial habitat in the ex-mining area due to the revegetation activities. And then concerning the mangrove study, there should be some action need to be conducted to reduce the vulnerability of mangrove to damage. Yeah? And of course, the action should be done not only by government, but also by people, community. Yeah? And the next is related with the technology or techniques of using seed ball in revegetation activities. This technique of using seed ball in revegetation has increased the success of revegetation or the success of plant growth during revegetation, but there should be an effort to formulate the appropriate formulation in the seed ball material. Yeah? And then concerning the urban tree planting, there are several growth indexes which can be used to assess the performance of trees planted in urban environment. And for this purpose, for instance, there are several correlation of growth factors which could be employed. And hopefully all this information can be used for improving the performance of urban tree planting. The next topic is concerning the Albizia falcataria or Paraseriantes falcataria seedlings, which is still having possibility to be attacked by several diseases. One of them is a leaf blight disease, which was reported for certain cases, including the severity, etc. And hopefully with such information, the next measure that should be done or next action that should be done to reduce the attack can be planned more appropriately. And then concerning the application of mycorrhiza, or in this case mycosylvi, together with silvicultural treatment, could improve the growth of Albizia chinensis in a case of post mining of silica sand, yeah, in a particular area which is studied in this research. Yeah. I think that is all the closing statement that can be made in this session. Thank you for all your attention. And then the next session will be a photo session. Yeah, to all of us. Please, the operator, help us, and then we should go to the next session. Yeah. Please, everyone, turn on the video. We have a photo session. We have photo session, and please, the operator, do the photo documentation, and then we should proceed to the next session. Yeah. Okay. Finish. Finish, the moderator, the operator in documenting, recording the photo of each participant.
Yes, sir.
This group the stand structure. Mathematic equation that are simulate our growth model such a recruitment in growth and mortality. Model simulation. At this stage, this model is run and the behavior of each stock model is studied. Model evaluation compare the behavior or trend of the variable obtained from the simulation with other studies outside of this modeling. If the trend show in the same, then the model is valid. Model used in the stage of adding several choice of strategy or scenario so that the modeling objectives are achieved. In this study, the choice of scenario of the outcome setting scenario, timber forest products are harvested based on consumption level and are carried out every 5 years. Next. Result and discussion. So that total product continued to increase in the 2013 until 2019 period by 33 million meter cubic to 47 million meter cubic. The increase in production was due to the production of timber from plantation forest, which increased from 30 million meter cubic to 40 million meter cubic. Meanwhile, wood production for natural forest also increased from 4.8 million meter cubic in 2013 to 7.8 million meter cubic. The production of log in Indonesia showing an increasing trend. The product of log for the 2013 until 2018 period is around 50 million meter cubic. This value is reduced by 4 until 6 million meter cubic. Due to export, in additional, there was an important of wood product, thereby increasing the supply of domestic wood products. Next. Wood consumption rate. Wood consumption rate meanwhile based on the population approach the consumption of softwood product from natural forest reaches 0.0133 meter cubic per hectare per year. This means that to meet the need for wood production is 1 hectare of natural forest land is required to reach 0.0133 meter cubic per year. Next. Model simulation. This condition centrally explain that forest harvesting will stop is only one cycle, and the next cycle there will be not harvest. If this condition is maintained, the value of forest land will be very low and unfit to be managed by the holder of a timber utilization permit from natural forest. Next. Evaluation model. Evaluation of the model is carried out on the projection of the stand structure. The result of this study indicate that the number of trees will increase after filling and then decrease during the second cycle of filling. After that, the number of trees tend to stabilize. Meanwhile, the number of trees is each diameter class will from an inverse J curve. However, after 10 years, the tree in the diameter class 20 up will continue to decline so that the number of trees that can be cut the second cycle decrease. This condition is also described. Next. Model use, we can see table about cutting cycle, BAU, and consumption. The choice of the best scenario lies in the objective of forest management. If the goal of forest management is yield sustainability, then a management scenario taking into account the level of consumption and timing of harvesting in the best scenario. On the other hand, if the management objective is to maximize crop yield, then BAU conditions are the best choice. Next. The concept of natural systems should not be separated according to the type of forest area utilization permit because each permit holder can use wood and plant trees. Utilization of wood in the form of harvesting wood the ground naturally. In harvesting wood, you can consider two important pieces of information that should not be separated. The two pieces of information referred to are tree growth and use of wood product. Separated, it will affect the structure of the stand, the volume of wood harvest, and the natural of investment. The effect of information used in only information on the use of wood, so that stand structure will be rich than the growth information. Harvesting is just to the volume of use. Meanwhile, if is only growth, the harvest may be greater so that more volume is harvested. Other influence on investment, if growth information is used, it could be that there is an abundance of wood stock so that the demand to the stand is high. This will result if fast investment, the price of wood incorrect to decrease so that the income will be lower than the cost. Meanwhile, if information on use, the volume of wood in the market will be limited, the price of wood will increase, but the logging performed will be low. This will make enterprise to stay long in the forest or investment last a long time. Unfortunately, not interesting. For that, investment must follow the market. It is proposed that wood originating from natural forests that are formed naturally and cannot be controlled is used for domestic market consumption. Meanwhile, the development of plantation is aimed at production good quality wood according to the product specification expected in the global market. And next. The conclusion, number one, the application of the clear-cut silviculture system at diameter 40 cm up will result the stand structure of log over natural forest being dominated by small diameter tree is harvesting is still based on the diameter limit for large diameter. The use of the wood consumption index will have a positive impact on the stand structure over several filling cycles. The silviculture system must lock a low level of demand and increase the demand for wood through the management of landscapes that are productive and of high economic value. Thank you. Wassalamualaikum.
All right. Thank you, Ms. Mira. So it's very interesting. I found it very interesting because
Okay, first there is the identification of burn area. A pixel is declared as a fire area if it meets the requirement SPOL 8 or PGL 2015. If complete the requirements if condition 1 NBR pos is lower than alpha and condition 2 if delta NBR more than beta, you can calculate the alpha and beta with this formula. And then next please. Okay. For after that, I create estimation of fire severity using the threshold, and I separate this class in the three class. There is low, moderate, and high, and I use this threshold formula to create this class. Okay, next. Okay, for after that, I must measure the ability of NBR. Here I use the distance value, or we can call that D value, based on the formula developed by Kaufman and Riemer in 1994. And you can look here the formula of D value, and we can get the result about the reliability of index. If D value is more than 1, the index has good ability to measure fire severity. If the value of index is lower than 1, the index has a poor ability to measure fire severity. Okay, next. Okay, for accuracy test, I use individual classification success index, or ICTS, according to Cole-Class and Blackburn in 2001. And okay, next. Okay, next. Okay, you can look here in our result. My result is in figure 2. The distribution of hotspot in 2019 at Hagesnebel is only found in September. You look at in September is only hotspot has found in that 2019. And then if you look in the figure 3, if we look the hotspot distribution only in September, the hotspot start on 10th and the end to the 26th. And if we look at the relationship between hotspot and precipitation, shows a strong relationship. The higher the monthly precipitation, the lower of the number of monthly hotspots, and vice versa. If you look that in figure 3, if in depth of 15, there are precipitation in that, and the hotspot will decrease because the precipitation value is increased. And based on this analysis, we can get the result that the estimate of burn period in Hagesnebel is from 10 to 26 September in 2019. Next. Okay, for burn area assessment from visual interpretation method, I create the delineation and interpretation burn area based on the characteristic of burn area in RGB composite image. There is reddish brown, which is darker than surrounding color, and is in the form of a rectangular polygon. You look here in figure 4. There are 2 locations about burn area. Next. Okay, after we can identify about the burn area based on composite band, the area of fire using visual interpretation method is 366 hectare. And then this data used as a training data area in identifying burn area, and this is used as reference data in the index processing accuracy test. Next. Okay, this is the result of NBR in figure 6. Yang in picture A, there is NBR pre or before fire, and figure 6 in B picture is the NBR post or after fire. This show that found a decrease in the NBR index after fire. You look, there are 2 locations. In the value of NBR has decreased. This because the vegetation after burning in the area has low reflectance to the near band and high reflectance to shear band. Next. And we can get the burn area with delta NBR. And look the indicator of this method. The burn area is interpreted if it's closer to the value of 1 about the delta NBR. Based on the figure 7, it is expected that there are 2 areas where being born area in Hages. Next. Okay, if you look the statistic data average, it show the NBR pre 0.5 and NBR post is minus 0.03, and this is show the decrease value of NBR significant. Okay, next. Okay, this is my threshold for assessing burn area with digital method. And the total area of estimated burn area identified by the NBR index is 351 hectare. Next. Okay, for fire severity, I use this threshold based on my training data. And the severity class in Hages Sungai Buloh is dominated by high class with 59% or 200 hectare. Okay, next. Okay, for ability test, NBR has a very good ability to measure fire severity. You look that in the value is more than 1. So we can get the result that the NBR has a good ability. And we look the accuracy is 91%. And the height of the value and accuracy of the NBR index is because the NBR index uses a square band, which has a higher sensitivity than other band in multispectral image. Next. Okay, if we look the relationship of fire severity and groundwater level, the period, this is in figure 10, is show the GWL in Hages Sungai Buloh. The period of July to December show different GWL patterns compared the period of January to June. If you look in A, that dominated by pink color, you know, and the interpret of pink color is depth of GWL if minus 14 to 0 centimeter. If we look in a yellow color, and the interpret of the color is the GWL depth is minus 68 to minus 54 centimeter. This shows the decrease of GWL. That's because the distribution, if you look in figure 11, distribution of monthly precipitation and GWL in Hages Sungai Buloh in period July to December has a decreased value of precipitation. Okay, next. Okay, for if you look the relationship between precipitation and GWL, precipitation had a significant effect on GWL with the value of significant F is that 0.03, and there is a lower, the value is lower than 0.05. And this is show that this was significant effect precipitation and GWL. Okay, next. Okay, if you look the relationship hotspot and GWL, fires in Hages Sungai Buloh may start to occur due to the dry peatlands during the drought. If you look in September, it's only found the hotspot, and in that month is the lowest GWL in that around of 2019. That's show that indicates that the fire occur following a precipitation pattern. So it's important to keep the GWL less than 40 centimeter from the surface to reduce the risk of fire. Okay, next. Okay, next. This is my conclusion. In Hages Sungai Buloh is dominated by high class severity, and the NBR index has a good ability to estimate the severity. And the second conclusion is the high severity of fire that occur is caused by the dynamic of the groundwater level, which is strongly influenced by precipitation. Okay, next. Well, this is my references. Next. Okay, thank you very much for your attention to me. I have quotes from Theodore Levitt. Creativity is thinking up new things. Innovation is doing new things. I'm Amir Ramadi. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
The title of presentation is In Vitro Biological Control of Fungus Botryodiplodia species using biopesticide. Please, I give time for you. Your time is 10 minutes.
Thank you. Can host help me to screen sharing, or I have to screen sharing by myself? Okay. Hello, is my sound is clear?
Yes. Good.
Okay. Good evening, everyone. I hope you all healthy and happy whenever you are. Let me introduce myself. My name is Ananda Ristisian. You can call me Nanda for short. I'm from Department of Silviculture, Faculty of Forestry, ITB University. In this evening, I would like to present. The title is in vitro biological control of fungus Botryodiplodia species using biopesticide. Next. This is the outline for today's presentation. It consists methodology, discussion, and conclusion. Next. Okay, the first introduction. Next. Okay, integrated pest and disease management is action practice. Chemical compound commonly used in integrated pest and disease management are pesticides. Sudarmo 1992 stated in Latin America, the use of pesticides can increase production up to 50% on chocolate crops, and based on efforts, the use of pesticide can save 50% yield on cotton plants. However, in addition to the things, the use of synthetic chemical-based pesticide is a problem for the environment and human health. The use of synthetic pesticide can create resistance to pests and disease, and contaminate the environment. According to Smartini 2016, the application of chemical pesticide also affects human health. Residual pesticide in harvest product will affect the health of consumers. Therefore, an alternative environmental and health-friendly pesticide is needed to overcome the problem. Next. Nufus 2020 explained the use of pesticide from plant extract proven to be safer because it has a short residual life. In nature, biopesticides have unstable and easy to degrade characteristics. Research on the effectiveness of the use of biopesticide has been done against particular pests or pathogens. And the research proves that the effectiveness of the biopesticide varies depending on the type and the concentration. Jabon or Neolamarkia cadamba is fast-growing species and commonly used as shading tree, construction wood, pulp and paper, and also for ecosystem restoration. However, the problem that happened in the cultivation of Jabon is the attack of pests and disease. One of them by pathogen Botryodiplodia species, which cause leaf blight, leaf spot, and shoot death. This pathogen has a wide range of hosts from forestry plants and agriculture crops. Plants that are affected with disease potentially have decreased productivity and loss of yields. If not controlled on the beginning of the growth, then will cause a decrease of wood economic loss. Therefore, this research focused on biopesticide as an alternative in vitro control of Botryodiplodia species. Next. Okay, the next is methodology. This research occurred on May until July 2021 and located in Forest Pathology Laboratory. Next. The research is in vitro laboratory experiment with food poisoning method. The data used as in the research is primary data from the observation of mycelium colony diameter growth in potato dextrose agar or PDA and mycelium biomass in potato dextrose broth or PDB. The research procedure consists of rejuvenation of isolates, pesticide solution dilution, isolate inoculation, diameter and biomass observation, and calculation of inhibition per stage. The concentration tested in this research are 0% as control, 0.25%, 0.5%, 1%, 4%, 7%, and 10%. Each concentration added to the media culture and do homogenization. The growth of isolate diameter was measured using a ruler every 12 until the control fully filled the Petri dish. Observation of diameter growth was carried out by measuring the x-axis and y-axis on the Petri dish. The length of the two axes are average. Isolate of Botryodiplodia species incubated for 7 days in PDB incubation period. PDB was shaken in a stirrer at 100 RPM. After the incubation period, the mycelium was filtered using filter paper, which had been previously oven baked for 24 hours at 60 degrees Celsius. Weighing dry weight using an analytical balance. Next. The calculation of percentage of inhibition was carried out by comparing the treatment and control. The percent inhibition value of mycelium colony diameter and mycelium biomass was calculated using the formula as shown on a slide. The data was analyzed using analysis of variance. The experimental design used in this research was rancangan acak lengkap or RAL with 3 replication. The design model based on Matrix 2000 is shown on the slide. Next. And the next is discussion. For the first discussion is about morphology of Botryodiplodia species. Fungal morphology in general can be seen based on its macroscopic and microscopic morphology. The macroscopic characteristics that can be seen in this study are the color and the shape of the colony. Isolate of Botryodiplodia species, which were rejuvenated on PDA media and incubated for 1 month, had a color change. Fungal isolate 1 week after inoculation showed grayish-white color colonies, as shown as figure 1A, while fungal isolate 1 month after inoculation showed blackish colonies, as shown as figure 1B. This is following by Asnani 2014. Macroscopic appearance also has aerial colony character as shown as figure 1C and pycnidia as shown as figure 1D. Next. Microscopic appearance that can be seen under the microscope are hyphae and conidia as shown as figure 2. But hyphae have brownish hyaline characteristic, were septate and branched, while the conidia were ovoid shape, brown in color, and Faiza 2018 stated that young Botryodiplodia conidia didn't have septate, but the old conidia have septate. Next. The next discussion is about biopesticide content. The biopesticide used on this research was named Plantes, that classified as insecticide, bactericide, and fungicide. Plantes are made from natural ingredients, so it is safe for human health and the environment. The composition of the Plantes solution was synthesized from plant ingredients containing active compound such as Azadirachta indica, Syzygium aromaticum, Cymbopogon nardus, and liquid smoke from charcoal coconut shell. The compounds on each ingredient, based on the references, is shown on the table. Next. The next discussion is about the inhibition test on PDA. Figure 4 show average colony mycelium diameter growth rate on PDA. Botryodiplodia isolate with 0% concentration fully filled the Petri dish at 72 hours or 3 days after inoculation. This condition of the radial growth was relatively fast. average growth rate of isolate with treatment and control has the same graph. The 0.5% concentration graph show the difference at 24, 36, and 48 hours after inoculation. That is showed the reduction of colony diameter growth. However, the growth come back on the 60 hours. This condition describes that biopesticides are more fungicidal than fungicidal characteristic. Rahmawati 2019 states Botryodiplodia tuberosity has the ability to continue growth back after the effect of the inhibition gone. Next. Figure 5 shows the inhibition percentage of biopesticide towards colony mesylum diameter Botryodiplodia species. All the concentration tested generally have the ability to inhibit colony diameter. This shows that there is an inhibition due to active compound in biopesticide. On the other hand, inhibition test done on PDA after the analysis. Next. The inhibition also cannot be seen visually at 72 hours after inoculation. Next.
Decrease of aluminium at the 0 to 10 centimeter depth and increase amount of aluminium in 10 to 30 centimeter depth. However, the changes of aluminium at the control plot is higher compared to the phase side. And acidic pH has effect on the availability of acidable aluminium in soil. In conclusion, during gas release, carbon dioxide interact with soil matrix and water, causing changes to soil properties. Moisture content, pH, organic carbon, and assimilable potassium in soil will enhance at 0 to 10 centimeter depth under elevated carbon dioxide condition after a period of 2 years. However, opposite trend was observed in the control plot under the tropical forest ecosystem, while similar pattern was detected for nitrogen, P, and aluminium in soil from both the control and the carbon dioxide fertilized plots. There was an increase in nitrogen content and decrease in P and also decrease in aluminium at the upper soil layer, despite the study area was or not treated with carbon dioxide emission. However, the effects were more for potassium and P inside with high carbon dioxide concentration compared to the control plot. With this, I end my talk. Thank you for your attention.
Thank you very much, Mrs. Rosita, for the presentation about the soil enrichment just now. So we'll proceed with our discussion. Yeah. So I hope that 3 presenters are ready with to answer questions. If there's any questions from the floor, please just turn on your mic and then ask questions to the presenters. If you wish to just type your questions on the chat box, you could do so too. So we'll just wait for if there's any questions from the floor, okay? Okay, maybe I will start first, yeah? So I will start my questions to the first presenter. So maybe if there's other questions from the other participants, you could just continue after this, okay? Just to start the discussion, okay? So for the first presenter, Ms. Andita Mingamora, so I have several questions for you. So I was aware from your presentation that you use Mrs. Andita, are you with us?
Yeah.
Okay. I just wonder about your presentation, yeah, about your research. You did mention about the traditional methods you use to locate the potential across the landscape, right? You did mention about the field work and also other spatial data that needed even for the conventional method. But for the field work, what type of data was taken for the conventional method.
What the data that we get to the next step?
No, for the conventional method, I mean the traditional method, because yours is using the GIS and sensing, right? So for the conventional method, the traditional method, so what's the difference, and then could you explain more on that?
Okay, thank you, Dr. Siti, for the question. The traditional method that researchers in the fuel fire management use in the field, they get some fuel in the field with the manual use, like
Boleh cakap Melayu juga, tak ada masalah.
mengukur like scaling the diameter with the meteran, with the pengukur, and then collecting the data from the field to the laboratory.
The last study, we recall we need the retaining or maintain the stand, because for the many of woolen stand, it can grow well in there. But for the density in total area is not presented in this study. Maybe that's all, thank you.
All right, okay. Thank you for your explanation to all the questions. So again, like I said, there is not much question to the other presenter. Because of that, I will, if possible, for all the presenter, can I ask question to each presenter for each of the presentation. So my question to presenter number 1. In his slide, in his video of his slide, there is this explanation about clear zone measurement. So I think this is involved measurement of diameter in the with the fungi and all that. So can you explain in specific what is the process involving this clear zone measurement? I think this question is for Mr. Jumadil.
Yes, thank you. And on the testing using, I use tannin acid and CMC media because it was seen that there was enzyme activity. To look enzyme activity with two media, especially the activity of the clear zona around the colony. I use two media, tannin acid and CMC.
All right. Okay. Thank you for explanation. And then there is for presenter. Okay, presenter number 2, Miss Farida. You already received so many questions, so I will skip you. So I go to presenter number 3, which is the Lufti. Regarding growth of natural forests that meeting the demand for food and construction and household. In your presentation, I mean your colleague present. There is a term that you call recruit trees. Can you explain? Be clear with what do you mean with the recruit trees? Because some of us, especially me, because I'm not in silviculture field of research, so it's a bit interesting for me to hear further explanation about this recruit trees. Can you explain?
Okay, thank you very much for your good question. I think we know about the stand structure, and then in Indonesia we can say trees if the trees diameter above on 10 diameters, 10 centimeters. So the one trees or the one hole can be grown to the trees class if the next years it grow after come in after 10 diameter centimeter, 10 centimeter diameter. So it is recruitment. So when we say in growth, it is because when we study about the stem structure in natural forest, we divide in some class diameter class. So the growth from the low diameter class to a high diameter class, we say that is in growth. It is different with recruitment and the in growth. Recruitment is the growth of before trees to trees class, and then growth in the class of trees. Maybe that's all for me. Thank you.
Thank you for your explanations. Okay, to be fair, I have another question for our number 4 presentation. Because Miss Farida, this is sorry, I'm interested, even though you received so many questions, but I want to ask about this. In your presentation, you said Ulin species is a slow-growing species, and it also considered as conservation species. Is there any specific reason why you focus on this Ulin tree species?
Because in Arboretum Sempaja, Ulin was selected for conservation ex situ species in 2003. So we monitoring the growth until now. So for the some places or some forests in Kalimantan especially is not more longer quite abundant for these parent trees, maybe for Ulin. So and some reason for research for the development the medicine plant, Ulin has is important species too. Thank you.
Okay. All right. Thank you for the explanation. Yes, it makes sense to see it as a conservation species. Okay. So the last question. This is for our last presenter. Considering your topic is about relating to ecotourism, do you have any example? Do you have any example that when you do your 3D construction, the consideration on the material that you use, can you provide one example of the material that eco-friendly that embrace the concept of ecotourism? Okay, there is a lot of you, so you can answer. Any of you can answer.
Okay, allow me to answer. Maybe about what material is it? Is it the material of 3D design?
Yes, the material that you choose when you do this 3D design, you show that there is this material for jetty, for the flower that you use, the stone. Is there anything that represent the eco-friendly product in this material that you have chosen? Because it's ecotourism, so it should be ecologically beneficial.
Okay, maybe the from the ecotourism side that we can show in this project is this Situ Mekir Sereng is use the potential source water that located in the seashore. So from the seashore, maybe people of Pasongsongan village did not have knowledge about how to make it become potential that can increase their economic activity, so that the situ, the water source, it has potential to develop into some recreational area that that we can take the water source to develop into recreational area. Just like
all right. Okay. Thank you for your effort in explaining the my question. Okay, because everyone has already presented their research and all that. So I want to close our session by summarizing our presentation today, the research that has presented. So if you can see this short summary. So for this room 3, parallel session number 3, under the topic of ecosystem service and uneven age silviculture, the from the
You after the event maybe.
Okay. In this research, I don't measure the severity in the field. I just measure that
by the grassland, and then the smallest is at the building yard. So the infiltration rate at the green open space area was the highest compared to the other two land uses. So this is because the tree's root system enlarge the pores of the soil so that it is easier to pass the water, and also the soil structure develops better at that area. So a suitable form of land use to increase infiltration is grassland with a few trees, and grass planting is also needed to reduce surface erosion. So finally, thank you very much for your kind attention. Thank you.
Thank you very much, Bu Ambar, for your presentation. Nice presentation. And the next presentation, I invite Ika Heriansah from Forest Research Development and Innovation Agency. To Ibu Ika, time is Pak. Oh ya, sorry, Pak Ika, time is yours. Hello, is Pak Ika already here in this room?
Growth of plant root to
because the Pantung plantation were
short and dark in color. Iron toxicity is able to induce cellular oxidative damage that causes change in morphophysiological properties which will reduce plant productivity. Next. Dry wake. Iron treatment had a significant effect to the dry wake of the tree seedling. The increase of iron concentration was able to reduce the dry wake of the tree seedling. However, at a concentration 1 millimolar iron, the dry wake of Senecio seedling was able to increase even higher than the
strongly influenced by Silviculture as a medium for plant growth. Okay, next. Next, please. Okay. Inundation of the soil by water cause disruption of soil aeration. Yeah, so that plant metabolism processes can be disrupted too. Yeah. To reduce the risk of inundation of the growth of Pantung plant, plant preparation for planting is carried out using the mound techniques, yeah, which is to create a mound of soil that is higher than surrounding area, yeah, as a location for planting. Okay, next. Okay, this is, you can see, this is a graphic of a growth model, yeah, for DB8 of Pantung using exponential equation. Yeah, you can see in the picture Y equal 3.5x exponential, yeah, rank 0.1x96 time x. This is coefficient of determination is enough height, yeah. 0.x9. Okay, next. Next, please. And this is a growth model for DBH Pantong using polynomial equation, yeah, using polynomial equation, and then we will compare to this is the coefficient of determination height 2, yeah, 0.x3, yeah, 7.5. Okay, next. And this is for
1 minute more, ya, Mr. Wahyudi.
Gimana?
1 minute more.
And this is growth model for height, yeah, of Pantong using exponential equation. And then next, this is height using polynomial equation. Next. Okay, we compare, yeah, polynomial and exponential equation. Next using chi-square. Now this is, you can see that the validation of model exponential compared with polynomial. You can see this is value of chi-square for polynomial equation is smaller than a value of x table. So polynomial equation accepted XO, yeah. So polynomial equation is better, yeah, better than exponential equation. Okay, next. Nah, look, conclusion. Conclusion, Pantong plant planted on mounds with swampland are better than conventional with swampland, yeah. Pantong plant planted on the mound with swampland do not experience waterlogging, tidak pernah tergenang, so that the soil aeration run well and the nutrient absorption process run better. Soil nutrients are not washed away by water flow. And number 2, growth model of polynomial is better than growth model of exponential, yeah, added to DB8 and also its Higgs. This model called to estimate DB8 and its Higgs of Pantong plant at the time. Okay, thanks.
Okay, thank you, Mr. Wadwi, for your presentation. And then Miss, where is siapa lagi, satu lagi, lah mana daftarnya? Momennya just lagi su. Okay, Miss Rani is there here?
Yes. Work was carried out in an ex-mining land together with our project leader, Dr. Ahmad Zaidi Yahya. Please allow me to go through the slides today with you. So just to give you some background, in the early 1970s, the land area for mining land was almost 300,000 and it dropped drastically, almost 88% to 1993. And furthermore, 91% in 2017. So this is a good indicator whereby it shows that Malaysia is not thoroughly depending on the mining activities, and it has been reducing. So basically, what I would like to share here is that some of the main things that has been regulated in the mineral development rules is that any mining which takes place has to be rehabilitated. And this is where FRIM comes into picture, whereby we are working hand in hand with mining land or mining companies in order to establish new forests with new species, which will enrich the ecosystem that has been previously degraded. So the area of interest is actually in Ulu Perak. It is to the north of Kuala Lumpur, much more closer to the Thailand border. So this was the area initially, whereby it was quite barren, mixed up with heterogeneous soil. What we I wanted to show here as well as that during the 1900s and 1920s, the normal mining method was actually dulang washing method, which is shown here. And now we have gone into open pit mining methods. So our project actually wanted to see how could Shorea roxburghi could be a potential species in greening activities and in mining land. So firstly, before we even planted the area, we spread out the area with hydrated lime. This was about 6 tons of hydrated lime applied in 2 split application. And then what we did was that we did some reclamation with mineral soil, whereby we put in mineral soils from the nearby hilly areas about close to about 75 to 100 cm depth. And you may be wondering, why did we choose Shorea roxburghi? If you see in the IUCN red list species, this species is actually categorized as vulnerable. So at the same time, it is fast growing. It has many uses for timber uses as well as constructions. So in December 2018, we started planting these seedlings. This is the picture showing you, whereby firstly we put in about 100 grams of CIRP, Christmas Island rock phosphate, during planting time. And then despite the treatments that we did, we still found that the basic soil properties that here was highly acidic, almost 2.4 to 3.3. And then you can see that the values for nitrogen, available phosphorus, potassium, calcium, and magnesium were all in very low levels. Even the CEC was less than 10 centimeter per mole per kilogram. So we carried out silvicultural management here at 4 months after planting. You can see some of the slashed Micania weeds here. Whenever we do any planting, we have to make sure that we tend to the stand so that we actually provide enough area as well as nutrition for the trees to grow. So we continued with our manuring activities at 4 months and 12 months after planting. For the first year, what we did was that we applied about 100 grams of NPK 15-15-15 fertilizer per plant. Of course, this was gradually increased after the year 2 and year 3 up to about year 4. Then coming back to our objective was that to actually determine the survival rate and the growth of the trees. So this is the formula that we use to actually determine the annual height increment of these seedlings. So the data that we collected was from April 2019 to July 2021. So we have data for the seedling age 26 months old. So if you can see the table 1 here, these are the results that we got. The survival rates of Shorea roxburghi was quite good. It was close to about 97 to 100%. And the mean height at July 21, about 26 months after planting, was about 2.69 meters. And when we saw these results, we compared this with literature review. We found that some of the work supports our data as well, whereby there was a paper from Ang et al. 2018, whereby they did some planting in extinct mining land as well. This was for seedlings age 5-year-old. It showed that the mean height was about 4.8 meters and the mean annual increment is about 0.95. So we are not too far off from which was reported. And when we compared with another study in Thailand, mean height was slightly much more higher. It was about 2.69 meters compared to what was recorded by Wong Prom, which was about 2.55 meters. And this was not for
Ilmu silviculture memainkan peranan yang sangat penting dalam pengelolaan hutan berkelanjutan dengan memastikan keberlanjutan fungsi ekosistem hutan dan meningkatkan dampak positif sosial ekonomi dalam mempertahankan dan meningkatkan produktivitas hutan sehingga mencapai pembangunan berkelanjutan. Dilatar belakangi oleh hal tersebut, Departemen Silviculture Fakultas Kehutanan IPB University pada 10 dan 11 September 2019 melaksanakan kegiatan The Second International Conference on Tropical Silviculture dengan tema Forest Research and Innovation for Sustainable Development. Kegiatan yang berlangsung di IPB International Convention Center ini diikuti lebih dari 200 peserta yang terdiri dari para akademisi, peneliti, praktisi, dan pembuat kebijakan yang berasal dari berbagai negara seperti Indonesia, Amerika, Jerman, Jepang, Malaysia, Korea Selatan, dan Australia. Kegiatan ini diawali dengan sambutan oleh Wakil Rektor Bidang Kerjasama dan Sistem Informasi IPB University, Profesor Dodik Ridho Nur Rohman. Dalam sambutannya beliau menjelaskan jika hutan tropis memiliki peranan penting dalam aspek konservasi keanekaragaman hayati dan aspek produk, baik produk kayu maupun produk non-kayu. Namun disayangkan hutan Indonesia menghadapi laju deforestasi dan degradasi lahan yang tinggi. Kondisi ini meningkatkan kebutuhan pengelolaan hutan yang lebih baik. Selain itu, beliau juga mengharapkan dengan adanya kegiatan konferensi internasional ini dapat memperluas pengetahuan dalam berbagai topik silviculture tropis.
Jadi tahun ini kita mengadakan 15 international conference, ya, salah satunya adalah international conference ya on silviculture. Ini yang kedua. Tentu saja kami berharap dengan banyaknya international conference yang diadakan oleh IPB, termasuk international conference pada hari ini, kita bisa menambah networking lebih banyak lagi dengan berbagai universitas dan peneliti dari luar negeri yang sudah punya nama yang dikenal di dunia internasional seperti Profesor Gode Goldamer misalnya. Profesor Goldamer sangat terkenal untuk fresh fire dan juga profesor yang lain, Koran dan sebagainya, yang diharapkan nantinya kita bisa membuat riset bersama, juga kolaborasi dalam publikasi dan sebagainya.
Kegiatan konferensi internasional ini dilanjutkan dengan plenary session yang menghadirkan 4 keynote speaker. Pembicara pertama adalah Profesor Johann Georg Goldamer, Director Global Fire Monitoring Center atau GFMC, Max Planck Institute for Chemistry and Freiburg University, Jerman. Beliau menjelaskan presentasi dengan judul Revisit if the Freiburg Declaration on Tropical Fire of 1989. The Initiation of an International Agenda in Global Landscape Fire Science and Fire Management. Dalam presentasinya beliau menjelaskan bahwa diskusi ilmiah tentang perubahan iklim, penggundulan dan degradasi hutan sudah lama dilakukan, yaitu sejak 1980 hingga kini. Ditambahkannya degradasi hutan terjadi karena kebakaran hutan dengan berbagai sebab. Indonesia sebaiknya melakukan pencegahan, penekanan, dan rehabilitasi untuk mengurangi ancaman kebakaran hutan dan lahan.
Yes, today in my presentation to the conference, I spoke about the last 30 years of fire problems and the last 30 years of fire research in Indonesia and other continents. And over these 3 decades, we have made some progress in reducing the negative use of fire, but we are not yet there, you know, we are not yet arrived at a point where we can stop completely the unnecessary or excessive burning. It is clear to us, of course, that fire is also needed in some land use systems, but we all need to work collectively together to reduce those fires that are destroying the very vulnerable and important ecosystems. So from this conference, I think we go ahead and are inspired to do more collaborative research work. And what is most important, to bring this message to our political decision makers, and so that they can make their best decisions based on the scientific evidence.
Dilanjutkan pembicara kedua adalah Profesor Horomi Mizunaga dari Fakultas Pertanian Shizuoka University. Beliau menjelaskan presentasi dengan judul Complexity of Leaf Arrangement and Ecosystem Services in Uneven Age Silviculture. Beliau memaparkan terkait struktur kanopi memainkan peranan penting silvikultur dan fungsi ekologis. Dilanjutkan pembicara ketiga adalah Profesor Mark Cochrane dari University of Maryland Center for Environmental Science. Beliau menjelaskan presentasi dengan judul Fire and Carbon Emission in Indonesia Peatlands. Dalam presentasinya beliau menjelaskan jika kebakaran hutan menyebar dengan cara yang sangat bervariasi, baik secara horizontal maupun vertikal. Sedangkan kehilangan volume gambut per unit meningkat secara substansial seiring dengan musim kemarau yang berkelanjutan. Dilanjutkan pembicara keempat, yaitu Dr. Agus Justianto dari Badan Litbang dan Inovasi Kementerian Lingkungan Hidup dan Kehutanan. Beliau menjelaskan presentasi dengan judul Government Policy on Forest Research and Innovation. Dalam presentasinya, beliau menjelaskan peran signifikan hutan tropis Indonesia sebagai aset nasional dan global. Selain itu, aplikasi untuk mendukung SDGs oleh Badan Litbang dan Inovasi KLHK di Indonesia telah banyak diterapkan melalui bidang sosial, konservasi, ekowisata, dan restorasi. Kegiatan konferensi internasional ini dilanjutkan dengan sesi paralel yang dibagi ke dalam 7 tema besar, yaitu biodiversity, forest fire and climate change, agroforestry and forest plantation, ecosystem services, non-timber forest product, uneven age silviculture, dan forest degradation and rehabilitation, di mana setiap kelas sesi paralel terdapat pembicara utama. Selain itu, pada konferensi ini juga dilaksanakan presentasi poster terkait 7 tema besar tersebut. Diharapkan melalui kegiatan konferensi ini dapat memberikan banyak peluang untuk berbagi ide-ide baru dan riset bersama untuk kemajuan pengelolaan hutan tropis di Indonesia dan global. Pipit Sativa dan kru yang bertugas melaporkan untuk Green Highlight.
Indonesia terletak di lintasan garis khatulistiwa yang membentang dari Sumatera, Kalimantan, hingga Papua. Keindahan alam Indonesia yang terdiri dari pesisir pantai, gugusan pulau-pulau, barisan pegunungan, dan hijaunya hutan belantara menjadikan Indonesia disebut sebagai Jamrut Khatulistiwa. Keanekaragaman hutan Indonesia merupakan rumah bagi berbagai kehidupan yang ada di dalamnya.
Hutan perkasa yang dulu menyelimuti pulau-pulau ini sebagian besar telah hilang. Tinggallah bentangan hutan utuh di Papua sebagai pemilik hutan terakhir di negeri ini. Saat ini, hutan digunduli sejumlah besar gas rumah kaca yang dilepas ke udara, dan dengan demikian mendorong kita lebih cepat ke titik di mana kita tidak bisa kembali ke dampak perubahan iklim.
Selamat datang di Departemen Silviculture, Fakultas Kehutanan dan Lingkungan IPB University. Departemen Silviculture IPB berdiri pada tahun 2005 yang sebelumnya berada di Divisi Budidaya Hutan, Departemen Manajemen Hutan, Fakultas Kehutanan IPB. Pada tahun 2013, Departemen Silviculture meraih akreditasi A dari Badan Akreditasi Nasional Perguruan Tinggi serta memperoleh sertifikat ASEAN Quality Network Assurance pada tahun 2015. Pada tahun 2016, Departemen Silviculture IPB dan departemen lainnya di Fakultas Kehutanan IPB bersama-sama menerima sertifikat SNI ISO. Departemen Silviculture IPB memiliki fungsi menjadikan Departemen Silviculture sebagai program studi terkemuka dengan kompetensi utama silviculture tropika berkarakter kewirausahaan dan bersendikan keharmonisan. Departemen Silviculture IPB memiliki misi yaitu menyelenggarakan pendidikan tinggi yang berkualitas berbasis penelitian untuk menghasilkan sumber daya manusia yang berkualitas dan untuk menjamin fungsi ekologis, kesehatan, dan produktivitas ekosistem hutan secara berkelanjutan sehingga menjadikan Departemen Silviculture yang berperan sebagai trendsetter bagi masyarakat profesi kehutanan. Departemen Silviculture IPB menjadi lembaga pendidikan tinggi yang mampu mengantisipasi dan menjawab berbagai permasalahan pembangunan kehutanan secara ilmiah dan profesional dengan sistem manajemen berorientasi pada mutu dan profesionalisme. Departemen Silviculture IPB memiliki mandat dan pengembangan ilmu dan teknologi silviculture yang diperlukan untuk membina hutan alam serta membangun dan membina hutan tanaman secara berkelanjutan berbasis ekosistem. Kompetensi di Departemen Silviculture IPB mampu menyerapkan ilmu dan teknologi silviculture untuk menjamin fungsi ekologis, kesehatan, dan produktivitas hutan sesuai kebutuhan dan nilai-nilai hutan yang diinginkan secara berkelanjutan. Departemen Silviculture IPB memiliki bidang kajian yang luas, menarik, dan aplikatif, sehingga dalam pelaksanaannya, Departemen Silviculture IPB dibagi dalam 3 kajian divisi, diantaranya Divisi Ekologi, Divisi Silviculture, dan Divisi Perlindungan Hutan. Bidang kajian ekologi hutan meliputi hutan mangrove, hutan rawa gambut, hutan dataran rendah, hutan pegunungan, ekosistem das, tanah hutan, nutrisi hutan, restorasi hutan, reklamasi lahan pasca tambang, biodiversitas, botani hutan, dan lainnya.
Good afternoon from Indonesia, ladies and gentlemen. Welcome back to the third international seminar on Conference Tropical Silviculture 2021. Before we come to the closing of this event, Dr. Supriyanto Pamungkas, as a chairman of organizing committee, will deliver the summary of ICTS 2021. Please welcome Dr. Priyanto Pamungkas. The time is yours.
Okay, thank you, Bu Ati. I thank to the participants who are still following the conference. Now my turn to read the conclusion of the conference as follows. Belum muncul. Mana? Excuse me. We have a little bit of problem with the connections. Recommendation of ICTS 2021. First, non-timber forest products have long been an essential component in the livelihood strategies of forest-dwelling communities. Indonesian essential oils has contributed significantly to country revenue with the growth in volume. However, there are many lesser use potential NTFP producing essential oil. Silvichemical aspect of NTFP producing essential oils need to be studied in wider perspective to increase the quality of essential oil and get international market as well as increase country revenue. In this conference, newly popularized medicinal species of Liana tubajaca species and a well-known Liana medicinal plant, akar kuning, have been successfully propagated using stem cutting. Other important findings are the success of cultivation of species of fern and pakuate, Lycodium cicrinatum. Here we learn that every part of a drumstick tree can be used as a source of food, medicine, and feed. Other species of fern and rattan have explored for their use culturally as vegetable, as well as Strychnos ligustrina blume for traditional medicine. Producing process of the kayu put oil may improve by refining time and kettle pressure during distillation process on kayu put oil production from Melaleuca leucadendron leaf. Finally, the potential use of wood, waste, bamboo, and agriculture waste containing lignocellulose, including coffee husk and oil palm empty fruit bunches, for cultivating oyster mushroom have been explored. This conclusion from of the non-timber forest product. And then second, the prolonged studies revealed a close relationship between precipitation, groundwater level, and peat fires. A better risk assessment of future peat fire occurrence can be done through the analysis of drought pattern in the previous success dry and rainy season. The peatlands should be kept wet to restore them hydrologically and to prevent further peatland degradation. The use of remote sensing technology makes it easier to estimate the burn area and the severity of the fire, such as by using NBR index, and analyze future active fire by using OLRMC index. The relationship between the result of satellite and field data analysis can be used as biophysical model. For peatland restoration active to be deemed effective, canal blocking effort must be shown to have led to shorten fire season, less area burn, and most importantly, less peat soil consumed across the affected landscape. Land conversion and suboptimal management of peatland can affect the properties itself. A fuel mapping method is proposed that use current remote sensing and image processing technology. Reducing the probability of fire occurring require an understanding of socio-economic factors such as human activities which ignite of fires. This should be coupled with an understanding of the supporting biophysical and social factor. Lack of knowledge and experience to fight peat fire will spread more fire and potentially out of control fire breakout that will produce significant amount of GHG emission as dry peat burn is difficult to control. And number 3, forests have a very important role to provide of ecosystem services. Some examples of forest services include carbon stock, water cycle provider, sources of biodiversity including microorganisms, ecotourism, maintaining the microclimate in urban areas, and others. In the last decades, the forest has become a destination to improve both physical and mental health, which is known as forest healing. In order to maintain forest ecosystem services, it is necessary for all parties to do so. The role of community in protecting the forest as done by the Balinese people with the cultural ways such as subak, uninherited communal water management in agricultural system for centuries in Bali Island, Indonesia. Of course, the government's role in issuing policies in sustainable management of forestry is play an important role. And the next, number 4, agroforestry become more visible recently, including in the food estate program. Agroforestry practices in a win-win solution between development and environment due to the diverse benefit that can be gained from the unit area. Better soil water management and carbon sequestration and retention, and communities' income increase. Agroforestry can contribute to green growth at landscape jurisdictional level if embedded in sustainable land use planning, forest management, sustainable community, and restoration program. In this conference, we learned the effective use of biofertilizer and biopesticide to slow growing species forestry plants, how to apply the analytical hierarchy processes in selecting the appropriate plant for the community's agroforestry land, and how to use DEMNAS imagery analysis as an approach for precision land planning. Here we learn the lesson learned from New Zealand emission trading scheme and subsidized a $1 billion tree planting program to address climate change and the optimization of tropical monsoon forest ecosystem. Optimum of forest monsoon forest ecosystem utilization to initiate the development of alternative sources of income on a small scale. The strengthening and institutional arrangement of farmer groups and increase farmers' knowledge and skills. And number 5, the prosperity of tropical biodiversity attract many scientists all over the world of both basic and applied research, including bioprospecting. Indonesia is making progress in implementing the Nagoya Protocol, but there have been many advices to minimize international transfer of biological material. Lesson learned from the research initiative could be summarized as follows. Number 1, preparing the capacity of human. Number 2, creating a pilot project and connecting to other similar projects. Number 3, publishing the first peer-reviewed scientific paper, which could trigger more research on the aspect. Number 4, disseminating the protocol and expanding the network dissemination of the technology relevant to scientists. 5, continuously improve the capacity and program. At least there are 2 key takeaways to be implemented in the near future. Namely, first, stepping up the research roadmap, including promoting the use of technologies for generating more data and application for biodiversity conservation research, and other utilization like ecosystem restoration technology. The second, introducing the technology to wider potential user for more technology democratization, particularly for scientists or high school biology teachers in remote area or disadvantaged regions of Indonesia. And the last, number 6, in forest management practices, uneven age silviculture includes silvicultural practices of controlling the establishment, composition, structure, growth, or quality to provide diverse needs and values. Transforming to multi-age stand from even age plantation is thought to be an effective option to rehabilitate ecological function of stand. The information of the relationship among practice of silviculture, canopy structure, and microclimate is expected to be useful for success of transforming processes. This is important as a basic option for the assessment of long-term monitoring, basic and applied research are tasks of forestry research. This provides scientifically validated answer to actual question problem in forest development. Thank you very much.
Okay, thank you, Dr. Priyanto, for the summary. Ladies and gentlemen, we come to the announcement of the winner for the best student presenter and the best student poster. So we invite the Secretary of Department Silviculture, Dr. Erianto Indraputra. The time is yours.
Okay. Thank you so much, Bu Ati. So, I think this moment is the final moment that expecting by every student presenter in this conference. So the winners of I will say that actually we are so proud of you all. Yeah, all of the students has presented their best, but from these presenters, there should be a winners. So we are coming to the winners of the most outrageous and most skillful oral presentation, outstanding student oral presenter. Number search, it's quite difficult for the judge to find the winners because the total value is slightly different from each other. So the third winner is Kintan M. Nurjaman with the total value of 66. for Kintan M. Yaman. Yes, the certificate. Congratulations. We are so proud of you, Kintan. The second winner comes to Verda Satyawan. Yeah, with the total value of 67. The difference is just one. Yeah, amazing. Yeah, and the first winner, you may guess who will become the first winner? It is from, if the number third and number 2 is ladies, the first one is Ikhwan Sodik Chifon. With the total value of 68. Yeah, the difference is just 1 and 1. So it's quite close. So, best poster presenter. Okay. She or he? She, because the poster presenter is all of the girls. Okay. The best poster presenter is coming to Familia Juniarti. Okay. Good luck for all of the winners. Yeah, for Kintan, Verda, Ikhwan, and Familia. Sorry. So the committee will contact you for the prize. Yeah, but for the students, we still have another 3 competition. Yeah, we have the videography competition, photography competition, and scientific drawing. So we invite all of the students to complete to send their best presentation, their best videography, their best photography, and their best scientific drawing. The further announcement will be found in our social media, such like the Instagram, and other social media. Okay, maybe that's all from me. Congratulations again for the winners, and don't forget the winners. All of the students is the winners for us. Yeah, but we have to select who are the best from the winners. Okay, thank you so much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Indra. Congratulations for the winner. And for all the winner, the committee will contact you to distribute the prize. Thank you. Okay, ladies and gentlemen, to officially close our event this afternoon, we are pleased to invite the head of Department Silviculture, Dr. Omar Rusdiana, to give closing remark of ICTS 2021. So please welcome Dr. Omar Rusdiana. The time is yours.
Thank you, Bu Ati. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. The honorable keynote speakers, invited speakers from Indonesia, USA, Japan, Germany, Malaysia, and New Zealand. The honorable Dean of Faculty of Forestry and Environment, the honorable are all distinguished guests, participants, and organizing committee of the third ICTS 2021. Good afternoon, ladies and gentlemen. I believe that during this conference, all of us have intense, fruitful discussion. In this, the third international conference on tropical silviculture, with the theme inspiring silviculture innovation and research in achieving sustainable development goals. We have learned a lot from the keynote invited speakers who have shared their interesting work. And I think once again, on behalf of the committee, thank you for delivering such important material so that all of us can deepen our knowledge about design research. Furthermore, I would like to thank all presenters and participants who have joined this conference from many countries. I think I am certain that every presenter have presented the application of design research and educational research. I sincerely hope that through your presentation and discussion afterward, all of us can contribute to solving the educational problem in our countries, even though the contribution may be small, but it is still valuable. I would like to thank committee's member for organizing this conference and ensuring that it's proceeded smoothly. I would also like to apologize for any inconvenience that you might experience during this conference. And by saying Alhamdulillah, I officially close this third ICTS 2021. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Ormo Rusdiana. Okay, ladies and gentlemen, we now come to the end of this event. On behalf of the host and committee, thank you very much for your kind attention and your participation, and have a good day, everyone. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Indonesia terletak di lintasan garis khatulistiwa yang membentang dari Sumatera, Kalimantan, hingga Papua. Keindahan alam Indonesia yang terdiri dari pesisir pantai, gugusan pulau-pulau, barisan pegunungan, dan hijaunya hutan belantara menjadikan Indonesia disebut sebagai Jamrut Khatulistiwa. Keragaman hutan Indonesia merupakan rumah bagi berbagai kehidupan yang ada di dalamnya.
Hutan perkasa yang dulu menyelimuti pulau-pulau ini sebagian besar telah hilang. Tinggallah bentangan hutan utuh di Papua sebagai pemilik hutan terakhir di negeri ini. Saat ini, hutan digunduli, sejumlah besar gas rumah.
Yang tersisa.
Laskar terakhir.
Oke, laskar terakhir.
Oke, ada dua slide ya, ada dua slide.
Satu naga. Laskar terakhir tinggal panitia nanti. Pak Iwan, kok gebuk amat Pak Iwan?
Iya, ini gara-gara WFA ini.
1, 2, 3.
Oke.
Jangan lupa maskernya.
Slide 2.
Senyum dulu.
1, 2, 3.
Oke.
Alhamdulillah.
Sudah, ya terima kasih Pak Omo.
Baik.
Ya, kapan ke Jogja Pak Omo?
2 tahun lagi kita kalau ada lagi.
Assalamualaikum.
Salam.
Terima kasih banyak.
Selesai gimana Pak?
Wah, sedih ya, satu persatu hilang.
Indonesia terletak di lintasan garis khatulistiwa yang membentang dari Sumatera, Kalimantan, hingga Papua. Keindahan alam Indonesia yang terdiri dari pesisir pantai, gugusan pulau-pulau, barisan pegunungan, dan hijaunya hutan belantara menjadikan Indonesia disebut sebagai jamrut khatulistiwa.
Izin Lip, selamat malam untuk semua.
Ya, selamat malam.
Good evening.
Keragaman hutan Indonesia merupakan rumah bagi berbagai kehidupan yang ada di dalamnya.
Hati ya semuanya ya. Belum di jalan.
Hutan perkasa yang dulu menyelimuti pulau-pulau ini sebagian besar telah hilang. Tinggallah bentangan hutan utuh di Papua sebagai pemilik hutan terakhir di negeri ini.
Terima kasih semua panitia, makasih lah. Sukses.
Lagi Pak. Iya, sama-sama, makasih.
Sama-sama, terima kasih.
Saat ini hutan digunduli jumlah besar gas rumah kaca yang dilepas ke udara, dan dengan demikian mendorong kita lebih cepat ke titik di mana kita tidak bisa kembali ke dampak perubahan iklim.
Ini kelihatan. Mana tadi? Oh, tuh ada palu sih.
Selamat datang di Departemen Silviculture, Fakultas Kehutanan dan Lingkungan IPB University. Departemen Silviculture IPB berdiri pada tahun 2005 yang sebelumnya berada di Divisi Budidaya Hutan, Departemen Manajemen Hutan, Fakultas Kehutanan IPB. Pada tahun 2013, Departemen Silviculture meraih akreditasi A dari Badan Akreditasi Nasional Perguruan Tinggi serta memperoleh sertifikat ASEAN Quality Network Assurance pada tahun 2015. Pada tahun 2016, Departemen Silviculture IPB dan departemen lainnya di Fakultas Kehutanan IPB bersama-sama menerima sertifikat SNI ISO. Departemen Silviculture IPB memiliki fungsi menjadikan Departemen Silviculture sebagai program studi terkemuka dengan kompetensi utama silviculture tropika berkarakter kewirausahaan dan bersendikan keharmonisan. Departemen Silviculture IPB memiliki misi yaitu menyelenggarakan pendidikan tinggi yang berkualitas berbasis penelitian untuk menghasilkan sumber daya manusia yang berkualitas dan untuk menjamin fungsi ekologis, kesehatan, dan produktivitas ekosistem hutan secara berkelanjutan sehingga menjadikan Departemen Silviculture yang berperan sebagai trendsetter bagi masyarakat profesi kehutanan. Departemen Silviculture IPB menjadi lembaga pendidikan tinggi yang mampu mengantisipasi dan menjawab berbagai permasalahan pembangunan kehutanan secara ilmiah dan profesional dengan sistem manajemen berorientasi pada mutu dan profesionalisme. Departemen Silviculture IPB memiliki mandat dan pengembangan ilmu dan teknologi silviculture yang diperlukan untuk membina hutan alam serta membangun dan membina hutan tanaman secara berkelanjutan berbasis ekosistem. Kompetensi di Departemen Silviculture IPB mampu menyerapkan ilmu dan teknologi silviculture untuk menjamin fungsi ekologis, kesehatan, dan produktivitas hutan sesuai kebutuhan dan nilai-nilai hutan yang diinginkan secara berkelanjutan. Departemen Silviculture IPB memiliki bidang kajian yang luas, menarik, dan aplikatif. Sehingga dalam pelaksanaannya, Departemen Silviculture IPB dibagi dalam 3 kajian divisi, diantaranya Divisi Ekologi, Divisi Silviculture, dan Divisi Perlindungan Hutan. Bidang kajian ekologi hutan meliputi hutan mangrove, hutan rawa gambut, hutan dataran rendah, hutan pegunungan, ekosistem das, tanah hutan, nutrisi hutan, restorasi hutan, reklamasi lahan pasca tambang, biodiversitas, botani hutan, dan lainnya. Bidang kajian silviculture meliputi genetika dan molekuler hutan, perbenihan dan persemaian, sistem silviculture, agroforestry, permudahan hutan, mikoriza, rhizobium, bioteknologi kehutanan, reklamasi pasca tambang, biodiversitas, dan lainnya. Bidang kajian perlindungan hutan meliputi patologi hutan, entomologi hutan, jamur hutan, mikrobiologi hutan, hama penyakit hutan, kebakaran hutan dan lahan, kesehatan hutan, gangguan hutan, perubahan iklim, biodiversitas, dan lainnya. Fasilitas yang ada di Departemen Silviculture meliputi laboratorium, ruang kuliah, rumah kaca, dan persemaian. Program Sarjana Silviculture akan meraih gelar Sarjana Kehutanan. Program Pasca Sarjana Silviculture Tropika akan meraih gelar Magister Sains, dan program Strata 3 akan meraih gelar Doktor. Berbagai inovasi telah diberikan oleh Departemen Silviculture yang diantaranya sudah dipatenkan. Jejaring kerjasama internasional Departemen Silviculture meliputi sebagai berikut. Jejaring kerjasama silviculture yang ada di dalam negeri sebagai berikut. Peluang kerja Departemen
Recording stopped.